think we'll start. So, good morning, everyone. I think you guys can be a little louder. Good morning. Right, it's more like it. Welcome to this first edition of the Zak World of Façades conference here in Ireland. My name is Ahmed. I'm part of the organizing team here at the Zak World of Façades event. I'll give you a quick overview of the event before we get into today's action. We started the Zak World of Façades conference back in 2012. It's an event which we started as a small evening cocktail event, and then it grew from one country to another. We've executed around 29 events. We've executed 88 events in 29 countries, so Dublin is country number 29 for us. We plan to be in 33, 34 countries by end of this year. So these are from all across the globe, right from New Zealand up until North America. This event was originally planned in May 2020, and after a point of time I even felt whether we could execute this or not, because we postponed this 3 times. Dublin's been unlucky for us, but finally we are all here. I'd like to thank our event partners for supporting us and our event speakers for bearing with us with the numerous date change. But eventually we are all here. I'd like to thank all of you for being here present in person for this first edition here in Ireland. So as I mentioned, it's a one-day event, as you all are aware. We have 4 sessions. We have presentations from architects, consultants, leading material manufacturers talking on different projects, concepts, solutions on different topics. We have a wide range of topics today. Literally the whole spectrum of facades is being covered by all the speakers in different capacities. The event, as I told you, is spread all across the globe. In the United Kingdom and Ireland region, this is our 5th event. We've had 3 events in London, 1 in Manchester, and this is the 5th one here. So this is the United Kingdom and Ireland Geo, as how we would like to call it. Our biggest one of all the events around the globe is the one in London. We have close to 800 delegates, 700 to 800 delegates attending, and this year it's on the 3rd of November 2022. What's special this year is we have collaborated with the Society of Facade Engineering, which is a chapter of SIBSI, and we would be organizing the Society of Facade Engineering's Facade Awards post the event on the 3rd of November this year in London at the Hilton on Park Lane. It's a black tie only event. It's a prestigious event which has been organized from the last few years, almost 10 years I think, and we have collaborated with them to host their event post the completion of the Zak World of Façades event in London this year. This is what we've been doing. Quick note about us: we've been having a challenging few years thanks to COVID. 2020 was a horrible year. 21 was okay. We slowly got back into action. 22 was on a rocky start thanks to Omicron and other confusion around it, and just when we thought things was becoming okay, we had to cancel our event in Moscow, which was scheduled for end of this month. So as an event organizer, it's been super challenging for us. It's not easy in today's world to organize events all across the globe, across different continents, different language barriers with the travel restrictions. But I hope things become normal and we are back to the happy 2019 days. Getting into the event, we're extremely thankful to our event partners. I'd like to start off with Schuko. Schuko is the presenting partner for the event. They are a German manufacturer, as you all are aware, a leading manufacturer of doors, windows, and curtain wall system, aluminum doors, windows, and curtain wall systems. They've been present with us literally all across the globe in almost all our events. Kingspan Facades, which is a rain screen division of Kingspan, are the powered by partners of this event. Axenoble is a leading powder coating paint manufacturer. EdgeTech are a German company. They have warm edge spacers for double glazed units for better thermal performance. Curare is the parent company of the laminated glass interlayers, Throsifol and Sentry Glass. They're going to be talking on an interesting product which is actually very popular in North America, which is bird safe glass. So that's something which is being used a lot. You'll be hearing from them. They've launched a brand new solution today. Obix are a British manufacturer of membranes and sealing solutions. Proctor Group, another British company, manufacturers of membranes, vapor barriers. Q Railing is a German railing manufacturer of railing and balcony systems. Siderise is a British manufacturer of cavity barriers for curtain walls and cladding. And our networking partner is Pyrobel, which is a fire-rated glass by AGC. So they'll be hosting the post-event networking event later today. So that's it from me. It's a great pleasure to have all of you back here in person. As I said, personally for us, Ireland has been chaotic in terms of scheduling the event. 3 times we've had to do it, and eventually when we got this date, we got a venue which is beautiful. You would have all seen it, but it's too large to our liking. But anyways, we made this happen, so I'd like to thank my team also getting this done. Okay, all of you, all the delegates should have a USB stick on your lanyards. So that USB stick has the brochures and the materials of our exhibiting sponsors, and I urge you to please visit them in the networking breaks. It's thanks to them we've been able to put up this event in a grand style, and they've been extremely patient in us executing this event. So please do visit their booths. All of them have a stand outside, and you can network with them in the breaks. So without taking much of your time, I'd like to call upon today's event host and convener, Stefan Tanno. He's the Director of Pre-Construction Services at Schuco. He's based out of the London office, handling projects globally. So Stephen is our favored and our most popular event host and convener across the globe. He's hosted almost 15, 20 events. I've lost count, but you're in safe hands with Stephen, and he's going to take today's proceedings forward. Okay, so thank you all. Stephen, over to you. Thank you.
I hope you can hear me. I don't know if my microphone is on. Can you hear me okay? Good, good. Well, good morning, everybody, and welcome. My name is Stefan Tanno. I'm part of the global engineering team at Schuco. On behalf of everybody at Schuco and at Zak, I welcome you to this first edition of Zak World of Façades in Dublin. Now, I want to start today leaving all the politics to one side, because irrespective of your political point of view, I think the people of Ukraine deserve our thoughts and prayers today. So in a minute, I'll invite you to stand and join me in a minute's silence and quiet prayer, during which I will say a few words of solidarity with and in honor of the people of Ukraine. So please stand if you can. So at this tricky time with war, we pray for world leaders, for compassion, for strength, and for wisdom to guide their choices. We pray for the world in this moment of crisis, and we reach out in solidarity with our brothers and sisters in need. Not only in the devastation of Ukraine, but in other places such as Afghanistan, Iraq, Syria, and wherever there are people suffering the effects of conflict and war. Thank you for observing this. Please be seated. So, as Ahmed said, this event was scheduled to take place in 2020 and had to be deferred twice because of the COVID pandemic. If any of you feel more comfortable here wearing a mask, please feel free to wear it. Just do whatever's comfortable for you. It's absolutely wonderful that we can at last meet face to face and have dialogue and interaction. This is what it's all about, to share our love and our passion for our work, share experience, share stories, about projects, about developments, and about what we do. As Ahmed said, this event started 10 years ago, and we actually started this event in India, and it sort of grew from there to Southeast Asia. And in those early days, the task really was very much about disseminating essential facade education and know-how. And much to, I think, Ahmed and everybody else at Zak's surprise and my surprise, when the idea came that we would take this event and do it in Europe, we were really not sure whether this would work. But it seems to be that there is the same demand, there is the same hunger for dissemination, for sharing, for learning, and for experiencing and learning from other people's normal work and their project experience. So we did the first event in London in 2017, and since then, as Ahmed showed you, Zak has become a bit of a global phenomenon. Because by having a diverse grouping of developers, promoters, architects, general contractors, specialist contractors, engineers, consultants, material suppliers, we are getting a balanced view on life. We are bringing our perspective, our unique outlook, our specific set of demands, whether it's in design, in technical, in logistics, in cost. All of that comes into the mix, which helps us to see construction through a full 360-degree view. Now, I reserve a special thank you for all of you who are speaking today or contributing in any way, because it takes a lot of effort for our speakers and contributors to prepare and to stand here in front of you and to share their knowledge and share their experience. My motto on life has always been, and I expect will always remain, that there is only one constant in life, and that is change. The rate of change seems to be accelerating faster and faster, that sometimes I feel problems we solved 30 years ago are coming back because people have forgotten the solutions. So in a world so full of information and systems of information sharing, artificial intelligence, and so on, it seems to me that human experience remains the most powerful tool we have. And with climate change and sustainability issues, post-pandemic blues, and a time of war, the changes that are happening in our industry seem to have a much more profound feel to them. The idea of abundant, cheap resources, abundant energy, suddenly seems out of reach. We have to be resourceful and intelligent in how we use materials, how we expend energy in order to save the planet and provide a future for our children and grandchildren. So on to the serious business of today, with major topics on fire, sustainability, high-rise buildings, smart buildings, and on materials and systems of all kinds. Plus, of course, commercial pressures of our price-driven nature of our business. All these topics and more will be covered today, and in a busy program of proceedings. So if our first speaker is ready, and I think he is, we have Pat Duffy from Arup, who will start us off today, taking us through sustainability, exploring current practice in Ireland and looking at ways in which we can reduce operational and embodied carbon. Thank you. Pat.
Thank you, Stephen. The presentation today, my name is Pat Duffy. I work with the Façade team in Arup, Dublin. And the presentation today is embodied carbon and facades, where to now? Climate change, as Stephen mentioned in his, alluded to in his talk there, is one of the most pressing issues that we as society have to address nowadays. Sorry, I'll take off my glasses there. The evidence is clear that our whole way of life is at stake unless we get to grips with the whole issue of excess greenhouse gas in the atmosphere. Just this week, the IPCC issued an update on their constant updated reports, saying that the window of opportunity for actually doing something on this is actually closing for us very, very quickly. The presentation this morning will be a quick run through the issue with an introduction to embodied carbon, an outline of where we are now, and some ideas around regulation. Embodied carbon is the total greenhouse gas emissions generated to produce, maintain, deconstruct and dispose of the built asset. It includes extraction of natural resources, manufacture, processing, transportation and assembly, along with consequent disassembly at the end of life. By comparison with other industries, the built environment makes up 35% of energy consumption and 38% of carbon emissions. These figures are from 2019, but 2020 figures are very broadly similar. Therefore represents a massive contributor to the buildup of greenhouse gases in the atmosphere. When you look at the lifespan of a building, it can be seen that the majority of the embodied carbon has been expended up to practical completion. It's shown there in pink, and the operational carbon in the yellow. So in addition to the up to practical completion, you have significant amounts during the lifespan of the building due to replacement and maintenance, and then at the end of life for disassembly, deconstruction and so on. These are general approximations. The ratios here are general approximation, and they vary from building to building and from component to component within the building. For example, the structure will require little in terms of replacement and maintenance during the lifetime, whereas MEP and facades require a lot more. But structures at the end of their life will require more carbon input due to the difficulties with demolition, etc. The graphic here shows the makeup of the life cycle carbon, and these are extraction, manufacture, transport, construction, operation, refurbishment, demolition and recycling. In other words, the embodied carbon and the operational carbon. In terms of figures, recently published data from the IStructD and CWCT indicate that embodied carbon can be up to 77% of the life cycle carbon in the building. The modules you see here, the A, B and C, are from design to end of life, A being up to practical completion, B is in use, and C at the end, the demolition at the end of life. 50% is to the site gate, an additional 5% then to practical completion. 20% of the life cycle is embodied carbon in use, whereas 23% is operational carbon, and another small amount then at the end. So the balance 23% is the operational carbon. And facades, of this, facades contribute between 10 and 30% of the embodied carbon, and 6 to 20% of the operational carbon. The Climate Action Plan for Ireland, published late last year by the Department of the Taoiseach, sets out a roadmap for achieving an overall net zero economy by 2050. This will be achieved by getting 51% reductions in overall carbon emissions by 2030, which is less than 8 years away. And then, and from that, achieve net zero by 2050. In relation to buildings, they're looking for between 44 and 56% reduction in emissions from buildings. And part of that is the National Retrofit Plan. In terms of resources around the subject, key amongst those would be the Eurocodes 15804 and 15978. The Royal Institution of Chartered Surveyors, RICS, are quite strong in this area, and they have published whole life carbon assessment for the built environment, and this serves as a guide to the practical implementation of the Eurocodes. The IStructD, my own association or institution, is very active in this area, and their document, How to Calculate Embodied Carbon, provides more developed methodologies around the carbon calculations. The CWCT, the Centre for Window and Cladding Technology, have also published data recently around facades, and Arup, like many other design practices, have their own documents around embodied carbon and facades and carbon in general. These would be all based on the IStruct-T and the RICS documents. So where we are now with respect to embodied carbon. Looking at the overall situation, 1.5 degrees is considered the temperature at which we need to stay below if we want to maintain life on the planet more or less as it is now. The Paris Accord in 2016 made commitments to limit that temperature rise to between 2.7 degrees and 3.7 degrees. COP26 held last year in Glasgow made basic commitments to keep that below 2.7 degrees with further net zero actions to get a further 0.5 degree centigrade reduction. So you can see that even with COP26 and net zero, we're still a bit out in terms of keeping life on Earth as it is. So up to 77% of the life cycle carbon of the built environment is embodied carbon. And while decarbonisation of the electrical grid may provide certain amount of relief in this regard in terms of our commitments and what we need to do in construction, if the case of the Derrybrine wind farm has shown, recent case there in Derrybrine where they've a wind farm that was built 20 years ago that now has to be taken down because of planning concerns. If that has taught us anything, it means that renewable energy is not going to be easily rolled out in this country. And there are no regulations at the moment around embodied carbon. Looking at some typical facade typologies in relation to this issue, we have calculated embodied carbon figures per metre squared of facade for a range of facade types as shown here. They range from a standard brick with punch windows, which is 138 kilograms CO2 per metre squared, increasing to over 200 for typical curtain wall types. If we increase the glazed portion or add fins, this can increase up to 245 kilograms, all the way up to 260 for unitised facades with shadow boxes and other features. Double-skin facades can be up to 350 kilograms per metre squared, and precast range from 125 to 200, depending on the size of the windows and so on. If we apply a possible statistical distribution to what we're doing now, it probably looks something like this, where we have a range of facades clumped around an average, with some outliers at the upper end for sort of high-profile buildings. It's easy to, I suppose, point at the grade A offices, the sort of the fantastic buildings we're putting up nowadays, and say, well, look, they're the problem with all the glass fins and the acres of glass and so on. But when you look at what our output in terms of carbon in construction, residential is actually by far the biggest component of our carbon emissions. So every part of the industry has to take action now. Going back to theoretical distributions that possibly may or may not happen, ideally you'd have the reduced carbon emissions would be something like this, where we'd increase our output on the low carbon facades, but we'd still allow the opportunity to build some relatively high profile facades, with a little bit extra carbon in them. But the reality is probably going to be something like this, where we have to reduce our limit, our upper limit, so far that all we're restricted to is the low carbon type facades if we want to get that 51% reduction, which is a massive, massive challenge. The CWCT, in a recently published document, sets out a hierarchy of actions to reduce embodied carbon in buildings, with a build nothing at the top and build low carbon at the bottom. Although huge advances are being made with regard to the development of low carbon technologies in construction, typical among recycled aluminium, that's something that's being pushed on us or pushed by the industry nowadays. In addition, there's green steel coming from Sweden, and even this week there was an article about carbon absorbing plasterboard coming from research in the UK. These on their own will not solve the problem. We need to do far more than that. In a recent Arab project, a concerted effort at the behest of the client was made at early design stage to reduce the carbon content of the facade for modules A to C, all the way up to end of life. This yielded a reduction of 14%. Significant changes would have had to be made to the aesthetic of the building if we were to achieve anything more than that. Achieving 50% reduction would have posed fundamental questions to the architect and planners, but I feel that that is what our future holds. As a reference, Arup have produced a document, Net Zero Carbon Buildings, 3 Steps to Take Now, and it basically sets out a good overview of what we need to do as an industry. And basically it's take the sum down. There's such a dearth of data around this in terms of what we are building. Nobody is actually recording or analysing the buildings we're doing now in terms of their carbon content. And in order for us to apply reductions, we're going to have to address that. So, some suggestions around regulation. As I have already alluded to, this is a subject with many moving parts. Even the 50% target by 2030 and the net zero by 2050 require a lot of analysis and data to determine where we are now and where we will get to along the way. The key issue, as noted, is the decarbonisation of the electrical grid. If major inroads are made here, it might be possible to actually alleviate some of the pressure on the construction industry. Likewise, the development of low-carbon building materials. As they progress and they're introduced into the everyday construction in this country and elsewhere, the pressure will be relieved on the overall embodied carbon. But we need to act. We need to act now. Also, should we have a hierarchy of buildings that benefit what are seen as socially important areas or building types? And for example, this building here, this is a nationally important building. We should have a situation or a mechanism by which we can actually afford to put more carbon into a building like this. And for the rest of them, we need to put pressure on them. Should we penalise buildings that are empty for up to 70% of their lives? Offices, like 9 to 5 offices, close up then and close at weekends and empty for the rest of the time. Should we penalise that in terms of what we allow them to use in terms of embodied carbon? Will reductions in the facade have to compensate for difficulties in other areas of the building? For example, the structure. Gravity is not going to go away, whereas facades, a lot of the embodied carbon in facades is delivering an aesthetic. So that's another question, a policy question. And then, should we revisit operational carbon requirements? The trend for the last 30 years has been driving U values down and down and down. That has come at a cost in embodied carbon in terms of additional insulation and all the follow-on materials that go into a building to get those performances. Is this beneficial overall? And are we ready for the new, possibly new low-carbon architectural styles? Other parts of the world seem to embrace uniformity far more than we do in this country. That's a picture from Copenhagen where they have geometrically uniform buildings, simple facades, brick or solid facades with punch windows. And that's rolled out. There are acres and acres of this all over Copenhagen. In terms of regulations, I would suggest that there's a carbon budget for all new buildings and a carbon certificate on completion. But it would be subject to renewal every year based on carbon usage returns. And like you do your tax returns, buildings should upload their energy use returns and maintain their carbon certificate. And levies for non-compliance. This is such an important issue. We can't brush it under the carpet once the building is finished and we forget about it after that. We need to manage this on our building stock from now on and monitor the building performance gap. Archie is going to give a talk. I've seen Archie there is going to give a talk on the building performance gap. It's an absolutely critical issue in building design at the moment. that predicted energy usage figures can be out by a factor of 2 compared to what's actually measured in service. In terms of actions leading up to the regulations, I would suggest that within a very short period of time, and I'm saying no greater than 3 months from now, all planning applications should incorporate a whole life carbon assessment. This should be mandatory, but without targets for the first year, to build up data on the subject, to allow us to see where we are, allow us to apply reduction factors, and formulate policy for the future. The formulae for carbon budgets should be developed based on that data, taking into account the building type, location, occupancy, etc. These obviously would have to be issued to the industry for comment so that we can all make comments on them. A reduction factor applied to the data and the regulations then from mid-2023 on, there's no reason why we shouldn't have regulations around embodied carbon in this country from the middle of next year on. And they will be updated on an annual basis, taking into account the additional data that we get from on a year-to-year basis, plus decarbonisation of the grid, and also monitoring what's happening elsewhere in the world, because this is a moving target. Work has already been done in the UK around what they term as Part Z, which is a sort of a hypothetical document produced by industry around whole life carbon in buildings. We need to do something like this, or adapt what they have done. In terms of facades, some suggestions may be to reduce carbon, use more timber. This is a difficult question, really. Timber is an interesting one because you're cutting down something that's actually absorbing carbon and taking carbon out of the air, and you're stopping that process. So there are issues around that, and mainly got to do with the life of the component. If it's going to last a long time, then it is a benefit. If it's going to be a short life, and we're talking about less than 40 years, then it's questionable whether that is giving us the benefit that we might expect. The I/D have done a lot of work on this recently, and they have issued they've issued a paper recently around the subject, which is worth looking at. I mentioned recycled aluminium, which most people are familiar with. Also in relation to green steel and the plasterboard, which I found very, very interesting, because that's a huge industry, huge user of carbon, and activity around that would be fantastic. Just this week, there was, in relation to the carbon-absorbing plasterboard, these and other low-carbon initiatives will be an essential part of the ultimate solution to this problem, but they're not going to do it on their own. We need to consider the optimization of high-carbon materials such as glass. We also need, in relation to glass, to assess lamination and fritting and why we use them and where we use them, because they are a barrier to effective recycling of the material. We need to think our whole approach around U values, I mentioned before. The large ratio between operational carbon and embodied carbon is in part a result of the trend downwards in U value. So the proportion of both has changed, but also we have had to add increasing material or increased amounts of materials in the building. So that has actually skewed the relationship as well. And with decarbonisation of the grid, when electricity is actually renewable, would it be more beneficial to actually relax U values so we don't have to put as much into our walls? As an industry, we need to consider the circular economy. Arup has recently launched a circular economy toolkit, which is accessible to the public. And I would encourage you to log on to that, register, and see if it can be assistance in your projects moving on to the future. Are we entering into an epoch of low-carbon architecture? I think so. I hope so. I think that's the only solution. And finally, we need to keep our existing buildings in service for longer. Like, far too many buildings have been demolished in Dublin in the last 5 or 10 years. With no thought really for embodied carbon and the additional carbon we're adding to the environment because of the replacements. We need to reconsider that. We need to get stronger in terms of what we demolish. So what you all need to do, everyone in the industry needs to upskill. on this subject. The resources are there. Get reading, get involved, get aware of this. Even in the absence of regulation, as designers, we all need to have conversations with our clients around this issue. And we need to start carrying out life cycle carbon assessments right now on our buildings with the agreement of the clients. I think there's a huge risk out there. I think funders, when they cop on to what is actually going to happen on the buildings, they're going to view the risk in a far different way. So that's coming down the tracks, I feel. And as an industry, we should demand action from our government around regulation. The Climate Action Plan was very good, but I think we as an industry need to get more involved in that and actually steer that around to a place where we are comfortable. We might not be comfortable describing it now today, but I guarantee you, we need to be, in 10 years' time, we need to be comfortable around what this means for us as an industry. You know, an easy one there is EPDs. You know, they're out there for most components we use in buildings. They should be mandatory in all contracts now, and we should review them and make sure that they are aligned with what our idea of embodied carbon and the reduction of embodied carbon is. And again, I mentioned the circular economy toolkit. There's a snip of that. There's a link to it. You might be able to see that. But if you do a Google search for Arab embodied carbon or circular economy toolkit, you'll get into that. It's really, really interesting. So that's it. Thank you very much for listening today. Thank you for Zak for having me here, talking about a topic that's really dear to my heart, and I hope is dear to everyone's heart here, because the future generations really depend on us doing something about it now. We don't want to be the people who did nothing. Thank you.
Pat, just stay for a minute. I hope you can hear me better this time. First of all, thank you so much, Pat. That was really, really good stuff that you talked about and talked so passionately as well. I know we're a little bit pressed for time, but I have one question for you. I'm sure other people will have lots of questions as well during the break. But the question that I have, you talked about carbon budgets and carbon certificates, which means we have to be quite accurate in how we calculate and how we present data about new developments.
Yes.
Do you see in the general marketplace right now an accurate way in which people can present their data on carbon calculations? Are there tools that you're able to use?
There are tools, yeah, absolutely there are tools, but it's a much different thing, obviously, making a calculation on a building and presenting a figure and having that in a certificate and saying that you have to hit that target every year. So we're going to have to develop our tools much, much better. The implication of the first one is that the slack is taken up by the environment.
Yeah.
So we need to change that. We need to be responsible for what we build. It's going to be difficult. We're going to have factors of safety in carbon, like we have in structures.
Yeah.
So that is going to be the way that we save ourselves from the being caught for having just around a couple of decimal places out or whatever it is. Yeah. I see there's a lot of work to be done. There's a lot of work out there. The I/D are very, very strong, and I brought that up. There's an article in the March edition of the I/D by my colleague Will Wild about embodied carbon and operational carbon, and it's definitely worth a look. It's a basic run-through, not quite what I have said, but a basic run-through of the issue. And we need to start informing ourselves much, much more on the subject.
Great. Thank you very much.
Thank you, Stephen. Thank you very much.
If anybody has any questions for Pat, you can catch him in the break and have a chat. I'm going to move on to our next speaker. It's Ronan Phelan from Scott Talon Walker Architects. Ronan's going to talk about sustainable development of a mid-century modern building, but hopefully will illustrate other case studies as well. And that all fits into the theme of reuse of existing buildings and finding adaptations for them. So over to you, Ronan.
Thank you very much. So I have two projects to show you, so I'm going to move a little bit quickly. So the first project I'm sure you're all very familiar with is Museum Plaza. Museum Plaza is the renaming of it's the redevelopment of the former Bank of Ireland headquarters on Bagot Street. So the interesting thing about this project, I think, in the context of sustainability, is that these mid-century modern buildings, which are designed in the 50s, 60s, and 70s, are now over 50, 60 years old. And to my mind, these are the classical buildings of the modern era from an architectural standpoint. There are many fine examples, and they're well worthy of renovation and restoration. And if properly done, I really believe this can be the most sustainable approach. For no other reason than that you take advantage of the embodied carbon in the buildings, as Pat spoke about. So obviously that's a challenge because of changing work practices, and in terms of office design, the tenants and clients are looking for different things. There are much higher expectations in terms of client comfort and tenant facilities. And obviously improving the performance of the building and improving the ongoing sustainability of the projects makes the preservation quite a challenge. But I think hopefully this project will just demonstrate how that can be very successfully done without impacting on the architectural character of the buildings. So the former Bank of Ireland, Bagot Street, was designed in the 60s by Scott Tanno Walker Architects, by Ronnie Tallon, and it was built during the 70s, as is evidenced by the style of the cars in the photograph. Then about 2011 it was listed as a protected structure by Dublin City Council, and what was listed was the exceptional external bronze facade and the public plaza, which is, so the facade and the spaces in between. In terms of redevelopment, our goal and our brief, if you like, was that this building will be, it wouldn't be a refurbishment or a renovation, it would be really a redevelopment, and no stone would be left unturned in terms of turning this into a project that was as good as, if not better than, any modern office building that was being built at the time. And we did quite a bit of benchmarking in terms of the quality of offices and services and things that were being provided at the time. Everything was to meet current standards, all of the current building regulations. There was to be no quarter given in terms of looking for little bits of forgiveness in terms of Part L compliance and that kind of thing. So since the facades were protected, but the interiors of the building weren't, so that allowed us to remodel the cores. So we worked in the front two buildings there, that's Bagot Street. We were able to remodel the cores, strip out all of the services, and put in more modern facilities, working mostly within the structure of the core in the smaller block, enlarging the core of the square block to give a very efficient floor plate. We made much more significant interventions into the cores of the larger block, which is the 9-story building that sits upon the podium. The reason for that is you can see it had actually quite a narrow floor plate in a time when there was much more cellularization in terms of offices, 6.5 meters deep, 6.5 meters there with the open plan at the ends. But in terms of trying to get a little bit of value in terms of the redevelopment, which developers and clients are always looking for, and also in terms of trying to get a better office space, the plan was to take the bronze curtain wall off the rear there and literally just move it out one structural bay, bang, like that, and then to remake bronze curtain walling exactly as per the originals to fill in the two ends there. So that gave us a super deep floor plate, 50,000 square foot of pure net lettable, which was a kind of an economic driver in enabling us to be able to fund the rest of the project. So just in design terms, this is the building before it was extended, and the idea was that we would just move it out one structural bay and it would look like it was always there. So that is before, and then bang afterwards, and there's really very little difference. It does look like it was always there, and the planners had no issue with that in terms of the protected structure. So, that's right. So in terms of the section, in terms of renovating these older buildings, working the section is obviously really important. We were fortunate in that we had 3.6 meters floor to ceiling, so that was an advantage. We were able to get our 2.7 just over 2.7 metres tile to tile. There was a structural, there was a non-structural screed there that had the trunking and everything cast into it and floor boxes, and we removed that to be able to put in a raised access floor, which gave us better services distribution, but also interestingly that removed a load off the structure. So when we recalculated the structure, we were able to demonstrate that it complied with the new loadings for a more densely occupied office space. And that gave us quite a neat office space internally. Okay, facade conference. I'm going to start talking about facades. So what was protected, well, the Bank of Ireland was designed with a lot of regard to the Seagram building in New York. It has these very fine external bronze cladding, these external bronze extruded ribs, bronze spandrel panels, and these bronze body-tinted glazing. Now, the double glaze, it was double glazed, but it was super thin double glazing, 24 millimeters thick, 6 mil body-tinted bronze, air cavity, and then 6 mil annealed internally. They're 40 years old, so they were all breaking down, but also the annealed glass didn't provide the barrier loading on the required, so all of that had to be upgraded. Very little insulation, if any, except in spandrel panels, which had that wonderful material of the loved by the 1960s called asbestos. So obviously that wasn't a great idea either. But other than that, no insulation. So freezing in winter, roasting in the summer. And effectively, we measured on the south facade, on that bronze facade internally, because it's bronze internally, at the height of summer, 80 degrees. So it's like a big radiator in the summer. So how to upgrade that to modern standards? Well, part of the step was to ask our friends in Arup how to do it, and Pat's team. So we worked very closely with Arup in trying to figure out how to upgrade that curtain walling system to a modern standard. So on the left there is the original with that beautiful extruded eye section. It's bronze extruded frames to all the glazing. That's the double glazing, and then internally a very simple fixing system. It was an internally glazed system, and then that U-shaped mullion cap that is the internal expression of the external mullion. So what we were able to do was to keep all of the original bronze window frame exactly as it was, and the external mullion, upgrade the double glazing to a more higher performance double glazed unit. In fact, we did quite a lot of tests on the units in order to make sure that we matched the bronze color of the original. We did 9 full-scale mock-ups on the south facade in terms of being able to pick what the best combination of the position of the bronze body tint and the reflective coating, and choosing the right reflective coating, whether it be Saint-Gobain or Pilkingtons or whatever, that gave us the best color. Then internally, we replaced all of the bronze internal elements with extruded anodized aluminium to match the color of the existing. And the reason for that was that we were able to get in some insulation at the back of the mullion, proper thermal breaks and gaskets and seals. And that gave us like a totally modern construction, in that now we have a fully drained 2-stage waterproofing system where water is allowed in here. There's an EPDM, then it drains out, and then you've got your second weatherproof barrier back at this point. We managed to keep the sight lines as before, 169 millimeters wide, and we extruded the pieces to match the internal profiles of the existing. We tried to keep some of the bronze internally, but it ended up really just as tokenism in the end, and we abandoned that idea. Even with that, that wasn't quite enough to meet Part L, so we had to also rely on internal motorized blinds. Those blinds are linked to a BMS on the roof, and they track the sun in 3 stages throughout the course of the day. They have kind of three movements where they close as the sun comes around, then at midday they go up, reset, just so that all the blinds remain aligned, and then they come down, and then they continue to track the sun throughout until the end of the day. Then they go up so that you can see into the building. They had to be painted white on the top side so that they would reflect the light outside and the heat outside, but we kept them bronze colored internally there so that when they're in the closed position, you still got that nice bronze look to the interior of the elevation. Additionally, just in terms for occupant comfort, but to get rid of that sort of downdraft that you always get next to full scale floor-to-ceiling glazing, we put in a very simple linear radiator along the edge of the glazing, and that gave us quite a nice detail up against the edge of the glass. We got an extruded aluminium piece there that supported the blind, so all of that worked out quite well in terms of the internal view. So the only way of doing that was we took every stick of curtain walling off the building. Architectural aluminium rose to the challenge of refurbishing the facade. Everything was brought back to their workshop, deglazed, stripped out all of the ACMs in a controlled environment, shot blasted all of the metalwork, repatinated it, and reglazed it. Even though every element was, in theory, exactly the same, we were conscious that we were taking elements off a 50-year-old building and expecting them to go back seamlessly. So it was almost like a conservation project where you have to number every stone. We numbered every single window, and everything came off and went back on in exactly the same place it was before, just in case things had moved a little bit in some way that we weren't aware of. So the whole thing then went back on the facade almost like a modern unitized system, with just some of the cappings and pressings being added on internally afterwards, which we were able to do because it was an internally glazed system. So that's how the facade finished up internally. You can see we got the same profile, the same expression there of the external mullion, albeit in the anodized aluminium, and that's the radiator grille and the little channel, and you can just see the cables for the blinds coming down there. So that all worked out very neatly. On the corners of the building, because we have these fully glazed corners, and complying with the instruction that we had to comply absolutely with every element of Part L, and if we wanted to put an office on the corner, we had to design a way of doing it. We decided to do a twin wall system on the south, west, and east corners. But obviously we didn't want, and we couldn't change the external experience of the facade. So what we did was we kept the external double glazing there with the blinds all in the same position, and we were able to just cut the legs off, the downstand legs and the upstand legs off of the original bronze curtain walling to get a ventilation into this cavity, and then put a simple double glazed unit internally, and then we had to do a little bit of weathering and drips and seals and all of that kind of thing internally. That went through a full CFD analysis just to make sure that we were actually able to rid the heat in that cavity. And you can see there that was the final build-up with the bronze body tint on the outside and the Pilkington coating on face 3 on the inner, and then it's two laminated panes across an argon cavity with no toughened glass. So internally, then that's on the corner. You can see that's the single skin turning into the double skin. So visually, it's all very similar. And externally, you can't see it at all. So we're fully complying with the requirements of not changing the external appearance of the facade while bringing it up 100% to modern standards. The ground floor glazing, similarly, we had to upgrade on the podium. It's 6.5 meters tall. It was reinforced by a steel post, but interestingly, when we tried to that post was fixed into the ground, it actually rusted and rotted away quite a bit, so we wanted to just swap them out, but we couldn't because it was an imperial dimension, and the bronze pressing fit super snug onto the pressing, so in the end we just had to kind of get in, cut them off, and repair the legs in order to keep externally the bronze pressings, and then internally we came in with a new curtain with a new aluminium thermal break piece to hold the glazing in place, insulated the back of the mullion, and made a bronze extrusion to the rear. We had to simplify that in order to get around to fully insulate that mullion. So we were about 10 millimeters wider in terms of the vision panel, so about 9 millimeters on each side, but you don't see it externally. And that's how it finished out internally. The other thing we did there was originally that the smaller unit was at the bottom. So you had a kind of a 2.1 high door into the building, but at the main entrance we wanted to create a kind of a more modern 3.5 metre high entrance. So we just turned everything upside down, really, and that worked out pretty well. So we have the taller unit on the ground floor, and then we were able to get our big double, almost full height entrance drum there, which clients and tenants expect coming into a modern building. So in terms of sustainability, then we did a whole bunch of other stuff, of course, in order to achieve our sustainability goals. But the US Green Building Council were very supportive of this because they've quite a few buildings which are gas guzzlers in the States, which are quite similar to this. So they were very interested in how we might upgrade it to meet modern standards. And with their help and doing a whole bunch of other stuff that I don't have time to go into here, we achieved a LEED Platinum version 4 rating for the entire building, which was the highest standard available at the time, and I think it probably still is. Other thing interesting, that's in terms of the podium under the building, that we had all this plant. This is the size of the ducts. It was a real gas guzzler of an all-air handling system. All the plant in the basement of the podium, pumping air, fully air-conditioned air into all of the 3 buildings, which is absolute madness. But we were able to clear all of that out. That's the plan of the podium. By clearing out all of the plant, we actually gained 1,000 square meters of net lettable space, which we were able to turn into tenant facilities and bicycle halls. And we accessed that from St. James's Place East. So you actually come in at grade, in with your bicycle or into the gym, and then you can access the building or the plaza. So we were using, I suppose, the design of the building in the 70s that no longer fitted the 21st century to give the 21st century offices the best tenant facilities that you might expect. So really justifying the refurbishment and renovation of it. And that's the entrance to James Place. So we're getting these kind of spaces with natural light coming into the gym and the tenant facilities, which really makes them very, very usable and desirable. And this is the organised core and the main entrance of Block A. When it was a bank, there was a gallery at that public gallery at that end, and we were keen to keep that kind of openness. So we actually moved this. The lifts are here now. They were originally here, so we demolished them and moved them to here, which created an entrance foyer. There's a restaurant. This is all the Department of Health are in this building now with a restaurant there. You can actually go in and have a cup of coffee. And there's a town hall building on space on the other side. So the entire ground floor you can walk in, and it is usable to a greater or lesser extent by the public. And that's just a night shot of the refurbished facade in the end. So when we were doing this building, we were also doing another project for another client, Green Property, on Harcourt Road. So Harcourt Road is the top of Adelaide Road is here, and then you've got Harcourt Street here at the top of that, and the Lewis comes around here. So while we were working on Museum Plaza, I've always been interested in the idea of that very nice expression of the external facade stiffener, and wondering could we actually do a modern version of that? I thought Pat was going to spoil my presentation talking about fins stuck on the outside of buildings, but the idea was to do it in a meaningful way so that the external fin was actually structural, and it's saved on the material on the inside of the building. So for this project, which is quite interesting because it's kind of a long, narrow plot. There's buildings on this side, so we couldn't get glass on this side. And there's quite a narrow road along here. So we needed, the next drawing is probably best, apologies, a rotated plan. Okay, that's Harcourt Road now. So this is the narrow road. So we opted for a saddlebag core with all the core on the side where we couldn't get natural light. Gave us a 10.5 metre deep floor plate, all very good. But then to get the right amount of daylight in, that all needed to be glazed. But because of the urban environment here, we're getting a lot of west sunlight here and on the south. So we needed for that section a twin wall system if we wanted to get the daylight we wanted and meet the thermal performance that we wanted. So the idea was then just to take, if you just imagine a standard curtain wall system with the mullion and the glazing system, and you just turn it inside out and put the mullion on the outside. So this system designed again, we designed this I think in a morning with your colleague Anthony, our facades, us saying, look, this is what we want to do, and Anthony kind of working through it with us and figuring out how we could actually deliver it. So what we wanted to do, that's inside and that's outside, is to have the mullion outside, minimum glazing inside, which gives you a nice clean floor plate, and make that structural. So that's all quite neat, gives you a very nice architectural definition. But then, since that, we've made that structural, when we want to add in a curtain wall, we just bring, not a curtain wall, but your twin wall. That mullion can take the loading of the twin wall, so you have the twin wall coming in, and it is supported structurally by that mullion. And that generated a thin skin twin wall system. So I think we're less than 300 mil, 287 mil from there to there. And then we thought, well, wouldn't it be even smarter if we were able to do this as a unitized system? And then that would be a really modern system and a modern interpretation of that mid-century 1950s architectural expression. Okay, so then what we did some sketches. We went out for to tender. Alucraft came back with a really good proposal. They found a system that they could adapt, the Huick system, and that's the original Huick system on the left here, which is a standard unitized system. So you can see the mullion in behind, your thermal breaks, and then whether it's a glass or a spandrel panel. So by taking that Huick system, which had already come with its gaskets and its seals and all of those approvals, we just modified that by making that bit longer, and then kind of doing something to the glazing to give it a little bit of stiffness internally. So this was the proposal in the end. You have these external fins. Because they're kind of skinny, they had to be reinforced with a steel plate inside them, which gave them that extra little bit of stiffness. So they're 140 millimeters deep. And then minimum framing for the glazing internally, only 65 millimeters. And then, of course, you get your thermal break along here, the double glazed unit, and these kind of modern, really solid thermal breaks along here. Working with a unitized system as architects, you have to accept you're going to have these kind of 24, 25, 27 millimeter joints. So we wanted to kill that joint at the mouth there by adding just a square box section extrusion that would run up the facade, that would give us a nice clean line. And just by fixing that simply to one side or the other, that didn't connect the curtain wall system together. At the stack joint, I'll show you what we did later. But that box there is pure decoration. The rest is all structural curtain walling. So then when we came along, this is the final design prior to construction. You can see how it developed, and that's the thin skin twin wall system coming in and being supported by this external mullion, and then when you don't need it, it just peels away and you have the single skin system. Double glazing on the inside, single pane on the outside. Because it's thin, we didn't want big windows on the inside, so that actually opens inwards. I presume that's telling me I'm going over time. The vision line there, we tried to keep with the framing of the external door. We didn't quite manage it. Again, we're 10 mil beyond, but we just brought the glass in front of it and silicone bonded it and fritted it out, and it all still looks very seamless. So we did have to go through a CWCT test, which obviously clients are a little bit nervous of, but BAT had just started doing that in Wexford, so we were able to do it a little bit more cost effectively. You're all familiar with those things. You set it up, we set up both situations, and then you have the box in behind. You can go in and look at the seals and test vary the air pressure and all of that kind of thing. I think that actually does something. Does something, and then you test it, and it all passed. In fact, the most interesting thing that came out of that was the operation of the external window, and we did have to actually upgrade the stiffness just so the thing didn't kind of fly out at you. And then the blinds are maintained outside from a cherry picker along the road, so it's all quite simple. And then internally, this is during construction before it got filled with furniture, but you can see that internally you got this nice smooth skin with just a 60 mil frame inside. In fact, when we designed it, the agents were measuring to the framing, So we were able to argue that we were actually getting more net lettable because we didn't have the mullions inside the building, and then they went and changed the methods of measurement before handover and measured to the dominant face of the glass. So we lost that little argument, but it gave us a very clean finish internally. And that's how it finished out. You got this very nice, sharp, crisp mullion, and the twin wall coming in here, nice and smooth, and then it peels away on the north face, which is on the city side, to give us that nice vertical expression. Again, like, we accepted that there were these 25mm joints, stacked joints at every level, but we sleeved just internally. We got an aluminium plate in there, and we just sleeved the two of them together, fixing it to only one side so that we didn't see daylight in between the joints. So, final thing, only take 1 minute, that the stair core, we have this very sculptural stair on the street side, which we hope people will use and add a little bit of dynamism to the street, and we want to do that as glassy as possible. So the idea was, it was a version of what we did out in Point Village on one of the stairs, which I think originally probably Wood Street, Rogers building in Wood Street used that kind of strategy. But we have a single column going from basement up to roof, which picks up a big steel beam truss at the roof level, and that sits back on here on a couple of legs. And then from that truss, we're suspending cables, which carry just a horizontal T-section, and then the full-height glass panels are toggled into that T-section. So you just get a horizontal line and then a glass-to-glass joint on the vertical. And then the staircase is supported by the column, so it doesn't touch the glass, so it's all very clean and neat and light. Again, this is one of our sketches. So that's the cable coming down here, picking up that horizontal T in section. And then everything working in concert, that's the edge of the stair. And we were able to clamp that back to the edge of the stair just to give a little bit of stiffness, just because it was getting a little bit wobbly in the middle. And so the stair and the glazing and the cabling all worked in concert to give us a very light finish. Not super photographs internally, apologies, but it does give you just an idea of the cable coming down, picking up that horizontal T, and then the glass-to-glass joints toggled off that. Again, using everything, we were able to prop the external handrail off the cables, which gave us that nice sort of engineered bracket there, nothing attached to the glazing, and the stair kept away from the glazing because it's spanning towards us to the column. And then just to fill that, we fill that gap just with a steel rod to keep the gap down below 100mm, and that gave us a very nice, light, clean staircase onto Harcourt Road. So that's it.
Thank you very much, thanks. Ronan. Great example of recycling on the first project that Ronan showed us, cleaning up materials and reusing them. That was a lot of craftsmanship went into that, I'm sure. I'm going to move us on to the next speaker because we are a little bit tight on time. The next speaker is Emmet Carolan from Kingspan. Of course, we need typology of buildings. Pat mentioned it in his presentation that we need to develop typologies, and those typologies need to be of a good quality and repeatable. So maybe manufacturers such as Kingspan can play a role in that, and I'm sure we'll hear a bit more from Emmet.
Definitely. Thank you very much. Thank you very much, ladies and gentlemen. As I said, my name is Emmet Carolan. I'm the Regional Commercial Manager for Kingspan Façades here in Ireland. Just to give you a bit of background, I suppose, on Kingspan, if you're not fully aware of the company, obviously quite a big brand name within Ireland. Started off in my hometown in Kingscourt in County Cavan in the late 1960s to 3 people, as all good Irish companies do. Started off in the back of a pub, manufacturing steel products, to where we are now with around 16,500 employees worldwide. So quite a big success story for Ireland. The facades element of it were unique in terms of we basically supply a full through wall system, everything from the SFS to your insulation layer to the actual facade on the external. Which brings into what I'm here to talk about today is, so our pathway to net zero carbon building, and this is kind of from a manufacturer's point of view in terms of what we are doing. So we'll look at the here and now in terms of what the regulations are, our NZEB requirements, etc. And then we'll look at an envelope-first strategy. So it is our kind of means of delivering a net zero building. Okay, so if we look at things work. So the RAI 2030 Climate Challenge, basically, they said we must act now ensuring that new and retrofit buildings deliver net zero whole life carbon as soon as possible. And I think that's been reiterated in our first two speakers. The importance of getting this right in design at this stage for buildings which are going to be delivered from 2025 essentially onwards is extremely important. So as you can see, the net zero is currently broken down into two definitions. So you have net zero carbon construction and net zero operation energy. So when we look at the net zero carbon construction, when the amount of carbon emissions associated with a building's product and construction stages until its practical completion, this is where we've focused a huge amount of energy in developing products which are reducing the amount of carbon associated with them. And I'm going to take you through how we actually do that and what that results in with more thermally efficient buildings, energy production on site, is a lowering of the net zero carbon from the operational energy point of view. So these are taken from the UK Green Building Council definitions, who are yet to officially define whole life or net carbon. So when we look at this, so net zero buildings should be looked at in the totality, accounting for operational energy, embodied carbon, water consumption, and health and well-being. So reducing the amount of carbon where possible and then offsetting it. So operational energy, looking at how much it's taking to heat, to cool, to light the building. The embodied carbon within the actual products that we're using, whether it be the structural steel right down up to the insulated panels to the facade system. Water consumption, managing water systems, managing our wastewater, reusing it, recycling it, managing rainwater and utilising it, and then obviously focusing on the health and well-being of our actual staff and personnel using these buildings. So when we look at the targets and regulations that are in place, so the III Climate Challenge targets the following 4 key areas, which you can see here. So reducing the operational energy demand as far as possible before offsetting, reduce embodied carbon, which is where we focus on in terms of our products, and I'm going to take you through what we actually do and are doing to reduce the amount of carbon within our products. Reduce potable water use by at least 40% and achieve all core health and well-being targets. So in end of 2019, obviously the NZEB requirements came into effect, which have been fantastic in terms of enhancing the minimum requirements. So if we look at a 60% improvement for energy efficiency and carbon reduction, so essentially what that means is if we're dealing with a commercial building for a pitched roof, which is any roof above 10 degrees, they have to comply with a minimum U value of 0.16. So essentially in our terms, that means using a 115mm insulated panel. We look at a flat roof, anything below 10 degrees, that's a 0.2 U value, and then walls are down to a 0.21. It also focuses on the renewable energy contribution, so that's on-site energy production. Depending on how thermally efficient your building is, that can drop from 20 down to 10%. This can be achieved through the means of photovoltaics, through solar or through wind turbines, through geothermal, heat pumps, etc. Improved fabric specification. For us, this is probably one of the most important things to come out of the NZEB regulations or requirements. When we talk about fabric specification, it's essentially how every element of the construction comes together. So where we're dealing with a pitched roof coming down into a wall, how that junction is managed, maintaining the thermal line behind your detailing. This is a really important one from a design stage, obviously, which usually will be fully in place, the correct design, following the thermal line through from, say, into your floor slab right into your wall. When it comes to on-site, and I suppose it's up to ourselves as manufacturers, where we go out to field service, up to main contractors, and also the architects, to look at ensuring that it is actually happening on site. We do a lot of field service work. We go to site, you see junctions which your thermal line has been broken, you have thermal bridging. It's an extremely important one that should be followed right the way through, from design stage right the way to completion. And then we have the major renovation performance requirements to lower energy consumption. So that's through, say, utilising LED systems, using better, more efficient heating systems. So understanding the landscape that we operate in is naturally very important. So what I'd like to do now is just a quick video just to show how Kingspan Façades products can assist in achieving a net zero building. The facade you're looking at here is one of our products. So it's a dry design cassette face fixed onto a carrier panel. So a carrier panel is a quad core insulated panel which forms your air, water tight and thermal line. And then this facade is essentially face fixed to it. So I'll just play this quick video now. Hopefully it doesn't come on too loud.
The built environment is a major contributor to global carbon emissions. By tackling operational energy consumption, we can move towards a net zero future and slow the effects of climate change. The first step to making this change is to use a fabric-first approach. Kingspan's quad-core insulated panel technology uses the most thermally efficient insulation in the industry. The next step is to insulate and generate on-site from renewable sources. Tomorrow, the built environment will have buildings that are adaptable, buildings that use materials with smaller carbon footprints, that are easily disassembled and reused at the end of their first life. And we are committed to developing zero carbon technologies and services that will facilitate your net zero journey with us. Join us today for a more sustainable tomorrow.
So if we look at how we aim to accelerate the net zero or net zero buildings in partnership with ourselves, we have a kind of couple of key things which are in place at the minute. So a reduction of operational carbon through the fabric first. So the use of high performance thermal insulation, which as seen in the video there, we can achieve U values as low as 0.08. Obviously using a quad core closed cell insulation foam. We look at superior levels of air tightness, so compared to other solutions, right down to 0.5 and below. Industry standard previously would have been around 5, it is now 3, obviously in line with NZEB. And then the reduction of energy load, so by using higher performance thermal panels on your roof walls, around junctions, we end up with buildings that require less heat, less operational energy being pumped into them, less cooling, less, if we look at cold storage, less cooling for freezer units, etc. If we look at the insulate and generate products that we have, so Power Panel recently launched the end of last year. This is an insulated panel essentially with a photovoltaic system pre-attached to it, comes out to site and can be immediately fitted onto your structural steel. So it has the benefit of both having the quad core insulation and also its own energy generation. So looking at how we can maintain temperatures internally, and then anything that needs to be, any energy that needs to be used, that we can generate it on site ourselves. So in Kingscourt, at our facility, we just installed around 7,000 metres of this material, and it's just been actually put into the operation this week. So we're also working with a number of battery suppliers, so Tesla and a number of other battery manufacturers, to work on how to store the excess energy that we're producing. So as you can imagine, 7,000 metres of PV produces far too much energy during daylight hours, even in Cavan. What we're doing is working on how we can use that. We operate 24 hours a day, and how we can utilise that energy into the nighttime hours. Enhancing our circular, so we mentioned, it was mentioned earlier on, the circular economy. What we're doing is introduction of packaging take-back schemes. This is already in operation across the UK and Ireland. What that means essentially is the packaging that our products come out to site in, the polystyrene, the plastics, the pallets. What we do is supply take-back schemes, so skip bags, etc., and everything can come back to our factory, if possible, be reused for further packaging or recycled in the correct manner. The introduction of the panel take-back scheme, it's been used in the UK primarily. As I said, we recently re-roofed our own facility in Kingscourt, and we had a queue of farmers collecting the panels that we were taking off, which were actually manufactured in the 1970s. So every cow in County Cavan is well insulated at the minute, where they used all our old panels. I don't think that'll be a huge uptake in Ireland, but the facility is there. What we do is we take back the panels, that are used, say 40 years later, take them back, we strip off the steel, have it fully recycled, and then the foam is ground down. Zero manufacturing waste to landfill by 2030. That's already been achieved by ourselves in the UK and Ireland, and we're rolling that out across our global network of facilities. More sustainable and reduced packaging. So this is a constant for ourselves, looking at sustainable packaging options that are biodegradable if they ever do end up going to landfill, that they do biodegrade, and then just reducing the amount of packaging that's actually used. We're also working on, which is being delivered at the minute, is low carb insulated panel range. So it's through the use of recycled plastics, which I'll take you through. So if we look at it on a journey map where we were in 2019 to where we are, which is our target at 2030, we look at Planet Passion target of a 50% reduction in carbon intensity in our primary supply partners. So this is setting targets for our supply partners, which are, say, our steel suppliers, our aluminium suppliers, our chemical suppliers, plastic suppliers, and setting targets for them to reduce their carbon intensity, which we've implemented already, and we're seeing a huge reduction being driven by other areas within the market. Drive to generate renewable energy on our manufacturing sites. As I said, Kingscourt has the PV generation. Hollywell has a large PV or a large wind turbine, and then our facility in Sherburn has the second largest PV array in the UK. Packaging take-back schemes, as I mentioned. One of the key ones which carbon is associated with is steel. So obviously an insulated panel has insulation foam with 2 sheets of steel either side. Steel has been one of our key targets in terms of reducing carbon. So we've moved already to electric arc, so EAF steel, which is up to a 22% reduction in carbon intensity compared to the standard, which would be a basic oxygen furnace in terms of the production of steel. So this is in steel mills, how they actually manufacture it. You'll see further down in our map, we look at using the H2 green steel. It was mentioned earlier on, a company in Sweden, which we've been one of the key investors in, are using hydrogen now to actually to manufacture steel, which again helps us in terms of the recycled content that you can put into that steel, and obviously the energy associated with generating steel. We'll look at carbon neutral bio-content packaging, biodegradable. Another key one with the low carbon is the use of RPET polyol. This is a really, really exciting story. We work with a company called Ecolaf, basically in the Mediterranean, where they remove plastics from the ocean. This plastic is then broken down. We just detract the chemicals that we use within our insulation foam, and then we produce panels using that. Extremely exciting that you can tell a client, in your building, we've recycled 280 tons of material from the ocean to produce the panels that are now giving you a high-performance insulated building. And then we look through into the H2 green steel, and then into new product features, which we're using biodegradable material for the panels. Our Planet Passionate report came out this year. I won't go through every element of it, just won't have time. It is downloadable off the website just to see what we're doing and what we've achieved to date when this started back in around 2015, and what we're doing as we kind of progress through. So when we look at the envelope first strategy, what I'm going to take you through is basically how we see the ability to enhance buildings. I'm going to show you a building which is our Icon building, which is located in Kingscourt in County Cavan. It's our global headquarters, manufactured using 19 different Kingspan products. We do a huge amount of work with architects and government bodies coming to the facility to see how it actually works. Within this building, obviously, we're working with the insulated panel range, securing our air and watertight line, our thermal line, looking at the light and air products within the Kingspan group, looking at air extraction, controlling the temperature within the building to maintain optimal temperatures. We're not having to cool the building when we can have automatic opening vents that are cooling the building for us. Water and energy, so harvesting any rainwater that we get, and then looking at any of the wastewater that we're producing and having that recycled back into some of the facilities within the actual building itself. This is the building here. It's a verified LEED V4 gold standard. As you can see, PV arrays on the roof, high performance insulation. a clever thing about this building, which we feel is something that we really need to be pushing to roll out across every building that we manufacture, it has a digital twin inside, so you can actually go and stand in front of a digital twin of this building, which is continuously monitoring energy use, lighting levels, oxygen levels, personnel movement throughout the building. It also tells you where your energy use is focused, and is that being fed by the PV array, the geothermal. So it's an extremely beneficial tool to see how much energy your building is using and how we're managing that. So I'm just going to show a quick video on it, just to give you a kind of run through of it. Very passionate music. So that is a net zero operational building. It's fantastic for if you are working with clients, yourselves as architects, as main contractors, as contractors to bring clients to it. What we do is product demonstrations. We'd have samples, say, of particular type of facade systems. So that essentially draws me to a finish, I think, just on time. As I said, I'm set up out in the main foyer area. If anyone has any questions or anything they want to go through, more than happy to answer anything. And thank you very much for your time.
Thank you, Emmet, and it's good to see PV panels on Kingspan.
Yes, definitely.
And also the talk about energy monitoring in buildings. It's good to see that a company like Kingspan is offering that as well. I'll move us on to our last speaker before the break. We're going to switch topics a little bit and talk about fire protection, but fire protection with transparent materials, glass, namely. Our next speaker is Andrea Marston. She's the Sales and Marketing Manager at Pyrobel. Andrea. Is Andrea with us?
I'm here.
Oh, there you are. All yours.
Thank you,
Take
Stephen.
it away.
Good morning, everyone. It's very nice to be here today, particularly after 2 years of making presentations on Teams and Zoom and so on. It's really a pleasure to be here. My name's Andrea Marston. I am the... Okay, thank you. I'm the sales manager for our fire-resistant glass business in the UK and Ireland. And today I'd like to talk to you about solutions in fire-resistant glazing and also to show a recent project that we've been working on. So if I may, I'll just briefly introduce our company. I hope that some of you may have already heard of AGC, but if you haven't, you'll almost certainly know our products because they're used in approximately 1 in 4 cars and buildings across Europe. We specialise in the manufacture of energy efficient coated glass that's widely used in facades. We have technology such as vacuum insulating glazing, building integrated photovoltaic panels, and much more, including fire resistant glass. So our brand is Pyrobel. We've been manufacturing fire-resistant glass for almost 40 years. So in that time, we've built up a large amount of, we hope, expertise, and also a very comprehensive product portfolio. So this year, you may not know it, but it's actually been nominated by the United Nations as the International Year of Glass, thanks to the contributions that glass brings to our society in a wide range of things, from the fibre optic cables that bring the broadband to our homes, to the glass screens on our laptops and smartphones, and of course, our built environment. It's hard today to imagine our homes or our workplaces without glass. Many of us spend up to 90% of our daily life indoors. Glass is the medium through which we bring daylight into our buildings. Daylight is very important for helping us to regulate our internal body clocks, linked to our central nervous system, that impact on our physical and mental well-being. And of course, glass connects us with our outside environment. But what happens when we want to use glass, but we also need to build in passive fire protection within the design of the building? Passive fire protection is written into regulations, building regulations across Europe for 4 main reasons: to provide safe access for firefighting, to protect means of escape in buildings, to limit internal spread of fire through compartmentation, and also to limit external spread of fire across the facade. So typically in these situations, the solutions we have are fire-resistant glazing systems. So that's not just the glass alone, but it's the glazing system that you're putting it into. These materials are fire-resistant. So you see here a typical example of a fire-resistant glass, which is fully transparent. It's a laminated glass with transparent fire-resistant interlayers that in the event of a fire, foam up to provide a barrier to fire, which brings its use to a wide range of applications, as you see here within a building. So within a facade, we may want to use fire-resistant glazing for fire protection, but it may also need to answer other challenges in the facade, like energy efficiency to be combined with solar control glass, thermally insulating glass. We might also be talking about glass acting as a full height barrier to protect against fall, and acoustic control. We use fire-resistant glazing within atrium, of course, thanks to its transparent daylight properties. But that glass is providing fire protection, but also safety, protection against fall. And then it's also widely used in internal partitions and doors, particularly on means of escape. So all fire-resistant glazing systems are required to be independently tested to show that they will work when needed. So when we talk about fire-resistant glazing, there are 3 main categories of performance, or classifications of performance. We start with the E classification. That means integrity-only glazing. So in the event of a fire, that glazing acts as a barrier to stop the passage of flame, but it doesn't prevent the potential for heat radiation through the glazing. So within that E classification, then you will have a time period, commonly 30 minutes or 60 minutes, often going up in some cases to 2 hours. We then have the next level of classification, which is the EW classification. So that's integrity and limited radiation. So again, the glazing is acting as a barrier to stop the passage of flame, but it's also acting to reduce the amount of heat that's radiated through the glazing. So that heat cannot exceed 15 kilowatts per square metre. So to put that into some kind of context, a typical gas fire in your home will emit somewhere between 5 to 7 kilowatts. And again, that classification has a time period, most commonly 30 minutes or 60 minutes, going up to usually 2 hours or even up to 3 hours. Now, that classification is not referenced in the UK or Ireland technical documents for fire safety, but I mention it because it's widely used in it's widely referenced in some other European regulations for fire safety, for example, in the Netherlands. And then finally, we have the highest category of performance, which is the EI classification. So that's integrity and insulation. So that glazing system is acting to block the passage of flame, but it's also blocking heat radiation through the glazing. And again, for time periods starting from 15 minutes up to the maximum of 3 hours. So I'd now like to just share a short video, an example of a fire test, and how you demonstrate compliance with those classifications is through a full-scale destructive fire test of the glass and glazing system, as you'll see here. So as well as fire testing of products, fire-resistant glass must also follow CE marking, which means that it's independently audited annually, and all fire-resistant glass is permanently stamped to allow for full product traceability. And from January of next year, CE marking in England, Wales and Scotland will be replaced by a UK CA mark. Of course, we've talked about fire protection, but another vital topic for us all here today is sustainability. As Pat's very clearly presented this morning, it's not just about operational carbon use in our buildings, it's about embodied carbon in the materials that we build with. And the decarbonisation of the glass industry is a really pressing challenge that everybody is very focused on. Within Pyrobel, here we are today, we try to go above and beyond the mandatory requirements. We have cradle-to-cradle certification for our Pyrobel fire-resistant glass. We have environmental product declaration, and our plants are ISO 14001 certified. And we're really interested to engage with industry as well to hear what more is needed from us. So now to finish, I would just like to present a short case study of an example where our fire-resistant glazing was recently used in the facade of a residential building in the Netherlands. The video is in Dutch, but you'll be pleased to hear it has subtitles in English.
Op de plek waar stad, landelijk gebied en water elkaar ontmoeten in Amsterdam-Eiburg verrijst het Sluishuis. Dit bijna 50.000 vierkante meter tellende woningbouwproject helt straks over het water. Reden om de ramen van de uitkragende appartementen te voorzien van beloopbaar brandwerend glas in de hoogste klassificatie, EI60.
Het is een heel bijzonder project. Het gaat om 42 ramen, afmeting ongeveer 3 bij 1,25 meter. De ramen zijn met het glas samen bij ons op de zaak geassembleerd in het Janssen Vis Fire profiel. En in deze toepassing zijn de ramen speciaal getest bij Effectus in Blijswijk.
Het glaspakket telt totaal 74 mm dikte, waarbij een Pyrobel T EI60 buitenruit is gecombineerd met een gelamineerde binnenruit van 3 bij 8 mm gehard glas. Het glas is horizontaal getest, zodat het bereik is vergroot en het van 0 tot 80 graden kan worden toegepast. Die keuze is mede gebaseerd op het vertrouwen in Pyrobel van zowel de aannemer Basics als van MC Kersten.
De eis van 60 minuten brandoverslag, EI, is de hoogste kwalificatie. Die komt voort uit de brandoverslag van het lager gelegen appartement naar het hoger gelegen appartement. Langs de cantilever, dat is de schuin oplopende wand. Extra uitdaging is dat de brand weer er lastig bij komt omdat we boven het water zitten.
De prefab-kozijnen met het dikke glaspakket wegen circa 600 kilo en waren te groot en te zwaar om binnendoor te transporteren. Ze zijn dan ook van buitenaf gemonteerd.
De montage van de ramen was een hele bijzondere uitdaging. We zaten tegen de schuin oplopende wand, dus de normale hijsmiddel was het eigenlijk niet te doen. Dus we hebben in eigen huis een hijsconstructie ontwikkeld, waardoor we de ramen via een hijsbalk die we tegen de plafonds in het appartement hebben aangebracht, omhoog hebben gehesen. Die hijsconstructie hebben we ook in eigen huis laten certificeren.
Resultaatgericht samenwerken is een begrip dat in de bouw steeds vaker terugkomt. Ook van leveranciers als AGC wordt verwacht dat ze constructief meedenken en zich houden aan afspraken.
Samenwerking met de AGC is zeer voortvarend verlopen. Ze hebben een goede kennis en kunde om dit soort projecten aan te pakken. Ze hebben ook met de brandtest goede ondersteuning geboden. En ook tijdens de realisatie is alles volgens planning verlopen. En we hebben met elkaar een prachtig project neergezet waar we denk echt trots op mogen zijn.
So that's a nice example, I hope, of the result of collaboration between glass and glazing industry, specialist contracting, architecture and engineering. So following a lot, I think, about what the spirit of this Zak conference is all about. So I'd like to thank you for your time, thank you for listening, and I look forward to meeting you during the rest of the day. Thank you.
Thank you, Andrea.
Thank you.
It was a great example of collaboration. And as always, it's not just the glass that has to work, it's all the elements around the glass. And in this case, you've seen the Janssen frame that works and is tested with the glass to work in this case. So we now come to our break. We're a little bit behind schedule, but that's okay. We'll catch it up during the day. Please enjoy a coffee break and please come back at 11 for what I hope will be a really interesting second session of today. Thank you for your attention so far. We're into our second session, which I'm really looking forward to. We've got some great speakers in our second session, starting with Neil Murphy. Neil probably doesn't really need an introduction in this audience, but I'll introduce him anyway. Neil's been working in this business for quite a long time as a facade consultant on many projects, not only in Ireland, but in the UK and in Europe and internationally. So I'm really looking forward to his talk. He's going to tell us a little bit about computational methods for facade design procurement, and we'll cover sustainability, but I think he just told me it's going to be a lot of case studies, so that's great. Over to you, Neil.
Right, thank you. The presentation will explain how advances in computational methods are allowing us to design, procure, and sustainably assess facades in a more detailed and informed way. It contains a series of short real-world case studies, some local, some further afield, and deals with a range of technical approaches in three main categories, being BIM, parametric modelling, and embodied carbon assessments. In a world of rising construction costs, cost, risk, and uncertainty play a leading role in the dynamics of a project. These new technologies are being utilised to understand, to technically solve, and to rationalise construction concepts. These technologies ultimately allow for more straightforward procurement processes, resulting in cost certainty for clients and contractors, lowering risk influence in the contractor's tender offerings, and ultimately enabling higher levels of understanding of the sustainability characteristics of the facade. It also increases the accuracy of embodied carbon assessments at much earlier stages in the project. The first case study in the parametric modelling section is a project that some of you will recognize. It's actually the oldest case study in the presentation. We did an awful lot of work with Henry J. Lyons at the time, and unfortunately the project was suspended in the planning process, but we're hopeful that it will come to life in the future. Basically, this was a 3,000 square meter double curved grid shell canopy involving more than 1,500 individual glass elements. And we supported Henry J. Lyons' concept development through computational modeling, undertaking rationalization studies, whilst all the while sticking faithfully to the architectural concept. Using Rhino software with Grasshopper scripting, combined also with CATIA 5 software, we worked with an original design which contained a vast majority of curved and double curved glazed elements. What we termed fourth point deviation analysis allows a detailed understanding of the extent to which flat glass can be utilized in a cold bending process to achieve a curved profile. Utilizing conservative manufacturing tolerances for force bending, which is more straightforward for non-IGUs, which this project was, we were effectively looking to try and procure curved glazing for free. We undertook a range of iterative analyses, which I'll pop on to the next stage. We undertook a range of iterative analyses which looked at the reduction of the number of curved elements, double curved elements. We also looked to minimize the number of glass panels themselves. We also looked at increasing the height of the central apex on the ridge of the assembly, and by doing that, we were able to ensure that you get minimum system slopes on the roof construction for warranty purposes, but also which also considered the dead load deflections and medium to long-term snow load deflections of the supporting structure. What you can also see there is a central ridge line on that apex, which was also created so that we could actually achieve a properly sloped surface either side of that ridge line, which helped to avoid issues such as ponding and helped with the maintenance strategy for the building. Henry J. Lyons were obviously keen to soften that ridge line, which you don't see there, but as that came towards the very front of the canopy element, that ridge line was softened architecturally, but it also facilitated a dip into the leading edge gutter profile, which worked for us too. The information extracted in this process would ultimately allow for a detailed glazing schedule to be produced, and in that information you can have the number of individual types, the panels which could be cold bent, and also highlighting areas shown in the kind of dark red colors at the base of the canopy, where the fourth point deviation was just too aggressive and elements just had to be produced in double curved format through the hot curving process. And obviously there was significant costs ultimately attached to that. So with appropriate qualifications, schedules such as these can support facade tender documentation, ultimately de-risking the tender process from a resource requirement and cost perspective, and ultimately demystifies the geometry for all concerned. The next case study we were started on this project about maybe 6 years ago. It's Port Baku Tower in Baku, Azerbaijan, and this is with Chapman Taylor Architects. This is a circa 50-story double curved tapered form. It's a speculative office development. This particular project and the location that it's in makes it quite complicated in that it's known as the Windy City. So we've got project-specific parameters on this project which have wind loads which range from 6 kilonewton per meter squared to 11 kilonewtons per meter squared. And to put that into a local context, that's 5 times the EXO building that we're involved on just down the way, which is the tallest office building in Ireland. And it's also 3 times the wind load of a Norman Foster project in Warsaw that we're doing, which is 300 meters tall. So exceptionally high wind loads. The wind loads were so high on this project that when the blast consultants started talking about the low-level facade elements, we actually already knew we could comply with the structural requirements of a blast through satisfying the wind load applications. but this particular blast requirement relied on resilience cleats to be integrated into the central body of the mullion extrusion. So you can see these profiles here. So effectively what that does is as the blast energy passes through the skin, it holds the two elements together. You'll also see very, very thick extrusion gauges there, and that's basically resulting from the wind load requirements. So on this scheme, MFS took the architect's model, which was a double curved sinuous form, and with CATIA 5 software, we developed a practical technical concept. Basically, the base frame is fully faceted, both vertically and horizontally, to achieve the double curved form, so no curving of profiles were required. We also then structurally bonded what were thick gauge double glazed units to a light gauge aluminium carrier frame, and basically through positioning what we were terming stainless steel nipples, which were hard points on the base frame, we were able to roll and press the actual lighter gauge carrier frame onto a faceting subframe and then stitch it into position. So effectively we were getting, in the most areas, curved glazing for free. The analysis that we did undertake, which was quite extensive on this scheme, allowed us to produce a panel schedule from the model that controlled all the dimensional and planar parameters, and this allowed for a very efficient tendering process and was appreciated by all the subcontractors. And this scheme is just complete now in the next couple of weeks, and it was done by Erbe, who are a specialist subcontractor from Turkey. I'm showing this one here. It's another example. It's the Elite Tower in Tel Aviv. It's, I think, 55 stories. Basically, this is newer forms of the software that we were using in the previous scheme. I turn the page. This was undertaken with Revit and Dynamo scripting. We undertook a sequential parametric modeling analysis to rationalize the concept. Again, we ended up with rectangular and trapezoidal panels with flat glazing elements. It was faceted vertically and horizontally, and there was some unusual triangulated panels on some of the corner areas where we had to kind of fold the unitized panels around the corners. This is one that's a lot closer to home, recently finished during COVID. It's by Altu Architects. It's the Black Rock Shopping Centre. The main function of this glazed canopy, which was a grid shell canopy, was to provide weathering protection to the 1970s built shopping centre while still maintaining the full external air condition. However, increasing the rainfall catchment areas on the roof, on the existing roofs through the use of the new roof was deemed to be problematic. So this led to a consideration to utilize the actual elegant tree stems as the drainage mechanism for the roofs. So we did a range of analyses looking at pitch points, single slopes, all trying to guide water into these kind of funnels. Now, the parametric analysis involved there was Revit again with Dynamo scripting. We ended up with primarily diamond-shaped panels, and then we ended up softening those triangular those diamond-shaped panels via triangulation to help with a smooth drainage solution. During the process, the building services engineers ultimately confirmed that the existing roof, with some modification, could accept the additional rainfall catchment area, and this obviously resulted in a much simpler multi-planar glazed canopy, and with obvious practical benefits for maintenance and drainage. The facade on this project was undertaken superbly actually by Octitube, who some of you will know. This is an interesting project. It's a tower in Augsburg that we're recently involved in with Studio Libeskind in New York. It's quite a complex shape. It's faceted and staggered a step-planed form on a floor-by-floor basis. There's also a significant number of glazed, three-dimensional glazed consoles in the main body of each elevation. This is obviously a complex facade construction, so understanding the geometries allowed us to develop a technical concept which ultimately satisfied the first principles in terms of performance, but also allowed factory fabrication and solved ease of installation issues. Even though this obviously looks like quite a premium facade, we were still tasked with some cost rationalizations, and the trick was ultimately to solve the geometry in the detail. So, utilizing Rhino with grasshopper scripting, we developed a concept with the following technical characteristics. Yeah. So basically, if you see the spandrel here in the center of the screen, through a very, very shallow profile section, we were able to make these Z-shaped transitions all in the one panel, moving from side to side, so literally transitioning spandrel panels. Once that was solved, that actually allowed for all the required bracketry, compartmentation requirements to fit in behind it. But once it is in position, it then allows still complex and tricky, but more straightforward vertical glass surfaces with soffits and roof elements to be basically plugged on in a fully unitizable manner. This is the last case study in the parametric modelling section. So this is a project called the W Hotel in Edinburgh. This was undertaken, or this is designed by Jessica Wiles, and it's basically a new kind of city, kind of retail quarter in Edinburgh, and this was a centerpiece hotel. Our role in this scheme was to help Jessica Wiles and the client understand the geometrical implications of the ribbon balustrade element, which is this component here. So basically, this wrapped all the way around the slab edges and ultimately became a freestanding cantilevering flourish element at the roof. With Rhino and Grasshopper scripting, it allowed us to understand this form and to actually interrogate the geometries required. We ended up with a prefabricated large frame construction in aluminium, which took basically edge-folded, conically curved, in some cases, Rymex, chemically colored Rymex stainless steel cladding. The cladding assembly itself was mounted on a more agricultural hot-dip galvanized steel faceting frame. So that then formed the full canopy, and that faceting hot-dip galvanized steel frame continued on up into the roof and became, through welded sections, to form a kind of an agricultural chassis to carry the more expensive and specially formed stainless steel cladding elements. This particular project, through the projects that we mentioned earlier, undertaken with Octotube, we had a very good experience with them on a number of schemes. So we actually put Octotube in front of the main contractor for this scheme, and they ultimately negotiated the contract and produced a superb solution. And it also included the actual ground, or the floor construction of the projecting balustrade concept as well. So now moving on to the building information modelling section. This is a scheme that you will have seen very recently in the newspapers. Got planning permission and is proceeding at pace. It's basically Google Boland's Bakery, and designed by AHMM Architects. Retention of existing structure and retention of existing facades is very important on this particular scheme. There's a strong emphasis on sustainability performance credentials in the design, construction, in-service phases. As an owner and user, the sustainability practices are heavily driven by Google in this project, and it's ultimately supported by a very strong technical team, including Ethos on building services, Meehan Green on sustainability, and Cora on structure, and I think John is probably in the crowd there. we were commissioned to undertake a high level of technical detail in the concepts, because we ultimately had to produce a family of BIM models to back up these concepts. The BIM models themselves were ultimately fed into the architect's federated model. There's the suite, the family suite from the BIM models. And these detailed Revit models allowed a strong understanding of the carbon footprint, whilst also facilitating the multiple validation processes required for energy performance, including LEED, ILFI carbon, and BREEAM, etc. What we had to consider in this particular project, and it's unusual and it's coming more to the fore, is the use of recycled aluminium. There was a strong emphasis on trying to procure recycled aluminium, and we looked at various options on this particular project. But what becomes apparent when you start looking into recycled aluminium is that the better recycled content aluminium is in extruded form. It's harder to get better recycled content and with good provenance in sheet material format. So we designed a concept which heavily utilized extruded aluminium in order to be able to get the carbon footprint benefits that provided. Part of the process in pre-tender was actually interrogating what available EPDs were for aluminium for the various products that are available on the marketplace, and trying to establish what products had the lower global warming potentials. What we found also in this process is global warming potential is heavily driven, of these products, is heavily driven by the national energy source that is producing these products. So if you've got coal-fired or fossil fuel-based energy source as a national energy source, inevitably the recycled content produced by these countries doesn't have as low a global warming potential as something produced from a hydroelectric energy source. These investigations allowed options to be considered, such as Circal 75 and Reduxa aluminium billets, which happened to be both by hydro, and they were found to have quite low global warming potential figures, and that's primarily because they're produced from a hydroelectric source. The performance spec itself required options for high recycled aluminium content, and this was monitored at tender stage, and the subcontractors who were tendering the process were required to supply certified EPDs backing up their tender submissions, and were ultimately challenged on their approach at all times. Stephen, you're not a tech head, are you? No. 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 It's probably going to shoot forward now. Okay. This is the next slide. There's a couple of videos in it, but I'm not sure if it's going to go. I'll keep talking ahead of you. Yeah, this was basically a large-scale residential project. It's the Fragment building in Prague by Carta Architectura. It's working, is it?
Yeah.
No. It's working until you leave the stage.
Otherwise, you can press next year.
Yeah, perfect. Basically, it's a complex stepped plan. It's a faceted form. Differing from the previous project where we provided BIM models just for localized Bay Area types, our role in this particular scheme was to undertake the Revit model for the entire facade. These Revit models were produced to a much higher level of detail that is required for that particular stage of the project. But what it actually provided, that kind of enhanced service, provided significant technical control and confidence on the spatial coordination within the facade zone and also the thermal compliance of the overall skin itself. The level of detail within the models also allowed a significant value engineering process to be undertaken in tandem with the two-stage tendering process. So basically, as kind of more real and live costings were provided, the cost consultants and the client were able to use our models to basically get more real-time impacts of the value engineering being put forward on the table. Ultimately, this process realized significant savings and de-risked the facade package from a cost perspective and effectively allowed the subcontractors to understand the geometry and get comfortable with it. These particular models also allowed a very, very detailed understanding of material content, volumes, and weights, which ultimately facilitated detailed early-stage embodied carbon assessments. And these were controlled at each stage of the process subsequent to that. And this particular project is now on site. This scheme that we can see here in the background is Project Key by Cuboid Architects. It's in the very early stages, but it's a commercial unitized project which, with quite a high level of repetition in the element types. I think there's less than 10 element types. But basically, the client wanted to understand the potential benefits of using our BIM model for budgetary control and costing measures. So to that end, we supported the cost consultant by linking our detailed BIM model directly via Dynamo scripting directly with the bill of quantities. This live model interaction allowed real-time adjustments and to be made basically to the cost plan. Several parameters explored, including panel type, panel size, panel rates, location, were basically allowed to be investigated also. Typical data inputs into a BIM model include glass spec, material finish, equal and approved systems, etc. These inputs from this BIM model actually form the text of the bill of quantities, those sections of the bill of quantities. So effectively, this BIM model wrote significant portions of the bill of quantities document automatically. Now, this is a two-way process where adjustments in the bill led to adjustments in the BIM model descriptions and vice versa. So obviously, engaging in a process like this, control permissions are key to the management of such a tool. Now, the final case study is based around life cycle assessments and embodied carbon analysis. This is a project that we're working on called the ESET Campus Headquarters in Bratislava with Big Architects. ESET, it's an owner-occupier HQ campus, so basic for the large software group, that's ESET. But there's very, very onerous local thermal compliance requirements. So we've ended up, shoot past this one. We've ended up with a closed cavity facade, which is positively pressured. So basically the cavity between the inner and the outer skin is positively pressured to keep out detritus, dirt, moist air, things like that, basically over the life of the panel. We've also got a lot of doors leading out from this skin, so we've actually got a hybrid condition where we've got just traditional unitized panels side by side with closed cavity, allowing door access out onto wraparound balconies. The improved U values that were available through the closed cavity construction also allowed additional transparency and allowed a controlled environment for motorized componentry, ultimately establishing longer design lives and warranty periods, where we also incorporated maintenance, sensible maintenance hatches to get in and out of these hermetically sealed cavities. Another interesting point on this particular facade is in the factory fabrication, we are going to incorporate components of the thermally broken balcony connection that are just going to effectively float there and be delivered with the panels, so that when they're brought to site, stood on the slabs, and when the balcony, its structural balcony itself is actually connected and loaded, it doesn't transfer any load into the unitized panels. There's a significant level of 2D technical detailing done on this project, and it facilitated a lot of validation of the thermal solution. It also facilitated detailed Revit model families which ultimately supported the embodied carbon assessments for the scheme, which we undertook to product stage phases A1 to A3. These were then fed to the project sustainability consultant for their kind of onward use and consideration throughout the process. An interesting point on this project is with the closed cavity facade, through the whole process, we actually benchmarked the closed cavity facade against a high-performing triple glazed kind of passive facade. And that kind of yielded some pretty interesting results. In that process, we also compared alloy options through standard aluminium billets, Circal 75, Reduxa billets, and just kind of gained a feeling for the improvements that could be obtained with this technology. Some of the interesting results are the aluminium content between the closed cavity facade and the passive triple glazed facade was actually quite similar. It's similar in system depth. Also, the glass content is not too dissimilar either, even though one is a double skin and one is a high-performing triple skin. And that is actually due to the fact that in the triple glazed passive condition, there's actually more opaque double glazed unitized spandrel elements. So there is actually not too much of a difference in glazing content. However, the really interesting item here, and if you can see on the top left, basically we took a standard aluminium billet, and when you analyze that from a global warming potential, the actual percentage influence over that, let's say, square meter of facade or that particular bay type was roughly 60%. So the aluminium was the dominant material leading to the global warming issue. When we swapped the standard alloy for Reduxa and for Circal 75, that influence reduced from 60% down to 40% and ultimately down to 28%. So just through utilizing more environmentally sustainable material, we were able to turn the aluminium, which will always typically be the dominant material, the bad guy in the room, from 60% down to 28%. So then the focus switches onto glazing. Now, as Pat alluded to earlier, there's lots of conversations around glazing and the kind of regulation needs for lamination, the client's needs for ceramics for visual control purposes. All of these have an influence on the embodied carbon content of the glass panel, but we don't currently feel the glazing industry is as advanced as the recycled content in the aluminium industry. So we do feel there should be a lot more focus on being able to obtain and procure high-performing glass construction, which is also environmentally sustainable with improved global warming potential. And then to conclude, basically what we're seeing, the ESET were, again, an owner-occupier. So you're kind of starting to see a pattern here, basically, where there's a consistent approach from all owner-occupiers that we've seen in the last number of years who commission their own buildings to drive this sustainability aspect of their buildings. We're also seeing large-scale institutional investors and developers. They're also being driven down this road, partially by themselves, but also by their own shareholders and basically funding groups. So that's effectively it. Thanks for listening. Thanks for Zak for allowing me up here. And I'll take any questions at lunchtime.
Thank you, Neil, very much for that, and it's our pleasure to have you here. I just want to have an update for you on Port Baku. Port Baku is a project that Neil showed us at the beginning with a kind of curvy geometry. This is ended up being executed with actually a cold bent facade. So it's not an interlock unitized, it's a Schuko, if you like, female-female system with cold bent glass on the construction, which gives it the real genuine curved appearance, as opposed to an interlock system which can only work really with a kind of segmented or faceted construction. The project is going very well on site. You'd be glad to hear, Neil. I'm going to move on to our next speaker. I'm very delighted that Stefan is with us. Stefan is a colleague of mine. We've worked together now for the best part of 7 years. Stefan is now Engineering Director at Schuko UK and responsible for some really exciting projects and always brings a lot of original thought with his work. So, Stefan, over to you.
Thank you, Stephen. Can you all hear me well? I hope so. Well, I need to start with a disclaimer. The topic of this presentation is sustainability, and I'm not an expert in sustainability. So I guess you could say that I'm approaching this from the point of view that I have, which is one of a simple-minded structural engineer by background. And however, I have come to realize that this is now a really important part of our designs and of the buildings that we're building. And everyone needs to get involved, including me, even though reluctantly at first. But essentially, unconventional perspectives on sustainability, what does unconventional mean? It's basically good old common sense in so many respects. And what I wanted to show you was 3 topics. So the first one is going to be a more general overview of the sustainability topic from a system supplier's point of view. Then towards the middle of the presentation, we are going to be looking at various design things that we can do to make our facades more sustainable. And those really are low-tech, low-key things that we can all do to contribute to better sustainability. And then the third part is going to be about looking at the big picture and looking really deep, analyzing it, and not really fooling ourselves about what we are doing when we build buildings. Okay, so starting with this overview of sustainability, you've already seen today quite a lot on that, and we know that a big part of our carbon emissions are because of buildings, so around 40% or thereabout. And yes, that sounds like a big number, but what does that number mean? And we should really be thinking in perspectives, and we have been getting better. So when you look at the overall carbon emissions behind me, you can see that they are falling. And the structure of those has been changing because historically we've been driving U values down and down. So essentially the structure has been changing, whereas now the next challenge is to reduce the embodied carbon in our facade so that the overall graphic will point even further down, okay? And essentially, to understand that and to be able to influence it, we need to gain a better understanding about what actually that means. Because we said in the beginning, okay, around 40% is the effect of the built environment, but how much of that is the facade, how much of that is insulation, concrete, etc. So there is data. Everyone can look it up and find out and educate themselves. So I do encourage you to do a little bit of reading. What Pat mentioned earlier today, the IStrucT has a really great document. There are other great documents out there. But essentially, we need to understand, before we can act, we need to put things in perspective and know really what we need to change. Because we already said 40% is the built sector, but from that, you've got around 25% is the facade. So it's actually 25% of 40%, okay? A lot of the carbon emissions are because of the concrete. There are other materials out there that also need to contribute. So looking at the facade, let's dive even further and look at the, sorry. Okay. So when we look at the facade, we can see the relationship. So you've got the main contributors are the glass and the aluminium. So the actual aluminium, it has a certain percentage of the overall weight, and it has about 40+% of the whole carbon emission. And this is based on more or less standard aluminium. So between low carbon aluminium and standard aluminium. So this is where Schuko comes in, and what we can influence is within that. So it's within the 40% of the 25% of the 40%. Okay, so this is the actual topic that we need to look at, and there is a lot of talk about how we make aluminium more sustainable. And aluminium has been getting some attention in the last several years. And when we look at the aluminium, we can see roughly where the carbon emissions are coming from, and respectively the embodied carbon. So you can actually see that most of those are because of the smelting process, so that gives you 80%. And when you're working with prime aluminium, you basically have more embodied carbon in your material, because this is the most energy heavy process in the production of the material. Okay, so recycling is great. We should be using recycling and recycled aluminium, but we should also be using low carbon energy sources. And what you're going to see in the minute is that actually recycling has a bit of a limited potential, really. Whereas renewable energy has a lot more potential. And the reason why I'm saying this is that when you look at a building, so you are a design team, for example, when you need to design a new building, so you want to achieve your architectural intent, you want to achieve your aspiration. And essentially, the problem is then where is it coming from? Because you need to look at the overall, you need to look at the big picture, and you shouldn't only be looking in Ireland or in Europe, or you should be really looking at the whole planet. And when you look at the actual consumption of aluminium, we're right about here now. This is around 2022. So in 2050, if we keep doing what we're doing, we will be using 3 times more aluminium. And the same logic applies when we start thinking backwards. We are now using a lot more than we were using 50 years ago. So if you think about a facade and its life cycle, and you think, okay, a facade is supposed to last about 50 years. So if we're using only recycled aluminium for our building, we have to find that aluminium from buildings being demolished that were built 50 years ago. Are those buildings there? And to give you a further example, I want to show you our own headquarters in Bielefeld. So this is a new building going up. It's almost completed now. And next to it, almost the exact location was this. This was the old Schuko headquarters, and that was built 60 years ago. So if we apply common logic, and if we think about circular economy, and if we imagine that everything just goes around in circles, it's not actually a circle, it's more of a spiral, because our demand is growing. We want to build more, and we need a much bigger building now than we needed 50, 60 years ago, okay? So yes, by all means, we should be using all of the available recycled aluminium. We just don't need to really put it in this building or the other. We should be using it throughout, okay? So renewable energy, yes. Recycling, yes. But do it with understanding and know where everything is coming from, okay? So let's look at some design principles and levers that we can use to improve, because in terms of design, you probably know this graphic, but the red curve shows your impact. So at the beginning of the project, you have the biggest impact. So when the sheet is blank, you can start, and if you start thinking about sustainability, then this is when you have the greatest impact. And admittedly, the blue curve shows your clarity. So you will have less clarity in the beginning, but that clarity is only going to grow and grow, okay? So let's think about it this way. We are a design team, and we want to design a middle-sized, 10,000 square meter, pretty normal-looking conventional facade, and we want to do it with a unitized curtain wall, okay? And looking at that, we start looking at various systems, catalogs, and we see that there are so many ways to do it. We can do it with very small profiles, we can do it with very big profiles, and I think that a lot of colleagues out there are looking at that, wondering, you know, what is actually the optimal way to do it? And intuitively you think, oh, look at this big section, that's a lot of aluminium, a lot of embodied carbon, a lot of weight, a lot of cost. But what I'm going to show you is that actually the section on the right is much more sustainable and much better for the planet. And to do that, it's just very simple math. So when you look at the sections from a system supplier's perspective, you can parameterize a section, okay? Because these things don't really change. The glazing detail doesn't change that much. All the grooves for the gaskets, etc., they are pretty standard. So what you can actually vary with, and what you do vary with most of the times, is just the depth of the section. So there is one single parameter that you can use for this. And intuitively, you would think, okay, we increase the section a little bit, so therefore we increase its stiffness and its strength a little bit. Well, that's not actually true. And when you look at a theorem that Steiner came up with about 200 years ago, it's actually a cubic section when you think about the moment of inertia and therefore the stiffness. And actually, this is the graphic. So people often think, okay, if I double my section, my strength is going to double and my stiffness is going to double. No, it's actually your stiffness is going to rise 8 times. Your strength is going to rise 6 times. So what you see behind me with the blue curve, this is how your stiffness rises as a function of the depth of the section. And the little gray straight line, this is the sort of intuitive thinking, what you think, okay, I rise with 20% and then it's incremental. But it's actually much better than this, because with the depth of the section, we're leveraging the mass, and it becomes better and better. So looking at it from that point of view, the actual mass rises linearly. So the mass, therefore, the amount of aluminium, therefore the carbon emissions, etc., they just rise linearly, whereas the benefit, meaning the stiffness, it just shoots up really, really quickly, okay? So coming back to our bland-looking building, we can actually study this, and we can take a typical bay, let's say it's 6 meters by 3.6, and we can do this in a number of ways. We can stay with kind of old school, so do like 1 meter wide units, or we can build them a little bit bigger. The standard right now that most people go for is about 1.5, but very often we see 2 meters, 2 meter wide units. Rarely we would see 3 meter wide, okay? But let's look at this, and it's actually very simple. I'm just going to really quickly go through that, but essentially, think about a simply supported beam. Your decisive criterion is the deflection, and that deflection will then be dependent on the stiffness, and the stiffness is a function of the material. All of that is given, so it's not a parameter, but the other factor is the section, okay? So we can play with those parameters. We can play with the width, and we can play with the section of the system, okay? So let's plot those graphically and see what happens. You can see the required depth of the mullion or of the system in this sort of generalized case study. And you can see that the gray line is the linear function, what we would initially think with our human brain. But then the blue line is what we actually need physically. So if you flip this around, and if you think about your actual aluminium requirement as a content of aluminium in the facade in terms of kilogram per square meter, you can see that this drops down very dramatically. So the bigger you go, the less aluminium you will use, right? And let's put some figures to that. So this is this case study that we did. And essentially, this would be broadly what you would get from a standard sort of unitized system, okay? And one would say, when you build bigger, doesn't your glass need to be thicker? Well, in most cases, a little bit thicker, yes, but not dramatically, because the same principles apply for glass, and glass is so often over-designed because of acoustics, because of thermal, etc. So the effect on glass is fairly minimal. And the other benefit is that your actual U value improves. So with bigger units, you'll have more glass, less frame. It's better overall for both your embodied and operational carbon. So looking at that previous example that I gave you, if you have this typical bay, if you're doing it with 1 meter wide units, you will be spending around 7 kilograms of aluminium per square meter, okay? You go 3 meter wide, and your actual aluminium usage drops dramatically down to 4.5 kilograms per square meter, okay? So if you think about this 10,000 square meter bland-looking building, when you go from 1 meter to 3 meter, you would actually be saving 190 tons of embodied CO2 with standard European-wide available aluminium, okay? So this is 190 flights from Dublin to New York and back, right? So that is one thing, right? And it is possible to do it. People often think, 3 meter wide, they're so big, how do you transport them? What about logistics, etc.? This is being done in Dublin by Alucraft. You guys are doing an amazing job. So you can see that it is doable, and it looks really good. Your architecture is improved, and your sustainability is improved, okay? And the next picture is another project that we have been working together with Alucraft again. Watch this space, amazing big units coming to life. And this is a facade that is going to be inherently, naturally, sustainable, cost-effective, and really, really good looking, right? So I mentioned that we need to be looking at the big picture. So it does not suffice to specify your aluminium properly. You need to be looking at your design. You need to be making a lot of options. I think Neil gave some really good examples of how you can parameterize that. You can take advantage. You don't have to do it old school. You can parameterize it. You can use computer technology to take advantage of that. But what the message that I want to give you is, look at the big picture and look really, really deep and challenge everything, right? And let's look at logistics. Let's look at how it works. And let's imagine that we have a project in a generic map, in a generic continent, and then we need to be looking at those things. We need to be looking at procurement. So if you're bringing your system from 1,000 kilometers away, it is what it is. But what if you are bringing your facade in terms of the ready-made units? Are you manufacturing those near to site, or are you manufacturing those somewhere 2,000 kilometers away? And does it really make a big difference? And what you're going to see is that it does. So these are not super precise numbers. That's just the back of an envelope type of calculation, and everyone can do that sort of calculation. And I know that when we consider what car we should be buying next, we think about fuel consumption, and fuel consumption is tied with carbon. And we know roughly what a heavy goods vehicle, what consumption that has, and we want to think about these two scenarios. So we have that project in our country, and we want to consider whether we want to manufacture the units 2,000 kilometers away, or whether we want to manufacture them around 200 kilometers away, or nationwide. And what we can see actually is that when it comes to the systems, it's actually less of an impact. This is the first row there. So in that column, you can see continent sourcing of, so something 2,000 kilometers away. And the right column is kind of more local, right? And you can see that the actual shipping of systems, so that means profiles, even glass, things like that, even if you're getting it from slightly further away, it doesn't make such a big difference, because those are elements that can be snugly fit into the lorry, into the transportation system that we're using. So you can see that the numbers there are fairly small. But when we think about our 10,000 square meter case study, and if we think about getting the units from 2,000 kilometers away, we should actually really be paying very close attention to this, because you can probably put 20 units on a lorry. So if you have 2,000 units, which is about the 10,000 square meter facade, you need to be making 100 round trips, 2,000 kilometers there and back, and that makes a massive difference. So you may do great work on specifying your materials, specifying where everything is, what kind of material you're using, but if you're not looking at the big picture, you might be missing something. So it makes a difference. So when you think about our standard case study, this would be the kind of very rough, kind of isolated example that I'm giving you about savings that you can do. And it all has to be, of course, part of the big thing. You can't just be thinking about your aluminium. You need to be thinking about your glass and concrete and everything else. But this is another thing that we can do. So coming back to our facade, I'm coming now to the end of the presentation, but you can actually see that these are not precise numbers, but it just shows you how big of an impact you can have. So if you have just, let's say, standard aluminium, not even low carbon, if you make that facade with 1 meter by 3.6 meter units, and if you're sourcing those from Turkey, the actual embodied carbon in the aluminium may be around 850. But if you double them up or triple them up, if you do 3 meters by 360, if you fabricate them locally, you will have half of the carbon emissions. Okay, so this is what I started telling you in the beginning of this. You have really, really big impact in the beginning. So think big and think smart. And finally, another picture by Alucraft from a building nearby. You need to be looking at the whole life carbon of the building. You need to be creating value, okay? So we shouldn't be really doing boring buildings that we will want to demolish in 20 years. We should be increasing the value. So build beautiful, build big, think big, and do it locally if you can. So that was it. Thank you very much.
Thank you, Stefan. Thank you very much. Moving swiftly on to our next presentation from Colman Billings. Colman's another well-known person that doesn't need introduction. Colman's going to talk to us about lessons learned from tall buildings and super tall buildings. So over to you, Col.
And mega tall buildings. So thanks, Stefan. Go big, absolutely. So going tall, start with why do we go tall? So back in the 11th century, this is San Gimignano, these towers were built by the ruling families, and it was to demonstrate their power, their wealth, their position in the society. There's only 14 of them left, but one of them is 54 meters. Originally, they were up to 70 meters tall. We can compare that to Dublin later on. We then jump to today. Why are we going tall now? We're going tall in places like Dubai as a kind of placemaking. Again, it's showing your technology, showing off your country and making it a place that people want to be and people want to go. But we really should be thinking about the density of people that we are now having to deal with in our cities, and that we should really be trying to reuse brownfield sites. We should be going up. Try not to broaden the footprint of your new headquarters, Stefan. Just go higher. So if we talk about the origins of tall buildings, they actually started in 1885, was the first building in Chicago. It was the first, it's deemed the first skyscraper. And this was where the structure, the steel structure in this case, was separated from the masonry, which was the original form of construction. And when you went tall, your masonry just got bigger and bigger and bigger. So with the advent of lifts, safe working lifts, and steel frames, they were able to go higher, and they were able to develop buildings such as we have the Guinness Storehouse. The Guinness Storehouse was actually the first Chicago-style construction in the UK and Ireland, and it's been very nicely reused and redeveloped by RKD, and you can see the steel structure which we sliced a pint out of a number of years ago. So if we want to talk about tall buildings, one thing we need to know is the actual names we should call them. So tall buildings are determined by the Council for Tall Buildings and Urban Habitat, the CTBUH, as something 14 stories and above, so 50 meters. So we have a few buildings that are just above that. High rise then is around 40 stories. Super tall is when you get to 300 meters, and mega tall is above 600 meters. There's a handful of super talls. There's less than that of mega talls. This is Dublin, to give you a feel for our heights. So Capitol Dock is 79 meters, EXO 73, then Google Dock 67, Millennium Tower 63, and Liberty Hall is 59, so not too shabby. If we look at Cork, the Elysian is 68 meters, and after that it kind of peters off. Look at Belfast, and the main event there in terms of height is the Samson Portal Crane, but the Obel Tower to the right of it is 85 meters, and if you go to the second last building, that's their hospital, which is 76 meters. So it shows you that you could do tall buildings which are very, very functional and make better use of the land, better use of your city, and try not to grow your city. Like if you look at Oslo as a city, they have made a green zone around the perimeter of the city, so nobody's allowed to go out into that. So the buildings have to be contained within a certain landmass. Then we look at the tallest buildings in the world. So Burj Khalifa, 828 meters, so it's a little bit taller than we're used to. But if you come down to the Shard, which is the nearest kind of tall building, it's actually number 166 in the world. That's residential, it's got a hotel, it's a living building, it's an operational portion of a city. It makes a lot of sense to do this kind of building if we're going to maintain the crazy growth in population that we're dealing with right now. But if we compare those to Dublin, we've a long way to go before we'll be actually building proper tall buildings. And then to compare those to what we're hoping will be the next tallest building in the world, which is on hold at the moment, but should be hopefully restarting next year, is the Dubai Creek Tower. We're not allowed to tell you what the height of that is. So when you go super tall and mega tall, the key factor that drives the building design and the structure design is high wind loads. When we're doing tall buildings in Ireland, we are dealing with quite high wind loads. We've got some of the highest loads in Europe. And doing wind tunnel analysis does a lot of work to reduce the effective loads and the design and the use of material for your building skin. So we're dealing with peak gusts, which are sometimes in Ireland, let's say we're 2.5 kilopascal. As Neil said, in Baku, we're up around 8, 10, 11. In Antarctica, we're seeing 10, 11, 12. So when we look at the issues with wind, one thing that people often miss, and you can get analysis on it, is wind-induced noise. So vibration of your facade. And we have a number of projects right now where we're looking at wind-induced noise. And it is something to be careful with. And certainly with the love of fins in Ireland, we need to watch out for the effects of those fins and what that does. When you go super tall, at the moment, with the environment we currently have, there's a risk of about up around 300 meters and above. You can get a thing called in-cloud icing. So you get super cooled liquid, which is actually below zero, but is still in a liquid form. And that, when it meets a surface, creates rime ice, and it's called in-cloud icing. So the image on the right is from the Mount Washington Observatory, which is in New Hampshire. And they use this in RWDI. They bring components up there and they experiment. This is actually ice building on the windward side of a structure. And when we do our super highly insulated buildings and we put them in this environment, we get ice growing on the surface of the building. Then that can fall off and that causes all kinds of trouble. If you're watching the news around New York over the last number of months, they had issues with ice falling off their buildings. In Chicago, they have it all the time. And as the Gulf Stream turns off, we could well start having to deal with this with our taller buildings. So then breaking it down to some of the more key factors in the design of any kind of a high-rise building, and just using a unitized curtain wall as an example, we have to deal with the sway. Certainly in tall buildings, sway tends to be more of an issue than we have, obviously, with smaller buildings. When you go very tall and very slender, then you can have something called sway, and then you can have something called slay, which is where the structure actually compresses, as well as racking, the structure is stretching on one side and compressing on the other. So you get a combination of movements, and those have to be taken into account in the facade joints. The other thing that happens is axial shortening. As the structure is going up, the structure will be compressing under its own weight. And this is particularly an issue with concrete structures. So we have to design the facade to take into account how quickly we are following that structure and how much time that concrete has to cure in order to judge how much dimension gets taken up in the joint. And this gets overlooked unless you're working with some very high-end facade contractors and making sure that they design their systems to take that into account. And it needs really careful coordination with the structural engineers and the main contractor. Because as you go up, you have to reset your facade to take into account that the structure has now changed dimension. The building on the left is a good example of how we should be doing high-rise. There's a retail level at the base. There's office levels at the podium. That's actually a steel structure with quite large span structure. And then above that is a concrete building, which is the tower with the residents in that. And what that resulted in was having to start one part of the building before the other was ready, and having to come back and having quite a substantial movement joint in the middle. The one on the right is the Wardian, which is a 54-story tower and another 48-story tower, and we followed the structure roughly 10 stories behind. In doing that, then we still have live load deflections after the building has been built, and so you get deflection of the slab, and we've all seen this image if you're a member of the CWCT, or you have swords that keep the panels vertical. But these have to be taken into account with the creep, because the slab will creep if it's a concrete slab. The columns are still creeping over time, and you've got the live load deflection. So all of these things go into the design of the joint. This is a building called Chapter London Bridge. It's student residence, and this is being built with unitized curtain walling, although we looked into a number of different methods of construction as well. And you can see here how the stack joint does its job of moving to take up the differential, which is all stuff you should all know already. Those kind of panels unitized curtain walling rely heavily on the gasketry, and those have to take up all of these movements, and they have to be able to take all the lateral and do all this for the life of the building. Now you can avoid all that if you go with something like a strongback. Strongbacks are not very popular anymore, but they were back in the 80s. And with that, you try and span from column to column, so you avoid the issues with the slab edge deflection, but you do have to deal with the sway. Now, in Ireland, we actually made these in the 1980s. In 1984, 85, up to the early 90s, we were making strongback panels and shipping them out to New York, to Philadelphia, and we did the Alban Gate building in London. And they were all Italian stone with insulation, welded up steel frames, quite lightweight and spanning from column to column. The modern version of that is precast concrete, which is not light, and you pre-glaze that, and trying to pre-glaze it and do it all off-site is great, but you have to then make sure that your building is able to take that. So this is Capitol Dock, currently the tallest residential building in Ireland. And if you look at the grid, it was kind of a double stack vertically architecturally, but the columns are every second bay. So it lent itself structurally to make panels that were double width, but architecturally it lent itself to going double height. Now, double height wasn't going to be an easy thing to manufacture, and in fact the panels are very, very heavy, so we ended up having to make it out of 4 separate panels that are interlocked, and the central column there ends up on a mid-span of a beam, so the structure had to be carefully designed to take that. So a real limitation of it was the weight of the panels on the structure. So you can avoid that by using something like the Buildus system, where the complete structure is precast. The skin of your building is an outer skin of concrete and an inner skin of concrete, and that is a structural inner leaf which goes with an entire structural model for the whole thing. It's very rare, very specialized, and you kind of have to hand over your project to them. Another method of construction is to do something like this. Is Mace with their hickory construction system from Australia. And what they do is they make a precast concrete slab edge, so it's about 2 meters deep. They stand a unitized curtain wall on the edge of it, and they have interlocks when they're building the building. These get lifted directly from a yard up onto the building, and that is your structure and your facade all going up in one go, and it's building the perimeter of your building. Straight off you have edge protection. All the external finishes are done ahead of time. Obviously, modular construction is another option as well. It's relatively limited in that there's very, very specialized people who can go tall. I think they're up at about 42 stories now. I think Pat Kerwin is in the audience. He can tell us more about it maybe later. But the issue with that tends to be that the column spacings are very small. So it works for residential, works for hotels very, very well, but not so much for office buildings. If we look at the Wardian, this was with wraparound balconies, a 54-story and a 48-story, 2 towers for Ballymore. And the system that we developed there was a window wall. Window walls are kind of popular in the US, but we don't use them much in Europe. But it made sense here because we had the balcony and the curtain walling. And in the procurement, the client wanted to keep the option of splitting the package, whereas we always wanted ourselves, technically, to keep the package all in one. And if we had been able to keep it all in one, we may have more integrated the structure into the unitized. But in fact, it worked out quite well. We made visual mock-up on the left and a technical mock-up on the right. Because there was so much repetition of this, it was like 100-odd stories of the same thing, we wanted to be really sure about the construction methodology. The other thing was on the visual mock-up, it was originally a building that was to be clad in GRC. There were concerns about quality control, color control, and the weight of the GRC. So we ended up developing with AkzoNobel, and Naveen is here today, a very, very specialized powder-coated finish with a little speckle in it to make it look like the original GRC. And the planners came along to see the mock-up on the left, and they were completely sold straight away. Not a problem to change from the GRC straight to the powder-coated aluminium, and that gave us a uniformity of finish. The other big feature on your tall building is always going to be the glass. And we really have learned a lesson lately that the color of the reflection of the solar control coating basically colors your building. So whatever, I mean, it makes sense when you just say it, but if you look at these mock-ups, what we did in each case was make sure that it was elevated and that you could orientate it to the correct angle, that you get a reflection of the sky, and make sure that you are happy with that color and with that reflection. We have a building at the moment where the architects are a little bit upset that they've ended up with a kind of a purpley building, but they did that as a cost saving from a more silver coating. In terms of what you then have to do once you've got past the architectural intent and working up the design, obviously we go into testing. You've all seen off-site weather performance testing facilities. The image on the right is another Baku job. This is not far from Neil's one, I think. This is the Crescent City building, which is an office building, and that does have 8 to 9 kilopascal wind loads on it. It's, again, cold bent, twisted, curved, seems to be a thing in Baku. But what we did do with this was we incorporated the replacement glazing system, which is a clip-on piece of glass. Because the wind loads are so high, we wanted to make sure that the replacement system would still take the same pressures as the basic system. When you get into high-rise, you're always going to be dealing with cleaning cradles. When you get to these kind of heights, it's no longer valid to go with rope access. So we've carried out on many, many projects where we get the cleaning cradle supplier to provide a cradle, and we then, working up the loadings with the facade access and maintenance consultant, we'll figure out what distance we need to pull that off the building, and then we'd throw it at the building. What we found actually was the sandbag impactor is actually a much higher effect on the facade than the cradle. And if you look at the next image, you'll see this is the sandbag hitting a terracotta tile, which is on a metal bracket, and the bracket had to bend to take the load and then come back. There's quite a lot of work done in developing the design of that so that we put all the load into the bracket and didn't break the fin. But it was absolutely fine being hit by the cradle. If you're going really crazy, you end up designing your building for hurricane zones, and then you're firing big pieces of timber at it just for a bit of fun. One other thing with high-rise, and particularly with unitized, is you need massive storage area before you come to the building. You need to get about 2-3 months worth of production in place, because you're going to catch the structure. You're also going to be putting panels on the building quicker than you can make them. The image on the right is a little pod that you can have a GPS tracker on your panels. So you can have tracking through the factory, and you can do that live depending on who the contractor is, what they'll let you do. But then you can place these in each stillage. So you have a GPS tracker of exactly where you are anywhere on the shipping. And if we're taking stuff from China, it's a particularly useful thing to have. But if you're bringing it even from parts of Europe, it's good to know your just-in-time deliveries, particularly with current sites which are so tight. You want to know where you are, how far away that package is, so that you're able to make sure there's access. And packaging up the elements to come to site is very important. Here we see a prefabricated balcony for Wardian. That was designed, and the height of the balcony when it's on its edge like that was designed to go through a hole in the core structure, which it needed to do once it came off the hoist to go through the building to come back out. And you can see the wraparound of the structure as the balconies, firstly the steel arms are installed, and then from then on we drop on the balconies, and that gives you your safe working access. And then you've got the guys installing the window wall on a safe platform. And we actually used the glass balustrade as the permanent protection. We took it that there would be a number of breakages, but it wouldn't be a big problem, and that worked out very well. You can see how complex the balconies are on the right-hand side. There's the drainage systems, the support systems for it, and we have a hinged soffit so that in the future those can be inspected without actually taking anything down off the building. When you're installing on high-rise, it's quite normal for the protection to go full height. I think we generally see it in Ireland as just a barrier up to here, but when you're going to these kind of heights, the wind loads are much higher, and we get things being lifted off the floor and thrown out into the street. You can see unitized panels, very tightly packaged. I think if you can package them that tightly, what we had here, this is 19 Elms in London, there were huge big fins that went on the outside, but rather than shipping fresh air, they shipped the fins tightly in a containerized units and shipped the unitized panels as thinly as we could. There is a rule that you try not to have any external access in these kind of buildings. You have to take it that you shouldn't really be using mast climbers, but you can, but it's much slower. But if you really do have to get to the outside, it's a very good idea to think about it properly, and this is an access method which is okay for small bracketry and things, but what you do see on a well-run site is that everything out there, everything outside that safety line is on a lanyard. So every tool, every component, every screw, all those pieces are tied to the building. And when we had to put the very, very large fins on 19 Elms, these are, we called them flying buttresses. They were actually made as unitized elements, and they cantilever off the building. But the way to install them was to create a very large, what we call a shark cage. And that shark cage is like a mini scaffolding around the outside, and that jacks up as you go up the building. So to get into the shark cage, you're just walking straight off the slab edge and you go in. And then when you're jacking the shark cage, all the floors get lifted up to one side and you're able to lift the whole thing up. So that allows you to do external access if you really, really have to. But if you want to go super tall, you go super tall. This is the Dubai Creek Tower. Its primary function is as a viewing tower. It's also a place-making tower to then build a whole series of residential units which will have a view out to this. So something nice to look at, something interesting, and it's a huge idea for a tourist attraction. It's primarily only for viewing, so that means that you've got about 600 meters of structure which is just getting you from one level up to the level at which you're actually going to have a floor. So super high-speed lifts, and as we do the concrete coming up from the base, there's strong back, big frames with aluminium perforated panels on them, and the perforations are carefully determined to generate eddies so that it doesn't have a single section all the way up. And that deals with dealing with vibration and loading of the structure. It reduces the load on it. But when you're up in the building, it's some areas of a mini hotel and restaurants, but primarily viewing. And the real fun is the rotating balconies with glass floors. We're talking about having anti-reflective coating on the outer glass, so it'll feel like you're absolutely out in outer space. And when you get to the very top, you have a garden, so you can hang out there on a nice evening and watch the birds come by. There is actually a facade access and maintenance strategy to get full-size trees to lift from ground all the way up to the garden, should that be required. And that's going tall.
Thank you very much, Colman. You've covered a lot of ground there, and I'm sure you'll get clobbered at lunchtime for some questions. But I will move on straight away, because we are running a bit late, to our final presenter before lunch. We're very delighted that we have an architect to make sense of all this technical talk that we've had previously. It's Merritt Bucholz. Have I said it correct?
You have not, but that's close enough.
Great, good.
Bucholz.
Bucholz.
Yeah.
Will talk to us about environmentally responsible facades.
Thank you. Thanks very much. This is Apollo 11. It's about the same age as me, which is mid-50s. And I mean, I think about facades. It's one of these things that this image has always fascinated me. The whole project of putting somebody on the moon has fascinated everybody, I guess. But I think, buildings are like spaceships. They They protect humans from, kind of an unforgiving environment. This one in particular is incredible concentration of technical know-how, innovations, inventions, things that we'd never thought of before. They reflect nature, and they reflect something of our ethos, something about our ethos. So I think of buildings like spaceships and facades. Obviously in a spaceship it is the most, think of it as a facade, but I guess that's an interesting way of thinking about this object and what we see in this image. On the other hand, buildings are like eggs. They're things that are made of natural materials, or at least ones that we win out of nature. They breathe. They transmit water vapor, light, nutrients, oxygen. These are all jobs that a facade should do. Much of the work that our practice has been working on has been about getting facades to breathe and to make buildings like organisms that are somehow in tune with the rhythms of nature, because at the end of the day buildings are occupied by people who are natural beings, and the connection with nature isn't just about seeing it, it's about inhaling it and about exhaling it and about all of the fibers that connect we as humans to the world. So I think that neither of these examples is kind of like, well, this is the way that it should be, but they serve as kind of useful poles, thinking around, particularly the space that construction sits within, and what we can do with our facades to allow our buildings to breathe. So I just kind of take you on a hopefully short journey through some of the ways in which we've tried to address this, and these are mainly, not all office buildings, and they're all decidedly low compared to what we've just been looking at. So, and most definitely, well, except for the last one located in Ireland. This is a 2005 project for the SAP Galway, SAP building in Galway. It is a naturally ventilated office building, and maybe just to talk a moment about how that actually works. So it's two office floor plates of 3 stories next to each other, separated by an atrium. The atrium is not heated, so all of the supply air for the building comes through the facade. So there's no mechanical ventilation, no mechanical extract. So we're completely relying on the facade for the inhaling, I call it, the aspirating aspect of the ventilation system. So of course we're working with engineers Transolar in Stuttgart to kind of develop the physics around how this works vis-a-vis the building kind of physiognomy, if you like. The facades then are have to deal primarily with 2 conditions. One is kind of let me say reasonable temperatures, neither too high nor too low, where effectively the air from the outside can be let directly in. So we're talking about temperatures maybe 12 to 18 degrees. After that, because the outside air temperatures don't always exist in that range, we added a heat recovery device into the facade. So the top diagram shows how the natural ventilation system works during most of the year, where the windows are simply opened in the facade. There's obviously an inner facade to the atrium, and then the pressure difference between the outside and the outside space in the atrium drives the ventilation. In peak seasons, i.e. cold or when it's very cold or very hot, there are decentralized heat recovery units in the facade which take the recovered air from the office space and blend it a little bit with the outdoor air. So particularly in the wintertime when we have high winds, this is in Galway, it's quite close to the airport, so when you have relatively high winds and somewhat uncomfortable conditions for opening the window. So this then, these decentralized units push the air underneath the soffit, and it's extracted in the same way as when it's operating in standard natural ventilation mode. So you can see in the photograph on the left-hand side, the heat recovery unit is the panel at the top. Little sketch to the left of that shows the box. It was made by trucks. And then below that is a panel, which is the natural ventilation panel that people can open. And then below that is a convection heater, which is actually not, it's incorporated into the facade, but it isn't actually part of the facade system. So the facade is 3.3 meter high by 1.5 meter wide pieces of glass held by Iroko frames. Where we have these heat recovery units and ventilation panels are plywood wind posts, which are taking the lateral load and allowing us to reduce the frame size of the Iroko frames. They won't span quite that far with that size glass. And then on the outside, there's a certain amount of shading, which are cedar brise-soleil. The building is oriented along the north-south axis, so you need to have vertical shading in the morning and in the afternoon. There's very little south elevation with exposure. And then the photograph on the right-hand side shows the inside layer that opens to the atrium, where it's simply a panel vent at high level, which is connected to an actuator, and the one that's open there is the manually operated one. So I think this is an image of it from the outside. The facade, you see the brise-soleil. There are areas that are simply clad with cedar cladding inserted into the concrete frame. And this is the atrium space. It's quite important. You obviously notice that all of these things are made out of wood. In this case, it's 2005, so the building couldn't be made out of wood. But part of the reason for using wood is that it's a material that people recognize and have an intuitive sort of connection to. When you have to make a facade that people are interacting with and using to ventilate the building and from which fresh air comes, it needs to be understood not as a technical thing, but as a source of air and of some of it must act in a way like the egg that I showed. In other words, people must know immediately what to do without kind of a long explanation. And I think this is something that the use of timber communicates a little more directly than aluminum does, and is one of the reasons that we tend to prefer it. The very similar principle in terms of how the facade operates at the project that we did in Elm Park, as I just explained in SAP in Galway, without the atrium. So in this case, we have long office floor plates, 110 meters long by 14 meters wide, 15 meters wide in certain parts, without atria. So these are simply cross-ventilated. And in order to ensure that the cross-ventilation works, there is essentially a kind of a preheat facade on the western elevation, which has an outer layer of single glazing, an inner layer of blinds, and then at the slab edge, double glazed units with panel vents. And the panel vents have a high and a low level opening. The low level opening is manually operated. The high level opening is operated by the BMS. These buildings, similar, in fact, exactly the same as SAP Galway, get all of their supply air from the outside, so not mechanically ventilated. which means that we have a slightly different condition on the east than the west, because obviously we are driving the ventilation in one direction with the thin atrium or the preheat facade. It's also wind driven throughout much of the year because of the high winds that we have in Ireland, but it also operates under solar stack effect when the sun comes out and blinds go down. There's quite a bit of cladding, timber cladding to the south and north elevations, which is simply large with a certain amount of limited openings. Normal in this process of trying to put these facades together is the construction of models in the office, and I think it's how we try to understand, or how we try to get closer, a little bit closer to the construction of things, kind of quite apart from the testing and the kind of processes that these buildings go through. But I think to make something that people understand and are kind of familiar with without, let's say, technical explanation, it's important that we work, it has been important that we work through these things in model. I'm just going to, let's say, show a couple of smaller projects that get a little bit more into the timber facades that we have been doing in the last 6 or 7 years. So this is a project that for Dunleary, Rathdown County Council. It's the Ballyogan Operations and Maintenance Depot. It's 2012. It's a timber frame building that is the lateral support comes from the concrete cores, 2 concrete cores, but all of the columns and beams and slabs are made out of plants, trees. So in this project, there's it's largely facing south, so it's quite exposed to the 3 Rock Mountains. It's just to the south of the project. And the south facade opens pretty much entirely. It's a narrow floor plate building, 12 meters deep by, it's 55 meters long. It's also cross-ventilated, but because the orientation, the site was quite constrained, the orientation, we didn't really have the opportunity to shift the orientation of the block around too much, so it's facing south, so we had to protect in some way the facade from the wind and allow the openings to open even in relatively high winds conditions. So you have this is with these large sliding doors, which are all which can be opened completely on every level. You can see that they work kind of like a patio door or something like that. This is on the south-facing side, and then on the north-facing side, you have 2 levels of panel vents, one at the bottom, which is manually operated, as is shown here, and the one at the top, which is operated by the BMS. So again, you kind of avoid mechanical ventilation completely, avoid air conditioning, avoid all those kinds of machines, and the facade breathes. Right across the street, basically, from this building is the Samuel Beckett Civic Campus. It's not an office building, it's kind of a mixture of different uses. There's a library, community center in phase 1, and then phase 2 is a swimming pool, sports hall, and so on. So they're quite different buildings, but all with the same facade, and both buildings are naturally ventilated through the facade. So I think what's interesting about this project is the fact that it was, from a facade perspective, it's a timber prefabricated modular system that hangs on this wood frame on the upper floor, which sits on a concrete kind of plinth, basically, as you see in this model. So we are trying to, I suppose, come up with a facade bay that you could naturally ventilate spaces as different as a sports hall or a library or a community center, but all kind of look the same or use the same components and parts. So we developed this small model idea of a piece that could hang, and that was on site, became these 1.5 meter by I think the tallest ones are 7 meters, prefabricated units that were made by Gem Joinery in Longford, and then transported to the site. Most of the, so this is it kind of being erected. Because these prefabricated panels have quite a lot of different types of openings and so on, and we had it tested in Windtech. So this is the bits of wood were not hurled at it, but it was definitely a hurricane that was thrown at it. And I can share with you that it didn't pass the first time around, but it did eventually. I think this is interesting because when you're making facades out of wood, with wooden mullions and transoms, and you have complex things to incorporate within vis-a-vis opening sections, vents, louvers, and so on. You have to test them, and it's a test by each specific unit or each building is bespoke when they're made in this way. However, it's well worth it. So these are this is an image of the section through the facade. You can see it's hung on from the top. There's a bracket which is fixed into these units. Sit against a CLT upstand, and there's a cup detail at the bottom. So the weight of the unit is taken by the concrete slab at the bottom with a kind of stirrup detail. And then at the top is basically just a restraint. So you see them here being kind of pushed onto the site. You can see the brackets. Well, the brackets at the bottom that you see coming out are actually for brise-soleil that get attached to it. But behind that bracket, you can see the cup to which the panels are fixed. And the cladding is Canadian Western red cedar, and we were looking a lot at the tradition of, how do you deal with the Irish climate and timber cladding, because it is quite challenging, I think, to do horizontally banded timber, because long lengths don't do well with water. So this pointed shape works a little bit better in terms of getting water off, and by tilting the orientation of these are all solid panels. The one above is not fixed, it opens. So all the glass is fixed and all these panels that are solid actually open, which is something that we've taken to doing because it's much more cost effective to open a lighter weight section than it is something that holds glass, which is obviously really heavy. So anyway, but this is we found a very good way of making a facade that was extremely durable in terms of the weather, even though the material itself is quite soft and quite lightweight. So from a carbon perspective, this is a carbon negative facade because it uses so much wood. It's quite interesting when you start to look at the carbon profiles of timber structured facades and cladding systems. I mean, not just the facade, things that hold the glass, the frames, but also the insulation and the products that are used that you don't see. It's very interesting how those are becoming, much more relevant in terms of how we deal with moisture in Ireland. Thinking back to the egg. So, this picture is sort of about the facade in the sense that you can see the wood beams supporting this 3 meter cantilever of precast concrete, and and the facade as well. So it's quite a robust robust way of building. All of the units are made structurally are made out of glue laminated larch, and then the cladding on the outside is cedar. There's a certain amount of Iroko for the large frames, which are backed in plywood, with panel vents incorporated into the underneath it. I won't explain the ventilation system too much, but you can see some of the operating vents here on the inside of the building. So the last project I'm going to talk about briefly is one that we're doing in Toronto, Canada. It's not quite finished yet. It's the headquarters for the Toronto and Region Conservation Authority, so they're basically kind of like a local authority or municipality who are responsible for the watersheds. There are 5 watersheds in Toronto, and they cross all of the boroughs, so all the planning applications which are made for buildings in Toronto go through this organization to make sure that they aren't damaging the watersheds and the ecology of the city, which is basically carried in these ravines which drain the city of Toronto to Lake Ontario. It's a completely timber building, including the facade, which I'll talk about in a minute. And I think it's just interesting when we arrived there how should I say it? Toronto has a climate that's quite harsh. It's can be -20 in the wintertime, can go into the high 30s, even 40 degrees in the summertime. And the way that the economy has developed, they're building quite a few condominiums in the downtown area that are quite tall, and I think they are struggling with the density, some of the density questions that we're all struggling with. But it is definitely a curtain wall sort of city, becoming that. And you see nestled inside all of these curtain wall buildings are these little brick buildings, which they call brick and beam buildings, and they're basically built in the 19th century kind of warehouses with brick walls, but they're wood on the inside, and they're quite nice buildings, and they're recently are protected. So it's quite interesting to think about we were thinking a lot about, well, how can we work with kind of what's there. The site that we have is outside of the city. It's actually along one of the ravines. I mean, when I say it's outside the city, it's still in Toronto, but it's not exactly in the kind of downtown area. It's along one of the edges of the ravines. It's this fan-shaped building that steps down towards the ravine edge. It's also naturally ventilated, which I think this is really where the facades become, sort of hyper important because of the unforgiving nature of the climate. Clients are very forgiving. The climate, as all clients are, the climate was quite a challenge. So this little sketch in the upper left-hand corner gives you an idea of how the ventilation system works, where we have basically supply air, which is being brought through the facades in the green boxes there, and then extract through these 2 atria, which are kind of between the 3 fingers of office floor plates. You see the little diagram with the sun on it. So the building is, if you think about a breathing thing, it's breathing in through the facade and out through the atria, which we think of as a horizontal facade that incorporates what's called, or what we have christened, I suppose, a water wall, which is going to help us out when the temperatures get too high or too low in terms of fresh air supply, and a solar chimney, which is all about making sure that the ventilation is working all year round with the sun, because unlike Ireland, Toronto has much lower average wind speeds. So this model that you see on the right-hand side is taken through the 2 atria, so you get an idea of one of the water walls sitting at the end of the atria. There are actually 4 water walls, which work in conjunction with the facade. So the section of the building kind of steps down towards the ravine landscape and opens out a little bit towards the south. This is a section going the other direction, so this is kind of looking along one of the atria. So for the extract, just go back a sec. The facade works in two main ways. One is pure natural ventilation, where the windows are simply opened, and there's a little detail in that, but the windows are opened, and then the atrium acts as an extract. So it's very similar to what I showed you in SAP Galway. And then when the temperatures are either very high or very low, the supply air is coming through the water wall. So the water wall is basically a glass duct with metal mesh suspended within it, which is shown here. Yeah, so a glass duct with metal mesh suspended within it, piggybacked on below. It makes sense if you piggyback below, but on top of that is the solar chimney, which is driving the extract air from the building. So the water wall is connected to decentralized ventilation units. So underneath the floor void, there's a unit which basically takes the air which has been either heated or cooled, depending on what time of year we are, and distributes it in the raised access floor, which is a plenum around the office space. And then the atrium still acts as extract. So the main supply air when the temperatures are above 20, 24 degrees or below 5 degrees is the water wall, not the facade. However, in order to extend the period of natural ventilation, I'll talk about the cladding in a second. In order to extend the period of natural ventilation, along the south facade we added a preheat zone to preheat the external air a little bit so that when the temperature was getting to be below 5 degrees, you could still open the window. And this is quite important to allow the facade to perform all year round and extend the natural ventilation period and minimize the amount of time that the water walls would need to be employed. In terms of cladding, we looked a lot at the TRCA. The client for the building happens to own, among many other things, maple sugar shacks, which are made out of Ontario eastern white cedar. They have quite a few of these buildings right nearby, so we decided to adopt this as a way of cladding the building. Building built in the 1850s is being repaired about the year before we got there, so we kind of thought, well, if we build this building now, in 150 years, they'll still be able to repair it if we clad it this way. The provenance of wood in Canada is very complicated. The TRCA has a mission to purchase wood from First Nations peoples, which is Ontario. You see the red in the diagram in the upper left-hand corner. Is an enormous province, but most of the timber that comes from Ontario is First Nations timber. So we found a mill within that giant red swath from which we could get the cladding. So it's basically shakes, shingles, very rough. Some of it's cut with an axe, and this is what we're going to be cladding the building in. The diagram at the top shows a little bit some of the details about the preheat function of the facade. The windows are actually made about 5 kilometers from the building site in a fiberglass window company. So all of the windows are made out of fiberglass. And I said that the Samuel Beckett facade is a net negative facade. The CRCA facade is even more negative. And it really hit home when we started to look at the figures. This is a building that's really focused on zero carbon. It's a zero carbon frame, zero carbon cladding. In fact, it's net negative. This is what it looks like today. The only concrete is the floor plate. So it's somehow we hope the future. Thank you.
Thank you very much, Merritt. That's really fascinating work you're doing. It seems quite honest and classic work, and a lot of timber there, and also a lot of local sourcing, which is great to see from a sustainability point of view. We're going to break for lunch. Ideally, we would like to come back at 1:30. 1:30, that'll be a tall order, 35 minutes for lunch, but please try to come back at 1:30 and we'll resume after lunch. Thank you. We'll crack on with our afternoon program. We're going to start looking at urban facades at Dublin landings in the safe hands of John Hanley from RKD. John, over to you.
Thank you. Good afternoon, everybody. Dublin Landings is just a little bit down the river. I think most people will know where it is. It forms part of the Dublin Docklands Strategic Development Zone development. It was one of the first large-scale developments that followed on after the central bank headquarters development in this area. It's an SDZ. It's governed by a strategic development zone that requires 60% of the development area as commercial. and 40% as residential. So we have about 65,000 square meters of offices and 37,000 square meters of residential over basements, and so it's over 100,000 square meters in total. So in the time available, this is going to be a very quick gallop through what was quite a large project. The building heights and development areas were maximized in accordance with the requirements of the STZ planning scheme. So we were allowed 10 floors to the riverfront plus a setback penthouse, and for the commercial and sorry, it was 8 floors plus setback for the commercial and 10 floors plus setback for the residential. So in terms of the master plan objectives, the basic requirement was to provide a dense mid-rise city district. We had a real focus on animation at street level. One of the fun things of the project was forming new city streets, which our clients got to name. So we have Slate Street and Fish Lane added to the lexicon of Dublin streets. This is a photograph of the Central Plaza area with 2 of the office buildings, Dublin Landings 2 on the left, Dublin Landings 3 on the right. You can just see the quality of both the landscaping, the soft and hard landscaping. Also to note the way that the office entrances form an extension of the public realm, so that we get this kind of well-integrated new urban environment. I suppose this entire presentation is really showing an example of good quality facades utilizing established materials, products, and design strategies. So in a way, it's a kind of a baseline to measure some of the more unusual projects that are being presented today. But in terms of the facades, a key objective of the scheme was to achieve a real traditional city variety in the facades. So we have 5 office buildings which wrap around the pre-existing central bank, and then to the east of those we have 8 residential buildings, starting with a taller tower on the riverfront. And even within those 8 blocks, there was a push to have different facade elements in the larger blocks. So the idea was to get an enormous richness in terms of the experience of this new quarter of the city. So just dealing with the commercial buildings first, they're simple, deep plan, but light-filled office floor plates, and they all focus on atria. On the left, Dublin Landings 1 and 2, which are the riverfront buildings, and on the right, Dublin Landings 3, 4, and 5, which are at the back of the site facing onto Mare Street. And just very briefly on the residential apartments, it's a mix of 1, 2, and 3 bedroom units. Usually from about 5 units per core to maximum is 12 units per core. So the construction history, it started with Dublin Landings 1, the building right next to the central bank, and the development took place in phases from 2016 to 2021. The actual completion was delayed for about a year by COVID, so it should have been finished in 2020, but it was quite a gallop. So just very briefly in terms of credits, the Ballymore Group were our clients. On the facade design side, the core team, besides RKD, were Arrow, a Copenhagen-based firm of architects, and Pat Duffy of Arab Facade Engineers. I'd like to pay tribute to the role that the owner of Arrow Architects, Ulrich Rass, played in the he drove the aesthetics and development of the facades, and Pat Duffy for the wonderful work he did on the technical design and realization of the scheme. In terms of facade contractors, Gunn Lennon were responsible for almost all the commercial buildings, and also the Riverside Tower on the residential side, and Techrete were very important on the commercial side, and then there were numerous other contractors. So just starting with the office buildings. So Dublin Landings 1 is a brick and metal building with about 50% of the facade area in glass. This allowed us to provide a very transparent, to use a very transparent glazing specification. The other features are a double height entrance loggia, and with these great big exposed steel columns. The idea was to refer to the historical Docklands materials in both the use of brick and steel in the facade, while still presenting a very sleek modern office building. So the building is now the headquarters of the National Treasury Management Agency. The facade, just a greater level of detail. The brick elements are all precast by Techrete. The punched windows, as you can see, span two floors vertically, and they include anodized aluminium side panels, which then reduce the extent of glazing, so it's around 50% of the overall total. And there's just some information there on the type of glass we use, which is super clear and floods the inside of the building with light. There was a huge amount of effort put into the specification of the brick. I think all the brick manufacturers in Europe were combed. Eventually, we settled on a German manufacturer called Hagemeister. This brick is called Dallas, and it's a continental brick size, so it adds, I suppose the Copenhagen influence in the design in some ways comes out in this. And then moving on to Techrete, you can see this high-level loggia, the way that the brick is actually carried around in this kind of open colonnade, and also was carried onto the back in hand-built brick, but otherwise all of the brickwork was factory finished on the precast concrete elements, and there was a huge emphasis on making it look like really high-quality hand-built brick, and I think that we were successful in that aim. Ballymore, as we've seen earlier in this presentation in Colman Billings, referenced as the Wardian, they are very, very focused on quality control through using samples, and full-size samples. You can see the bottom left there. They're actually two-story samples of Dublin Landings 1 is the dark one, and Dublin Landings 2 is adjoining building, the white brick. So that was, again, a very successful discipline in terms of the progress of the design. And another real challenge on the design was the objective of having an absolute glass box pavilion as our penthouse. And I mean, we all know that a glass box does not work in environmental terms, so how are we going to achieve it? In fact, we did make it work, as you can actually see in the photograph of the fit-out at the top right there. It was largely through an enormous amount of computer analysis and the development of fritting and graduated frit, and we looked at about 20 different patterns, and we ended up with a pattern that passed all of the tests. And we made the top panel into a solid spandrel panel at the junction of the roof, but the way the fritting grades through to the dense, continuous opaqueness of the top spandrel actually succeeded in making the whole thing seamless. So we were quite pleased with the way that worked out. Another interesting element of the design is the use of a 1854 map of this particular area of the Docklands as a decorative theme for a very, very large double height decorative screen at the main entrance. And again, the techniques were quite interesting. What we developed was a series of vertical aluminium strips, which were part routed to create the visual image. The really interesting thing is that it's, you only see the image from the east side. You don't see it from the west side because of the particular way, and it also depends on the light. So it kind of is there, it's not there, it's there, it's not there. It really worked well. And we have these at the entrance to 3 of the 4 commercial buildings. Very quickly, these are construction stage photographs of the atrium in Dublin Landings 1, and a very quick shot of the finished atrium. I suppose the point being that the roof lights in all of the buildings over the atria were also part of the facade contracts, and so we're part of the envelope. So, moving on to Dublin Landings 2, very briefly. View along Fish Lane, looking at the double height entrance again. The building in terms of the facade designs is essentially a repeat of Dublin Landings 1. You can see a progress photograph of the Techrete panels in progress, and this is one of our, I think, 6 site test panels in terms of the particular brickwork, the particular pointing, and so on. There's an aluminium panel to the side of the windows to reduce the extent of glazing. You can see it more clearly in this photograph on the right with our friend, the rope access cleaner. And I think that the vertical element, which is at the junction of the window and the side panel, really adds to the 3-dimensional kind of shade and light play on the building. So the next 3 buildings we'll go through quite quickly. Dublin Landings 3, 4, and 5. This is a south view to Fish Lane. Dublin Landings 3 on the right. Dublin 4 and 5 were subsequently purchased by the Central Bank of Ireland, who are currently fitting them out as an extension of their headquarters, including a bridge. So their work included some changes to the facades as well. So I won't dwell on those. This is a design stage image of Dublin Landings 3, which has a series of fins and trapezoidal sections, and a photograph of the finished building. Gunn Lennon, again, were the facade contractors for this job. And again, we used highly clear glazing, which was slightly different in its spec for the previous jobs. Another view of the completed building. Another feature of this particular design is the horizontal bands formed every 2 levels, which were originally to be GRC panels, but in fact, in the end, became aluminium with particular Axo Nobel textured matte powder-coated finish. And again, it was actually, this particular paint finish was based on the Wardian, which has been mentioned earlier. It had a kind of like a slight fleck and a texture in it, and we were very pleased not to have to actually change the materials, to do everything in a single suite of materials, the aluminium system, but in a way that actually achieves this contrast in terms of the texture of the various elements. Just a quick design stage sketches of the 2-story elements, and you can see that the intermediate floor is very much suppressed in terms of its, we'll come to that a little later. The fins and trapezoidal sections were effectively a decorative application to the fully weathered facade. So if you look at the construction stage photograph on the right, you'll see that sort of galvanized finish element is the fully weathered facade finished, and then these are applied as rain screen elements. Now they do have a positive contribution in sustainability terms, in terms of controlling solar gain, of course, but they're reasonably monumental, but I think are highly successful in the finished facades. The main entrance to Dublin Landings 3, again, a high double height space with, you can again see the way that the map motif, not alone is taken along the side wall, but it's also taken across the soffit. And we avoided any lights in the soffit itself. And again with another great big steel, chunky structural element that continues this reference to past Docklands kind of materials. So just a very quick view inside the reception of that building, and you can see the way that the finishes of the external facade, those anodized finishes, are carried through into the interior, so it kind of just adds to the richness. We're very pleased with the anodized finishes on Dublin Landings 3 because there's a natural variation in anodized finishes. So the fins and the trapezoids and so on, you can actually see we just got this lovely richness and texture to the entire facade. Last thing on DL3, the ESB, well, they required a couple of enormous substations on Mare Street, which is kind of an important thoroughfare at the edge of the scheme. And we were quite unhappy about the idea of having all these ESB doors opening straight onto this prominent facade, so we developed a CNC cut decorative screens. Again, rather like the other elements, the decorative screens at the main entrances, we were able to use digital technology and the information that we produced on our computers, as it were, was fed straight through into the manufacturing process, and it actually allowed us to achieve this kind of richness with really very, very tight budgets. So finally, on DL3, in contrast to the penthouse of DL1, it was decided to put a little bit more solid meat into the facades in DL3, so there was a whole series of vertical fins, which meant that we didn't have to get into any particular standing on our heads on solar gain and fritting or anything like that, and so that worked pretty well. Dublin Landings 4, just in passing, an image of the design on the top right and a progress photograph of the building before it went into kind of an alterations phase by Central Bank on the left. And moving on to Dublin Landings 5, the only thing I want to talk about again is the fact that it's kind of a continuation of the themes of Dublin Landings 1 and 2 with the use of Techrete panels with a very rich brick selected, again, a continental size. In this case, it was by Gima, and the brick is, and besides the brick, we, instead of having a flat side panel, it was a canted side panel, which just gives the building a kind of a different facade expression. One of our challenges in all of these buildings was actually suppressing the joint, because in every case, we in 1, 2, 3, and 5, we have these double height windows, which where we didn't want to actually express the floor plate. So this is one of Pat's sketches as to how, Pat Duffy's sketches as to how we deal with this. So you see the edge of the floor slab, and it's hard to read, but there's a whole line of fritting. I think I have a laser here someplace. Just at the back of the glass above the blind box, and then that goes up past the siderise fire barrier between the floors. And in fact, it worked extremely well. In reality, all you see is the really thin transom. You don't really see the junction between the floors. So moving quickly to the residential blocks. As I said earlier, the objective was to achieve a real richness and variety in terms of the expression of the blocks, and on the left you can actually just see an idea of that. The E1 building, I suppose, is the kind of star of the show in terms of the residential, and it has 2-bedroom apartments to the riverfront and balconies with screens. We've incorporated kind of like metal elements into the balconies, which are then carried out into the base of the building. So here's some images of how we actually got the decorative metal elements to run down through the brick base, and a view of the top floor penthouse level with its wonderful views. This is interesting. On the left is a design stage CGI. On the right is the finished development in terms of what the courtyards look like. So I think, you know, we kind of realized our vision in terms of the way the buildings look. It was a pretty much conventional build, the residential. There weren't really any prefabricated elements. Again, a huge emphasis on samples. The facades were relatively simple, lots of brick and then metal panels inset to just give a bit of variety. Here some views of the detailing, straightforward, fairly lightweight construction with SFS backing to the facades. One feature of the design are these sky villas, two-story family units, 3 bedrooms, extensive living rooms, lots of lovely terraces. Some images of the portal frame and the SFS in terms of building those, and then some details of the rain screen metal panels that then we had BMO standing seam roofs, and a lot of fun detailing the facades where they met the steel frame, particularly in terms of fire. So finally, the Block B, general courtyard views, really very much a continuation of the interesting thing about this particular building is the application of kind of like these picture frame articulation, just to actually give the rain screen some real variety. Concealing it was an MVHR ventilation system in the apartments, so concealing the vents was really important. And the projecting balconies were a real design challenge. You can see on the left, they were well worth pursuing, tied into the structure through shot thermal breaks and so on. So, the design went very much into that design quality, followed through into all the final details of the project. So, just in conclusion, the buildings really were set out to meet the requirements of the building regulations, which, particularly in relation to residential, now set an extremely high bar in terms of sustainability and so on. The analysis that went into solar control, fire safety, and so on drove many of the aspects of the design. But I think that the development shows that even with these requirements, that we can achieve a mid-rise urban development that will all come together to provide an exciting new city quarter. Thank you.
Thank you very much, John. That was, I actually walked through there yesterday evening, and the spaces between the buildings, it's a wonderful environment, and the buildings, if there is a typology, a modern typology for residential developments, this must be it. We see this now in a lot of locations, not just here in Dublin. There's a lot of buildings like this all over the United Kingdom as well. Moving swiftly on to our next presentation, which follows in the theme of retaining buildings and refurbishing buildings by putting over facades onto existing buildings. So I'd like to invite Tom Gray, who's the founding partner at TESS, to tell us a little bit about over facades.
Thank you. First of all, a slight ambiguity on over facade, perhaps. I spend my working day in French because I live in France for the last 30 years. And what I meant by over facades was more, when we talk about double skin facades, sometimes it gets very complicated, and sometimes it's easier for people when you're conceiving double skin facades. So just think of it, I have a facade which is a thermal and weathering envelope to which I add another facade, which is more of an architectural way of describing it perhaps. So basically I'm not as well known as all the other presenters, so I just want to say two words about myself. So you say, who is this guy? Basically, I'm a graduate from UCD Architecture School, and I've spent the last 30 years in Paris, having spent 8 years in London. And for half of that time, I've worked with a company, RF4, Rice Francis Ritchie, and with Rice, which was a company founded by Peter Rice. And while I was there, I very much worked on projects in Ireland. Merritt didn't show this one earlier, but it was his first project in Ireland where the classic RF4 cable technology got brought in, and one down the road, if you turn right when you go out to the Convention Centre. So having worked with those companies with RF4, then 15 years ago, co-founded with 2 other directors of RF4 a company called TEST, which is Technique, Exploration, Surface and Structure. And we were basically well known in France for being the people who work with Frank Gehry a lot. We did all this glass parametric. Neil, we can talk about parametric geometry later. Although I must admit my partners are much more involved with that aspect of the project. But we also do, at the moment, while I should really, thinking of the presentations earlier, I should really have done a presentation on a little project I'm doing, renovating a base in the Antarctic, and the carbon footprint of the transport and the wind and everything. It probably would have been a more appropriate image rather than this, which is a totally gratuitous carbon footprint project. But it does bring up the point, where do we all build buildings, like Pat says, should we go the Copenhagen way? In the end of the day, you can justify these buildings by saying they're sculpture, we're leaving something. I was reading Joyce's, Yeats' Sailing to Byzantium the other night. I was a bit depressed and I got out Sailing to Byzantium and it cheered me up. And you do need things, we do need to leave a legacy. We do need to leave monuments to the future. So there is an element where, in all our current obsession, which I share totally, we have to keep an eye on the essentials of the project. And so with TEST, we've continued, probably less intensively than with RF4, but we've continued working in Ireland. These are nice glass fins, 8-metre spanning glass fins, which this is showing in National Gallery that in the in-plane, stiffness, all the loads in plane are transferred through the silicon joints longitudinally. What I want to do is just talk about one aspect of our work. I have been lucky enough over the last 30 years to have worked with a lot of really interesting architects on double skin facades. And an architect once said to me, the problem with these double skin facades is the Germans invented this technical thing, and we're all having trouble understanding it. And they are a bit complicated, but they're still very, very pertinent in that in the current French regulations, you're obliged to have external shading in residential, and you will progressively have to have it in all office developments. So external shading is buildings, if we want to reduce, we still have to, we can't take our eye off the ball because we're now passing on to the embodied energy. The the energy and exploitation, sorry, it's a new vocabulary, carbon in English for me today. So we still have to, the operational energy, that's what I'm looking for. So the operational energy still is, we still have to deal with it. And if you do, okay, you can just say, well, we'll do 40% glaze. If you do want a fully glazed facade, which has in high-rise buildings a big advantage of just, it is absolutely wonderful to be looking out a high-rise building when you're on the top floors looking out. So that those glass facades, if we do keep building them, they will more and more need external shading. And those external shading, they at high-rise have problems, so you protect them with an outer sheet of glass. That kicks in a whole load of secondary effects of the space heats up. We got problems with the space heating up. We ventilate. You ventilate, but the air is too hot in the summer. In mid-season, it's Lovely. You got, are you really getting thermal insulation, fire, you get fire passage going up, so on. There's a lot of acoustics. I could go on and on and on. But what I want to say in a way is that rather than talk about the technical aspects, is that we forget that they are fundamentally architectural. And the architects are a bit uncomfortable in appropriating these very technical objects because they're bombarded by us talking about acoustics and whatever. So what I wanted to just share with you guys today, and women, sorry, is this idea of that as well as having the artillery of technical topics of fire, acoustics, we also have to develop a vocabulary of architectural themes, and which come up in designing these facades. So when I was doing a competition for this tower in the centre of Paris, we took an office around here during the period, which went on quite a while, the competition stage, and we talked a lot about how we would reskin this facade. So it's basically a very good, unfortunately Mies van der Rohe did not do it, but the glass was probably the same, Ronan. The tinted bronze glass has a great advantage that in France, they don't like sprinklers in high-rise buildings. And if you negotiate with fire people, they just say, no one's ever died in a high-rise building in France. This is how we do it. And how they do it is they have a fire barrier. They have a fire barrier at every floor, which is a 1.2 or 1.5 meters high, depending on the combustible mass, which is why I want Schuko to develop less combustible thermal brakes, please, because it's a big factor in calculating the thermal mass, which decides if your barrier is 1.5 or 1.2 meters high. So that's hidden in behind the facade. So when I was talking about these guys, we just talked about facades, and what are the architectural themes that come up? Well, the first one is scale. So a good example of this is the Kildare County Council, where with Shifu and Roisin, this over facade here quite simply breaks the scale of the building down. What is primarily an office building? Office, as someone said, architecture is horizontals held on verticals. You know, it's hard to just not express the floor, although RKD managed to conceal it very well. How do you get away from this reading of just stacked up floors? And it's a bit like Michelangelo on the Capitoline Hill, where he just invented the pilaster, which goes over 2 floors, and the whole building reads as one entity, rather than the Colosseum, which is a piling up of the orders. So it does break down the scale, and you're not quite sure what the scale of the facade is with these glass sheets, which we would not serigraphy today, Pat. It's okay. We won't frit them, but they were fritted there to be grass. Kildare is grass. It's grass on the facade. An over facade, when you're building on the scale of, in Shanghai, you have a mere 45 meters high. You got 6 buildings, Shanghai standards on this amazing site on the side of the river with Will Alsop. We decided to give a reading the client wanted to read as an entity, almost like a horizontal skyscraper that had fallen down. It had to have a presence, which it just didn't have. Before the facade went on, the facade just linked everything together and gave this reading of a scale. This over facade, where the garden, which is all around, just can go in, you can come out to the balcony, the heat is evacuated at the top. It's propped at the top and propped on the second floor. And this, for the engineers who are present here today, this is fun. So this bow element, we used high-strength steel, and to resist the wind loads, we pulled on pre-stressed cables, which I put red. The cables aren't red, that's me, I put red in last night. So these elements, which you'd think are spanning 40, 45 meters, are actually just spanning 2 floors. And the wind, so you pre-stress, and we deformed these bows by up to 35 centimeters. And there was so much pre-stress in this that when the wind loads apply to the facade, it just reduces the pre-stress in these elements. And that, in the space, you hardly see these cables in the final. You can see, you don't see the cables in the space. So it gave this monumental scale without Now, there's another aspect of over facades, which is the problem is when you're inside, you get this great view. You got your glass building, you got this great view. The problem is that all the outer facade is going to block the view. And in this case, we emphasized the horizontals, got rid of any mullions as much as we could by little cable RF4 things, and the elements became quite thin. So the other intriguing aspect of these outer facades is the actual surface itself. Now, in this case, you know, there's insulation, there's floor slabs, there's fire breaks, and all the rest. And the architect wanted a glass box. So what I've discovered is that once you go in behind, generally you look at a building, it's black, because the light level in the office space is so low. Once you go away from immediately behind the facades, you only see the white columns which are immediately behind the facade. Unfortunately, the architects never paint their columns black or grey. They always paint them white. And you do these lovely white, clear facades, and all you see is the columns, because that's the only zone that's lit. With a double skin facade, the light level just behind the facade is very high. So if you just leave the glass, on condition it's not dirty, you just don't see the glass of the outer skin. You see the skin in behind. And we do a lot of testing in the office. We just make cardboard boxes, you know, models of 1 to 20 of the office spaces to put the glass samples up to see what it gives. Because light is it's linear. Stefan, light is linear. So so what we did on this box, we have on the inner glass, we have a low E coating. Now, thank you, AGC. We have lovely low E coatings now, which have hardly any tint. Because we're not worried about the selectivity, when I built this building, we did have a slight tint in the low E coating. Nowadays, we can get low E coating, which is hardly any tint. We're not worried about selectivity. We put the coating in the outer skin. So this is just a mirrored coating. It's a reflective silver coating, which is about 34% reflective. The inner is just a low E coating. And so nowadays when we do the double skin facades, there's no color, there's none of this. What a famous Irish developer once said to me, "You're the fuckers, give us these green buildings." You can guess who that was. And so that greeniness with an overskin facade, you're not running after the selectivity business, so you don't end up with green coatings. Another in this, just to draw attention, we put these little struts to reduce the inertia, so we piggyback the outer mullion on the inner mullion. And the internal plane, you can spot the Eiffel Tower there. I just noticed that. So we put as someone did earlier, you can put the inertia, it was Ronan did, you put the inertia in the double skin facade in our case, and that just gives this nice flush for partitioning, finishing the inside. Texture with these over facades, there's a whole potential, there's a whole sculptural potential which is phenomenal. I was asked to do this tower in Abidjan, which you could say you shouldn't build towers in Africa. Abidjan is very rich, it's got lots of cocoa beans. So how do you build a facade? Well, we faceted it and brought out the facets, and then that wasn't quite, the tower is 400 meters high, 333, it's 412 with the mast. So one of the things we did, which is important with the double skin facade, we dropped the floor of the double skin facade down so that you can see out. You can get caught on this. The first one I did, all you see in the inside, you just looked at dirt, which was here, and you couldn't see anything. So we try and drop that floor down. We clean the facade from the inside. There's a system moves around in the inside, and with this slopes, because the geometry, we just clean it. But basically what we did for the texture was we opened up the facade, which gave it this grain. We had lots of more funky designs along the way, but we ended up quite calm. Merritt's already presented this, but I'll just to say that the ventilation through double skin facades is a very, very complicated topic. Solar protection if you've managed to make the glass totally disappear and you got glass floors and glass and just a cable that holds everything together, all you see is the shading. In this case, it was worked very efficiently as reflecting everything out. Very little came in. The real origins of this design was to give confidentiality to a bank in Luxembourg, because the German tax people permanently videoed from a hotel across the road everyone who came in. So this was marble. Fiberstone made this laminated marble. So just on the case study, I realize I'm running out of time. All those themes which I presented, and lots of others, so there was all the technical issues of double skin facades. That was just bringing to the surface the themes that you actually talk about with architects when you're designing double skin facades. This was a tower where we brought out, a bit like Merritt, breaking the scale down by having the levels which tie in with the city, like in Elm Park, which was history repeats itself. At the top was a planning bug in that they had allowed you on the roofs in Paris, they suddenly said, if you build a glass house on the roof for urban architecture, you don't need planning to encourage people to build little glass houses on the roof. This is our glass house on the roof. So we didn't need, it stayed in the planning law. So you got the 3 layers and the main shaft of the building. Now, so we won the competition. I've got to say that. We did win the competition, and it just gone to tender. And so the major, I think we're all converging on one idea today, which is big blocks are good. So what I was saying earlier about we have this fire barrier, which we have to have in France. That's effectively achieved by threading into the aluminium profiles, steel profiles, and then fixing between them steel sheets. So those, we said we'll use that element and that element together, combined together, make the fire barrier. We said we'll use that as a horizontal beam. That, because we're currently, all my projects in Paris are on existing concrete frames. You can no longer, you're a different dynamic in Dublin perhaps, but in France they say we have the building stock, you're reskinning existing buildings. So there is a little bit of what the presentation said at the beginning about reskinning old buildings. So reskinning old buildings, the floor slab couldn't take the loads, because as was very, very well described by Colman earlier, the differential movements between the blocks. So we use this block to span. The ventilation, unfortunately Merritt wasn't on the project, or it would have been very interesting. We did, initially, when we won the competition, the idea was the wind is on the longitudinal axis of the building. We kept the form of the building. The wind is on the longitudinal axis. And what we tried to do was create negative pressure zones and positive pressure zones here to fuel the natural ventilation on the facades, because the blocks, we introduced a pattern of, if I go forward, we introduced a pattern on the facade of the blocks are different depths. So, and this is a 5-meter sheet of glass. So the idea was to use these zones, it gets flatter as it goes up, and was to use that to create pressure and negative pressures here. It was basically the building, because it was a fit out, the building was too deep, it didn't really work in the end. It just wasn't. We went through all the figures. The percentage gain wasn't on the heating loads, it just wasn't worth it. So what we do is the operator, the people inside, if they want to open a flap, they can, and there's a quite simple device. When the weather conditions aren't good for opening up, there's a red light comes on, and when it's good for opening up, there's a green light. So low tech, high tech, I don't know what. You need high tech to tell the light to come on, and the person just decides whether to open it or not, because there's a lot of BMS and a lot of equipment. This is just comfort ventilation, as the French call it. I've run out of time. This is an interesting thing, I think, because this is a software called Ocean, where a French guy we know has developed, initially with Saint-Gobain, he's now on his own, and you put in the characteristics of the glass. you put in the characteristics of the glass, and it does give you the real rendering. So this isn't, I wish it was like that. This is what we believe. So after that, the glass is based on the light direction, the time of day, the time of year. So basically, they're different conditions. And when we present an image, we say, this is in the 21st of June at 12 o'clock, and that's taking into account the reflection off the adjacent towers or not. So I think that's a very, very interesting tool for us all to discover. So here you can see that we play, sometimes these are double. For maintenance, you open one of these windows, there's blinds inside. We didn't go quite. So what, I don't sit down or teach or anything. I'm just trying to learn from what I'm doing and trying at a conference to step back for a few minutes and think, is there a conclusion out of all of that? All I know is at the moment, this is what I'm doing with Rory, working in Reddy's. So with Rory, we decided we're building on top of the Jervis Street Centre, hopefully, and this facade was basically, it has a sculptural quality by having an over facade with a very simple geometrical, we won't need parametric modelling on this, just very simple geometry, but an effect with Renzo Piano picked up the idea of the silver coating and nothing else on the glass, so you can see it in his new law building in Paris, and they do really work. They do really reflect the sky, these coatings. So, and what's more wonderful in Ireland than the sky? So that's one. It will. What I'm saying basically, I think it's still justifiable. As Pat said, there's always monumental buildings. There's always leading edge buildings. There's always times you can justify the extra expense. I'm not saying every building should look like the extension to the Jervis Street Centre, but I think there are times when it's architecturally justifiable. Also, we're going to have to not wrap them all around buildings, maybe just use them really carefully so buildings won't be the same all the way around as they tend to be at the moment. They'll have to be, the facades will have to be more climate specific. This is a building where it's a recladding again with a view up to Notre Dame with the crane, God love it, after the fire, and there's no spire after the fire. And so the views are upriver. This is Central Paris up here. This building addresses the river. It's southwest. So this is the block. It's an L. So this facade here is the one I'm looking at here. What we did was we introduced, this is the plane of the facade, and we introduced a twist by the zigzags in the facade, and we brought the ventilation in through a solid bit. So this is where the ventilation will come in behind the perforated panel. And this, we continued it it worked for this facade as well. So for the noble facades, we have a zigzag. For the facades which are to the north, they just go flat. And that did effectively, the main interest was the blind, because the blind is internal, it's going to be very visible and rather annoying for the occupants. It will delay, if I go back to the previous image, it will delay by an hour and a half when the people have to lower the blind inside. So rather than 11, they put it down to 12:30. So they get an extra bit of time without the blind. It's an extra bit of time without solar gain. So that playing with geometry, suddenly if you can't do over facades, maybe we just have to work a bit harder on other themes. This is a competition which I heard I lost the other day, where we did, as Merritt was saying, we're going to have to think an awful lot more about timber with a bit of aluminium outside. At the moment is the way we generally do the timber facades. We're doing a hospital with Renzo Piano, and it's very interesting to try and do everything with timber systems, but we are reluctant to put timber on the outside. So there, overskinned facades. You can have fun with them. Thank you.
Thank you, Tom. Overskinned facades of different kinds we've seen there. Swiftly moving on to Allan Gibson, who's going to talk to us a little bit about a slightly different topic, bird impact on glass, I think. Correct?
Yep, that's right. Thank you,
Okay.
Stephen. I won't be overrunning. I've meticulously sorted out my time schedule, so hopefully we'll all be okay. Right. Now, we've heard a lot about sustainability, but today I think my presentation is more probably about the environmental impact on some of these beautiful buildings that we've seen during the course of today. First of all, how nice it is to see people in person. For so many months now, stuck behind a desk in a home office, doing presentations on Teams and Zoom and everything. It's great to be able to smell you for a change. So it's great to be able to shake hands and meet people. What I wanted to do is just explain a little bit about myself. Some may know you already, but as this is Dublin, although I've been with the company for 4 years, I've probably met some of you. My name is Allan Gibson. I've worked for Courray for 4 years, as I say, but I've actually been in the specification of specialist materials for the construction industry for 21 years now. I've studied supply chain management, I've got a BA in management, and I've literally just finished a master's in facade engineering. So I kind of hope that I know a little bit about what it is that you're looking for when it comes to designing with glass elements in facades. So I'm responsible for the high performance products of Courray, and I cover the whole of the north of Europe. So today I wanted to go through the following topics and the challenges of modern day building design and their effect on the environment. We will look at glass in structures and how they pose as a hazard for birds, and how small changes can make a big impact when designing with our brand new product, which is Trossifol, Bird Secure, and Sentry Glass Bird Secure. So Courray's Advanced Interlayer Solution business is a leading global specialist in the development, manufacture, and supply of PVB and ionoplast interlayers for the laminated safety glass applications in architectural, automotive, and marine industries. And this is all provided by a truly global business full of diversity, with more than 900 employees in more than 20 countries, with 7 manufacturing plants and multiple research and development and technical service sales locations. Now, this provides a local service and supports our valued customers and project stakeholders. And this is possible with a multiplicity of specialist interlayers manufactured by our division of Courray. And it provides solutions in the areas of safety, decorative, acoustic control, structural and security, and some of these topics we've heard already today, and other specialist applications like automotive, transportation, and of course sustainability. And it's the new Bird Secure interlayer, part of the specialist application family of our products that I wanted to share with you today. But first, let me play a video. It was created by Ryco, and that it really inspires the purpose of this presentation today.
For centuries, birds inspired humans' pursuit of flight. They show us freedom, balance, and harmony. Birds do what we can't. They take to the skies and soar, defying the gravity that glues us to this earth and making us wish that we could join them. But birds in flight are dying every day, and we are the cause. It's not intentional. There's no master plan. It's just that we build glass structures for people to live, work, and shop in, and the birds can't see them. They move through the air at full flight speed and unknowingly strike the glass. It is estimated that up to 1 billion birds are killed by window collision in the US every year. Birds are an irreplaceable part of our biodiversity, born to gather, to breed, pollinate, and inspire, and we can help protect them. We can simply show birds that a window is a barrier instead of a patch of open sky.
I'll stop it there. There's a few tears in the room today. It's really an inspirational video, and it brings me on to the valuable subjects that I wanted to share with you today. So first, let's look at the challenges of modern building design. The upward and outward growth of our urban areas around the world has degraded the quality of existing natural habitat and has increased the number of hazards for birds found in our cities. As human activity encroaches on shorelines, wetlands, valleys and meadows, these stopover locations for migrating birds are becoming smaller and more fragmented. Now, urban intensification also brings larger and taller structures that increase the number of obstacles for migrating and native birds. And glass can appear very different to our feathered friend, influenced by several factors. The viewing angle, how the structure's been fabricated, differences in the internal and external lighting levels. Combinations of these factors may cause the glass to act like a mirror, giving an illusion of the surrounding trees, the skies and the clouds, or the dark passageways, or give the appearance of complete transparency. And we've seen some of these pictures today, haven't we? Or they give the appearance of complete transparency falsely, resembling a safe passage of flight for the bird to quickly discover an obstructive solid wall of glass with devastating consequence. So first let's look at glass, and why is it a hazard for birds? Untreated glass is responsible for virtually all bird collisions with buildings. As the building size increases, so does the amount of glass being used. That's inevitable. And this increases the risk factor. And it is generally accepted that the lower levels of the building are, in fact, the most dangerous, as they are the same level as the trees and the other landscape features that attract the birds. However, more recently, monitoring programs accessing the roofs of tall buildings are finding that birds also collide with the higher levels, especially during inclement weather, low cloud or fog at night time. And the main factors for influencing the bird strike rate on buildings include the transparency or the reflection, and often designed with the blend in with the surroundings. Even non-reflective glass can become highly reflective at certain times of the day. Here you can see transparency and the black hole effect, or the passage effect, where birds can think it's a safe channel to fly. Building sizes increase the risk factor, and they reflect not just vegetarians, not biased, vegetation, and transforms the glass barrier into an oasis attracting passage of light and then to be met with consequence. So as you've seen, there are many challenges that need to be addressed and help to overcome this issue of bird strikes on modern architecture. Now, bird-friendly manifestation is not new. It's not a new idea. However, it commonly applies a film or a screen-printed ceramic frit, which involves an additional process, and this includes glass tampering or tempering that needs to be applied often before the glass is laminated. However, this also comes with some processing complications like the bending of glass. And both of these processes can be eliminated with the use of our solution. So Courre's propose an alternative solution. We have already the skill and the expertise in manufacturing specialist interlayers for laminated safety glass. But now, by combining this expertise with a certified bird-friendly pattern configuration, the possibilities in glass use are now, the designs are endless. So Trussful Bird Secure can be combined with other Trussful products like colours, tints, the acoustic interlayers and so on. And the Sentry Glass Bird Secure can be combined with other Sentry Glass products, offering additional structural security to buildings. Now, the pattern may not have to be facing towards the glass surface, and products can be laminated in a nip roll or vacuum bag, and even in an autoclave-free system. So the characteristics of Courray Bird Secure reduces the threat factor actually is outstanding during the test results. It's tested to American Bird Conservancy standard. There's no need to carry out any of your own expensive and time-consuming testing. And it can be used with monolithic or in combination with solar control coating, which has also been included during our Courray testing processes. Now, relevant safety features of laminated safety glass remain unchanged. Cullets are glued to the interlayer, and in case of glass breakage, they remain intact. Outstanding optic quality in combination with Bird Secure is now possible. And from a distance of 2 meters or more, the dot pattern disappears. Regarding solar control performance, this has all been measured by the notified body of the Fraunhofer Institute. And calculations are also possible now using WinSLT or optics or Berkeley Lab. And if we compare Bird Secure with screen printing on glass, we could be looking at faster delivery times, especially for replacements. Thinner glass combinations with annealed glasses that can now be used for better optical qualities. The tunnel test method is claimed to be the preferred method of testing, and this was carried out in the US. And Trosserville Bird Secure and Sentry Glass Bird Secure achieved outstanding results. And in comparison to screen printing solutions, Courray Bird Secure can be used in combination with annealed glasses. And this can provide optical benefits and cost advantages, making it easy to process, supporting quick deliveries with shorter replacement times, and the design with sun coating could be replaced with Bird Secure using low-E glass. So the objective is to reduce a bird injury and the mortality from in-flight collisions with buildings. And to do this, we need to comply with the building facade off-site structures. So exterior lighting and develop a performance in the monitoring plan. And these requirements include, it's also crucial to include the development of the building facade and include any design strategy for external buildings, structures, physical barriers to birds, like some of the barriers that you'll see around trees, and also the bandstands and so on and so forth. So all the supporting literature is available on our website, and if you're not used to our website, please do have a look at it. It's very easy to use. And they can also be found with the application, the WinSLT that I mentioned earlier, which now includes the Bird Secure interlayer analysis. But finally, I want to introduce you to our brand new tool, the Solution Finder, where all our free-to-use apps, like apps for working out the acoustic Sound Lab AI, Glass Global, the Strength of Glass Calculator, and the Solution Finder and the WinSLT, all available and easy to find within this particular app. All the test data, brochures can be found easy in one easy-to-use, free-to-download on your phone or other handheld device. So please do come to our table, and we'll certainly help you find it and download it from either Android or Apple Store. So this presentation has been brought to you by Courray, and it underlines their commitment towards serving the ever-changing demands in our global industry of glass through innovation and leadership. Thank you very much for your time.
Thank you, Allan. We'll continue in our afternoon presentations with Naveen Sandhu, who I think we've heard quite a bit about your products earlier today.
Yeah, it's been great, so thank you for those who've mentioned us.
So we'll hear some more from you.
Okay, brilliant, thank you, Stephen. So where are we now? Just an hour after lunch. Those of you who've loaded up on the carbs will start wavering by now, so I'm going to try and make this as interesting as I can for the next 20 minutes. No inspirational videos, just me talking, so hopefully that's enough to get through it. So yeah, I could give you some corporate propaganda, but I'm not going to. I'm just going to start off with this. So this is really focusing on 3 specific considerations when it comes to facade finishes, okay? So firstly, we have aesthetics. Now, kind of first, long-lasting impressions are quite crucial in our industry. Secondly, we have the ability to withstand against the elements. So this is really quite pertinent given where we currently are and the major kind of urban hubs of this island. And finally, we have the ability to contribute to the upkeep of a given building, which powder can now do. Now, evolution of powder is such whereby it's able to positively contribute across all 3 of those areas. So we've now got kind of finish and surface treatment options, which are able to align to ever-increasing design life expectations. Powder tends to be more favorable from a carbon footprint perspective, particularly when compared to our friends anodizing and pre-coat. But we're also able to take it that one step further and actually tangibly support the energy efficiency of a given building, which we'll talk about later on. So let's attack these one by one. Now, some of you in this room have probably come across the terminology of super durable powder or class 2 powder. That's something which has been increasingly talked about over a number of years. But really, it's been around for about 30 years in total. It's only the last 10 years where it's become the go-to for facades. Now, you may have come across projects like this at some point. Hoping you haven't, but you may have. Some of these have been installations from the 80s, 90s, early noughties, where essentially you've got a breakdown of the resin. Essentially, that gets broken by the UV, and it starts to chalk, starts to degrade, and this kind of gave powder a bad rep for a long, long time. And then people started to realize, okay, if I'm the building owner and I've got this, what are my options? And really, you've got 3. You can either leave it as it is, which will only get worse as time goes on, or you can recoat, which is using liquid, or you can replace. Now, as a building owner, those 3 options are not particularly appealing. Some of them are quite costly. And it's really not until you see something like this when you start to get an understanding, actually, there is another option, which basically means that you don't have to make that choice in the first place. So these panels have been left out in the lovely Florida sunshine, okay, for a period of 5 years. So Florida is a main testing hub when it comes to UV degradation. So each kind of left-hand panel, that's a standard PPC class 1 coating. The panels next to them, that's a super durable equivalence. Top section of each panel, that's been masked off to show the original color and gloss. The rest of the panel is then subjected to the weathering conditions. And you can see, yeah, quite a bit of movement across these 2 in particular, whereas these right-hand panels, you're not getting much drift there whatsoever. And that's kind of aligning to people's expectations when we're talking about 25, 30, 40 years of durability. Now, just in case you were in any doubt as to the credentials of super durable, I just want to draw your attention to this. So this is the first ever project to ever use super durable powder. And last year marks the 30th anniversary of this building. So this is in Florida. Sorry, this is in California. It's a hospital scheme where essentially we have a team that go back there periodically and actually measure the performance of the coating over a period of time. Fortunately, I'm still waiting to get my invite through the post. Still not yet come through, but hopefully one day. But what they found remarkably was when they went there back in 2019, they looked at the color and the gloss, which was still performing to the original spec. But also what they found was no parts had been replaced, no parts had been recoated, no parts had corroded or showing signs of corrosion. And that's 30 years in quite an intense UV, relatively saline, quite humid environment. So hopefully that gives you a bit more assurance, a bit more confidence in terms of how these powders can actually stand the test of time. Now, it's one thing to have the technology in place, but you still need to kind of stimulate those kind of visual and touch senses. And the biggest kind of area of growth that we've seen in powder, particularly the last sort of decade, has definitely been metallics. And it's metallics to resemble anodized aluminium. And you can walk along this street and you'll notice quite a few elevations using it. But I think a few years ago, trying to find viable alternatives in powder was a bit of a challenge. People kind of felt it was too flat, too lifeless. These were some of the comments that people made to us. But we as a manufacturer have tried to improve those finishes, giving that extra level of depth that people desire. And I think we've succeeded, and it's leading to installations like this. So this is Northampton Council's office building, which not too long ago, this probably would have been a grey box. Let's make no bones about it. But what they decided to do was literally every single material on that elevation, they went down the road of metallics to really bring the elevation to life, which it certainly does. You would never imagine a council building looking like that. It did cost £50 million though, so I guess it had to look like a £50 million building. Something a bit more closer to home. So you got a lot of bronze detailing here, and I've noticed a few of the presentations earlier referring back to bronze. This has definitely become the de facto kind of color when it comes to metallics. It's now replaced silvers as the go-to, and yeah, because it's got that level of depth that people really want to achieve. And then we kind of take it up a notch with installations like this, which is really bringing the facade to life, giving that extra level of finesse, extra level of elegance. And this is where powder can really enhance facades, and not just become a byproduct, which people often think it is. Okay, so some of the earlier presentations have already alluded to this, but yeah, we have entered the world of masonry over the last few years. And it's one of those areas which is gaining momentum almost on a weekly basis. I think if I did this presentation maybe 5-6 years ago and talked about powder as an alternative to GRC, to precast stone, we probably would have been laughed out this very room. It just would not have entered people's heads. But times have changed, as you've seen. People have started to realize it is achievable, it is possible. And when you really take a step back and think about it, it's, going towards aluminium is a godsend for a lot of people. It saves a lot of hassle, and almost every concern is kind of eased. And that's probably illustrated by one of the first projects. I'm careful here not to mention the previous ones that you've seen already. So this is a building in Canary Wharf. It's 27.8 stories in height. And originally, the intent was GRC. That's what the planners had approved. But then the contractor came on board and said, 28 stories, GRC, access was a bit tight, don't really want to be doing that. So what they did was they consulted the market, did a round-robin exercise, and said, look, any of you guys in aluminium, can you help us here? And one particular subcontractor was able to do it. And what they cleverly were able to do is articulate a 3mm panel to the original approved GRC design. And so they're still kind of retaining that element of solidity, of mass, which is obviously what you desire. And obviously, you could literally easily walk past that building, think it was GRC, unless you really went up close to interrogate it. And it's not, it's 3mm aluminium. And that's kind of, we call this the Project Genesis. Off the back of this, we've had numerous project teams from Dublin, from Glasgow, Birmingham, Manchester, traveling to that site, quite skeptical to begin with, and then seeing it and realizing, oh, okay, we can see what direction we're going in this. And I think this one was mentioned in the presentation not too long ago. We've got a different image that kind of makes up for it. So obviously with this one, this is the first project on this island to adopt it. We're hoping for many more. And obviously for the banding elements, crisp, clean lines, that's what you're after, which always helps. And just because they got a decent result at the weekend, I'm going to show this one. Yeah, but it's 2 grey tones, so slightly different. But you've got that combination coming into play with the rain screen, looking quite refined and quite elegant, I'd say. And this is the thing, as a value proposition, powder just ticks a lot of boxes, particularly on aluminium. You're talking about essentially, commercially, you're talking over 150, 200 euros a square metre as a saving. The actual installation journey becomes that much more simplified, less machinery, less handling. And also you lighten the load of the structure. The backing supports the weight over 50 kilos a square metre. So as you can see, it's ticking most boxes for most people. Okay, so what we're starting to see more and more is this kind of shift towards textures. Now, textures, quite refined, quite tactile in nature, but they're also able to hide a multitude of sins, which helps a lot of people. So we've got a few local schemes here where they've been adopted. One sitting just across the other side of the river. This is the old former sorting office, where the intent for these kind of vertical fins, or perforated vertical fins, kind of leaned quite closely to a terracotta-ish, natural terracotta tone. And when we take a look at this almost microscopically, this is what the finish looks like. It's actually a texture, but contains metallic. And it's that combination of texture and metallic which kind of refracts the light in a much more sophisticated way. And I think that's what we're starting to see. You know, you want to add that bit of elegance to proceedings. Now, as part of Cork's rapid expansion plans, this is the Dean Hotel. Again, this kind of insulation is not overly removed from almost like a zinc cladding. You've got the texture and the metallic coming into play, but I think it's really the tapered detail which kind of brings it to life, really plays with the light, gives you that kind of feeling of elegance too. And looking at this close up, that's literally the sky at night scenario. I think that's essentially what that looks like. Half expecting the Star Wars credits to start rolling up the screen, but we're not going to have that, I promise you, don't worry. And finally, this is projects which is close to one of the projects Colman was referring to earlier. So this is a double act combining together to create a sense of irregularity, almost akin to Corten cladding. So they decided to basically specify two complementary tones of this sort of reddish copper type finish, put it in different areas of the rain screen just to break up the effect, and they ended up loving it. It's, you know, saves you from sort of staining. You don't have to have all the extra drainage preps that you normally need. So again, it ticks a lot of boxes, and yeah, that's what those look like, a little bit like the surface of Mars, but there we go. Okay, we've now, well, I say we've now, but it's something that's been around a while, but timber, kind of composite alternatives, that's now coming back in a big way, mostly because of the changes to UK building regs, which has opened the market back up again. So this is very much slightly different in terms of application. So this is relying on a printed film, which is sublimated onto a specially formulated powder, which essentially soaks up the ink all the way through the coating. And that combination of the powder and the inks is quite infinite in terms of what you can achieve. And we're seeing, you know, installations on kind of planks, battens, soffits, you name it. I think this is an area of growth that we're starting to see, almost getting weekly requests for things like this. So I guess this is what powder's almost become, you know, almost chameleon-like in nature, trying to mimic different materials, some better than others, but it's very kind of adaptable, quite agile, but most importantly, it's durable. Okay, so we've delved into the past, we've talked about the here and now. In terms of the direction of travel, well, AXA Nobel are very much committed to sustainable architecture. That's, you know, for sure, that's been from the start of time. And one of the areas that we're trying to improve on and help is reducing this urban heat island effect, where obviously temperatures in inner city environments are obviously much more and much higher almost each year versus then kind of rural kind of counterparts. And that temperature difference in the peak summer months could be up to 10 degrees Celsius. So obviously all these buildings in these cities, to try and cool them down during these months, they're going to take that little bit more of energy. So what we've done is we've developed a specialist formulation which essentially has got pigments which deflect the infrared light from the sun, which is the main cause of the heat buildup. Essentially what that does in turn, it helps to cool the substrate that it coats, but also what room and what area that substrate protects also becomes cooler as a result. So some of the studies that we found was that you can actually get a 7-degree difference in terms of the substrate temperature versus a traditional powder coating. But also what that did to the room temperature was up to 3 degrees Celsius, which is huge. But obviously this is all very dependent on how much the elevation is comprised of panels. Obviously the more panels you have, the more impactful it becomes. If you've got a facade like that where it's obviously mostly glazing, then it becomes more diluted. And obviously colour plays a part too. You know, your lighter colours tend to be more impactful. But again, this is an area which we see definitely people are veering towards. And I guess that all links into this and kind of transparency when it comes to emissions, critical. It's been mentioned numerous times today. We do that obviously through our EPD, which is independently created, recognised, shows the operations from basically raw material extraction, production, transportation, pre-treatment, curing, and application. So it goes through the full stages. And obviously what we've started to see more and more is this almost tail of the tape scenario, where people are benchmarking and trying to create and then trying to compare and contrast different materials. And I think powder, just to give you some perspective, per square metre tends to generate just under 4 kilograms of CO2. And if you stack that up against the other alternative finishes, it does stack up quite favourably. So, penultimately, just want to really talk you through this, because think about where we are now. It's quite a marine environment, and therefore what you need really as a specifier is to ensure that you've got the foundations in place, and also you take extra steps to enhance longevity. So these are the kind of key focus areas really, which to back up all the technologies that you have in the powder. So we're very much focused on pre-treatment, and specifically really looking at two facets of aluminium pre-treatment. So you're talking about the etching rates, which really tends to be increased in locations like this to around about 2 grams a square metre. What you want to be doing is giving that powder a strong mechanical surface and key for it to stick to, and increasing the optimal kind of adhesion integrity of the powder. So increasing that is important. And also the final rinse off is again quite critical. If the conductivity is too high, you're going to be left with deposits, contaminants that you don't want before application. Okay, so making sure that's not too high is critical. Fabrication perspective, this is where you really need to really look at your weak points, which is always the areas where you cut and you've got no pre-treatment protection at all. That's where you really have to seal, encapsulate those areas, because essentially, we're talking about mitered joints, face end capping, talking about drainage slots, drilled holes, all these things really have to be sealed, because invariably that's where corrosion will propagate from if you don't protect it fully. And yeah, we have 2 guys here cleaning an elevation. 90% of the time, maybe higher, they'll just clean the glazing. Probably won't be cleaning these surrounding panels, but it's very much there for a reason. You know, you do not want any salt deposits sticking on that metalwork for a prolonged period of time. That will start to oxidize, start to catalyze corrosion. So if anyone thinks that cleaning is a get-out clause, no, it's not. It's really quite crucial to the whole longevity. So I guess we kind of come full circle again. Hopefully you've got a better understanding, a better appreciation as to how powder can fulfill these kind of 3 key pillars. It's very much looking to bring surfaces to life, but in a durable and sustainable way. Anyone of you who've got specific questions or want to see some of these finishes we've discussed firsthand, feel free to pop over to our table. Be more than happy to assist you, answer questions. So, yeah, thank you very much for your time.
Naveen. Naveen, if I can invite you to stay for a minute, please.
Oh, sorry.
We'll have a short interlude while we upload the next presentation. So I thought I'll take the opportunity to ask you some questions and maybe invite anybody in the audience who has a question to fire a question. I'm interested in what you said near the end of your presentation about the carbon footprint of powder being 4 kilogram of carbon per square meter. So this is taking it on a flat metal sheet.
Correct.
And that includes the embodied carbon of the product itself and the application process.
Yes, it goes from the A1 to A5 all the way until it basically gets released from our applicators.
Right.
Production facilities. So yeah, you're talking about raw material extraction, production, application, curing. Those stages are what's included within that A1 to A5 spectrum. Yes.
And sorry to put you on the spot, but do you know how that compares with, say, anodizing?
Good question, because it's one that we've tried to ask and find answers ourselves. If you try and put anodizing EPD or any embodied carbon information, it's very difficult to find that information unless you drill very deep. We've tended to use external people who've done it as a third-party basis. They've looked at this by themselves as a company out in America that did a study probably about 4 or 5 years ago. They found it was around about 11 kilos per square metre. So that's the only definitive one that we've seen in black and white. You try and speak to any of the UK anodizers in the marketplace, you may struggle to get any information. So, yeah. And that's where transparency is key. I think more and more, that's what people are asking for. If you haven't got that information, it's almost a case of, what are you trying to hide kind of scenarios. So that's the way we see it.
Thank you for that. I think our next presentation is ready.
No worries.
Thanks,
Thanks,
Naveen.
Tim.
So we'll plow on. Our next presentation is from Michael Slattery, who's the principal at MSA Fire Engineers, and by definition of what Michael does, it's going to be on fire.
Yeah, that's it. Okay, good afternoon. It's good to be back speaking at these events. It's been a while with all that's gone on. So, I mean, this presentation, I'm looking at, I'm trying to give you a fairly high-level overview of what is somewhat a somewhat tedious subject in the time available, but it hopefully gives you a flavour. It's a relatively hot topic, forgive the pun, and so what I'm doing is I'm kind of looking at some of the key parameters that we would look at as fire engineers in assessing how we would approach facade design from a fire point of view, and the codes and standards that we work to don't always reflect this. But I mean, in buildings where the occupants are likely to be asleep, are at the higher end of risk, and the consequence of vertical fire spread, extensive vertical fire spread as a consequence of the facade is of much greater significance, as we all know from the tragic fire across the water in Grenfell. So, apartments in particular in the UK, they have a stay-put strategy. In Ireland, the Irish regulators have kind of now recommended, and it's been followed, that all apartment design here should be based on all-out or staged evacuation. So at least we're not as reliant on the compartmentation. Hotels, which would typically have a staged all-out evacuation. So there are subtleties even within that class as to whether it's a stay-put strategy or not. Occupants requiring medical care, such as hospitals, residential care facilities, are all designed on the basis of phased progressive horizontal evacuation, which is, so you are now relying in a building such as a hospital on the compartmentation to work for a prolonged period. Now, hence, in hospital design, the hospital design code that we use in this country's HTM has particular prescriptive requirements on the design of the facade junctions with compartment walls for that very reason. In other buildings where the occupants are awake, and these are the kind of risk categories from BS 999, people are either familiar with the building or they're not familiar with the building, shops, places of assembly. Again, typically in those buildings, unless they're very tall buildings, it's an all-out evacuation strategy. So you're less dependent, in containing vertical fire spread, but you don't want very rapid vertical fire spread either. So the criticality of the compartment floors, in my view, is a lot less in a building such as an office building. And I think that was somewhat reflected in the presentation by Tom Gray earlier, where he says the French authorities don't consider office buildings a particular risk. And now our codes have a slightly different perception of when you need sprinklers, but that's a separate question. But in high-rise, tall or very, very tall buildings, you will have phased evacuation and extended evacuation times, and obviously it's much more significant in that case. I suppose the key parameters in vertical fire spread are in relation to the facade system design. Is it a curtain walling stick or unitized lace system, which presents one set of challenges, but perhaps a lesser set of challenges than the built-up walls comprising rain screen? The other, obviously, you have external wall insulation would render brick slips. That's a typo, which is perceived to present a significant risk, but if properly detailed, it doesn't. And then you have more traditional masonry wall construction, which is diagram 17 or diagram whichever, from the other codes, which is of not a particular concern. So, I mean, if we look then at rain screen systems, the rain screen system consists of an inner leaf construction, which is blockwork or RC, or a framed hollow construction comprising plasterboard and calcium silicate board with stud. You then have insulation, combustibility or not, and you have outer leaf rain screen construction. And ultimately, I think all the tests, all the research and the tests, and indeed the case studies, would demonstrate clearly that the combination of B and C is the key factor. You can't look at one in isolation from the other. And obviously, the outcome of the Grenfell fire and the investigations so far on the Grenfell fire are clearly showing that the combination of the phenolic insulation or PIR insulation products used with the ACM material, which had a polyethylene core, was a key factor, if not the key factor, in the very rapid vertical fire spread. And there are other case studies from around the world, Dubai, Australia, that have demonstrated that the same outcome. Now, I mean, these slides, and I'm not sure, can you read the print, but I mean, I'll try and take you through it, is kind of demonstrating the principles of vertical fire spread. And I mean, this is obviously, say if you take this as an office building, you have a fully flashed over developed fire on the floor, and at the stage a fire is that developed, there's extensive flaming out the windows. Now, that's representing a fire where there is a very strong spandrel panel detail and a fire stopping detail which works, but nevertheless, the flames out the window elongate, and they will start attaching themselves to the windows above. So there's no construction detail that absolutely prevents vertical fire spread, unless the building is sprinklered. It greatly reduces the risk, and it doesn't happen instantaneously. That's the key. So you'd have to be one floor at a time progressively, and the fire brigade have an opportunity to come in and prevent it happening. It doesn't happen rapidly. So, I mean, that's the typical detail. Now, I'll come back to discuss if that detail of the junction of the spandrel and the slab somehow fails or fails, partially fails, it obviously, increases that potential. So that's the scenario with say a typical curtain wall detail. Now we have what you might regard as the rain screen cladding system with a cavity, and this is exactly what has happened, what happened in the Grenfell fire and what happened in the Dubai hotel and apartment block fire and the Australia apartment block fire, that in addition to the flames attaching to the window, the flames and hot gases got into the cavity, involved predominantly ACM has been the predominantly problematic material with the insulation, and rapidly spread up the face of the building, leading to multiple fires on every floor in the building, or nearly every floor in the building, in a very short space of time. Now, so I mean, design has to be, for all building types, has to be to prevent that potential happening. And I mean, and even with sprinklers, I mean, significantly, I think in one of the Dubai fires, which was a fully sprinklered building, because the fire spread so rapidly and involved multiple fires on every level, the sprinkler system was overcome. A sprinkler system is designed to fight a fire on one level or one area. And if multiple fires start happening sequentially, and the sprinkler system can get overrun in terms of the capacity of the pumps and the amount of water. And that was a significant factor in that particular fire. So, I mean, a key objective in rain screen design, or has to be the preventing the potential for this. And I suppose with the way from the outcome of the Grenfell fire, there has been reaction to it in UK regulatory circles in any event, and some of it is perhaps knee-jerk reaction and excessive, some people might say, but nevertheless, I think it has been a wake-up call to, for designers to fully, and specifiers and contractors to fully understand that the combination of materials is a key factor. This slide is just an example of, and you won't be able to read this, but it's just as an aid memoir to myself. The number of significant fires involving facades that have occurred worldwide in the past 30 years. Now, the most significant of those have been the ones I mentioned in passing, which have been the two Dubai fires, which were well publicized at the time. Obviously, the Grenfell fire, and there was a residential tower in Melbourne, in Australia, where it was the combination of ACM with combustible insulation product. And indeed, I think in the Melbourne tower, it was stacked. In addition, they had stacked balconies, which were being used as an extension to the apartment, and were, I'm not sure were they semi-enclosed, but there was a lot of combustibles on the balconies. The balconies weren't sprinklered, the apartments were sprinklered, but the balconies contributed to the rapid vertical fire spread and the sprinkler system being overcome. So there's a few other factors, and the design of balconies is also in the frame in residential buildings. And now this is the more tedious bit, is what is the Irish and the corresponding technical guidance across the water saying? I mean, this is a key statement in B3, which is internal fire spread, relating to compartmentation. And it says, the junction of the compartment wall or compartment floor with other walls, including an external wall, which typically will not be a fire-resisting wall, should maintain the fire resistance of the compartmentation. Now, that's a tall order, which could be hung around designers and, including the fire consultant, but perhaps all of us, if we don't give due consideration to how are we complying with that objective in the technical guidance. And I've thrown up, and these are some very, very typical generic details from some guidance, showing what might be regarded as typical fire stopping details. Now they're always a lot more complex than that in practice, but it's have you combustible insulation? Does your and they're suggesting in that guidance that you take the fire stopping at the floor to the back of the spandrel panel, but provided it has a fire-resistant lining. If it doesn't have a fire-resistant lining, you must take the fire stop to the outer face, and then if you have non-combustible insulation, it's less of a concern. So they're kind of giving you principles more than actual details. A key parameter is and I think, again, referring back, we've often over the years had particular fire authorities in assessing fire cert applications saying, we don't like the robustness of this detail, we want a fire-rated spandrel panel. So in that case then, that's the spandrel panel, it has the 60 minutes rating in itself, it is fixed back to the slab in fire-rated bracketry, and I mean, that's a more robust solution, but it has massive impact on the design of the facade. Now, that's not typically done here. It was interesting that in Paris, I think, there was reference to a type of fire-rated spandrel being used as a means to avoid sprinklers. I know in regulatory circles, there's a school of thought emerging that if a building isn't sprinklered, it should have a fire-rated spandrel panel. If it's sprinklered, it doesn't need it. And that's not dissimilar to some of the recommendations in international codes, in the States and Australia. But that's the kind of, the typical detail is based on those principles that we are involved in and typically approved in this country. But I think we have to tread with a degree of care given the wording of the prescriptive statement in the technical guidance. I think Tom earlier referred to double-skinned facades, and indeed we've been involved in a number of of double skin facades here, and this is, I think, an example of one we're looking at the moment. I think I've taken the references off it, but I mean, in that case, we have the second skin glass. We have at each floor level we have a walk-on open grid metal grating, and then we have a double skin or a double glazed inner insulated panel with an openable door window section, which is linked to the fire alarm to close on detection of smoke. And then we have a single skin outside. Now that doesn't comply with the prescriptive guidance because it's a cavity straddling a compartment floor. But I mean, fire engineering can be used to demonstrate that fire will not spread to the upper level via that detail. Now, I mean, we would typically use CFD modelling of a fully developed fire on a floor and look at, the flame projection out the windows and the sequence of breaking of the glazing to demonstrate that we're achieving the equivalence to the prescriptive recommendations. A significant benefit in that analysis is the presence of the metal grating, and we would be specifying that be steel, because that will stay in position, and while it's perforated, it has the impact of deflecting the flames out to the outer pane of glass and causing the breakage of that earlier in the sequence of events. So, I mean, there's a number of projects where that has been successfully done in this country, and it continues to be done, albeit everybody's getting more conservative in their approach on facade design. But I mean, it's a necessity that we develop design solutions for double skin facades. Now back to this is a long, and I'm not going to go through it, but I mean, essentially Technical Guidance Document B of 2006 and updated in 2020, it kind of deals with external fire spread via the external wall. It has fairly detailed, simple recommendations on the surface flammability of the external surfaces, which is easy to interpret and easy to comply with. In relation to the external wall build-up, it very clearly says the external envelope of the building should not provide a medium for vertical fire spread. The use of combustible materials, combustible thermal insulation, or overcladding in drained and ventilated cavities may present such a risk in tall buildings, and it was kind of prophetic that statement was in there. Now, in that technical guidance, it went on to say that in insulation material used in drained and or ventilated cavities in external wall constructions should be a limited combustibility, which essentially is rock wool. And that was a kind of a pretty, and this is buildings over 18 metres high. This doesn't apply to masonry wall construction complying with diagram 17, which is inner leaf block, outer leaf block or equivalent, and a sealed cavity. And then at that time it cross-referenced to BRE 135 as advice on thermal insulation material is given. So it was giving you the option of going down the BRE 135 route, which I think we were doing, continuing to do. That's the table. I'm not going to go into that. Approved document B, I said in England, the latest version of it is kind of, I put it up there because it has now been taken as the reference by some of the fire authorities here, and it's some or all of it may find its way into the revised Irish Technical Guidance Document B. Now it is saying for buildings other than buildings described in Regulation 7, and Regulation 7 applies to residential buildings, and I'll come back to that, but in all other buildings, it's giving you the option of going down the prescriptive, more conservative route of using Class A2 or limited combustibility insulation, which is essentially rock wool, or filler material in the spandrels. The external surface is the same criteria as is in TGDB, really. I don't propose to go into it. And cavity barriers, dealt with in the traditional way at all floors and around windows. That's one option. Or the alternative option is meet the performance criteria given in BRE Report 135 for external walls using full-scale test data from the 8414 tests. So that's still an option under the England and Wales, or the England approved document B, which is being followed here. And the recommendations in that are identical, or pretty identical, with BS 9999 and BS 9991, which we use in this country for the design of buildings, typically in the case of 9999, and for apartments in the case of 9991. So, you know, that has been the criteria. Now, then, and I suppose that's what was in approved document B prior to the Grenfell tragedy. I just thought I'd put up an example of, this is a photograph of a test we were recently involved with in Jordanstown in Ulster. And this is the 8414 test, which 8414 part 1 is where the inner leaf is of masonry construction, and then the outer leaf is what you're going to build in terms of insulation. And now in that case, that build-up was a stone rain screen and a PIR phenolic insulation of one of the well-known brands. And that's, I think that's something like 6 meters or thereabouts high, and it's about 2.5 meters wide and 1.5, and that's the large wood crib that represents the fire. The next slide shows that, you know, the cladding system during the fire at 23 minutes. So it's a pretty severe fire. In that case, that cladding, that rain screen or that wall construction passed the test. So the test criteria, you know, are quite severe. I mean, and they're measuring thermocouples, they're measuring vertical fire spread in the cavity, they're measuring temperatures in the cavity. So that's an example of, it is quite a severe test. And there have been people out there saying, well, the test isn't severe enough, and there were some people in the UK insurance industry questioning the adequacy of that test. But in our view, it's quite a severe test, and you know, a lot of the more regular construction build-ups, you know, are being shown to meet that test. The problems have arisen with some of the aluminium types and others, not just aluminium. Now, Regulation 7.2, and I'm near the end of the presentation because I think, was that a gong telling me it was? Yeah. Regulation 7.2, and I won't go into this in detail, this is England's regulation, which Irish fire officers are tending to say, we want you to comply with this. And I think most, if not all, the recent residential developments we have worked with, we've been on in Dublin, Dublin in particular, we're on outside Dublin as well, but the Dublin fire officers tend to say, we think you should adopt, notwithstanding the Irish technical guidance isn't updated. And it is saying, you know, it applies to buildings, a building which contains one or more dwellings, it contains an institution, which is a hospital and similar, a room for residential purposes, excluding a room in a hostel, hotel or boarding house, so they're excluded. So, I mean, the inclusions are basically student accommodation, care homes, sheltered housing, hospitals, dormitories and boarding schools and apartment blocks. And, I mean, Regulation 7.2 in a nutshell is saying that all materials which become part of the external wall or specified attachment to the external wall should achieve a Class A2 S1D0 rating or a Class A1 rating, other than those elements exempted by the... So there are certain exemptions from that in the regulation. And the exemptions, I mean, there are some challenges presented by that requirement in the UK that are kind of working their way through the system. We're not having to face them here because I think we're having a more sensible interpretation of it. And external wall attachments include balconies, solar panels and sun shading. And that's the addendum. So the exclusions then are membranes, except membranes need to, according to the approved document B, need to achieve Class B, which is somewhat lower but still quite a high rating, and window frames and glass, including laminated glass, are exempted, but window spandrel panels and infill panels are not exempt, and that includes laminated glass. So the laminated glass is a challenge, and it's a challenge on balconies, and that's a challenge that has to be risk assessed, and I mean, it's a challenge in the UK that I don't know, has it been fully resolved yet. And finally, I kind of put up the last slide in saying, you know, the references that I've kind of quickly glossed, you know, passed over there that we would tend to, well, that we draw on is, I mean, TGDB 2006 and amended 2020 is still the primary Bible in this country. It's under review, and we're expecting that a draft for public comment should appear before the end of this year. We've heard that last year, that it would appear last year, it hasn't. And I mean, from my grapevine knowledge of it, they don't appear to be adopting in full the prescriptive requirements of Regulation 7, but fingers crossed. BS 9991, which deals with apartment buildings, and 9999 deals with a whole raft of other building types, is accepted as an alternative to TGDB generally here with some tweaks. And so we tend to, also refer to that, particularly in relation to office buildings. I've just referred to approved document B in Regulation 7 because it is informing what's happening here. BRE 135 and its associated test documents we've kind of covered, and that's still a Bible. Significantly then, BS 9414, published in 2019, is a document on interpreting or applying the results from an 8414 test. And this is an alternative to the desktop studies that got into serious disrepute after Grenfell. So this has a very rigorous approach to interpreting results and applying the results to slight variations or variations from the tested combination. And you need to get an expert evaluation report on the deviations to demonstrate that if your wall construction varies slightly from what was tested in some respects, within the parameters in that code, you can accept or you can prove that it's achieving or demonstrating compliance. I've referred to the CWTC and Society of Facade Engineering guidance, which we would cross-reference to. There's also an interesting BS on the design of balconies and terraces, which has a section on performance and fire, which gives a little bit more clarity and support to kind of move away from some of the very prescriptive requirements in Regulation 7. I think that's it. Yep.
Thank you, Michael. And staying on the theme of fire, we will hear from Barnaby Carrick, who's a technical engineer at SideRise Group, on some of the compliance and product testing that they have been doing.
Thank you very much. Good afternoon, everybody. So this presentation, what we're going to be looking at is essentially, as I say, very similar to what we've just been looking at, managing that fire risk within external wall build-ups or external envelopes. So I do warn you, there's quite a few slides in this, but we're mainly skimming over a few of these, as there's quite some similar slides, as you may have already seen in previous presentations. Very brief introduction about SideRise. We are a manufacturer of passive fire protection systems, which for many applications, different kinds of external envelopes. And we've very much now become a global brand from quite humble beginnings. Some of you may recognise brand names such as Lamatherm or Lamathon. That's SideRise brands, that always has been, but recently, or in 2013, unified into the SideRise brand. And we, as I say, deal very much worldwide, been involved in, very gratefully, a lot of these Zak events now, which has been great to speak to so many people about passive fire protection. Now, with Ireland, fantastic opportunity is that we have a great partnership with a company called Thermal Insulation Distributors Limited, or TIDL. Both TIDL and ourselves are extremely knowledgeable and have great expertise within the passive fire protection industry. So you've got a very local point of contact, and we work very closely together with these projects. So this is a great opportunity to work with both of us. Now, very briefly, I just want to go through a couple of quick definitions, all very familiar stuff, I'm sure. But first of all, when we're looking at an external envelope of a building, typically we're categorising them into one of three, caveat 4, different kinds. You tend to have your curtain wall systems, your masonry systems, and then some form of cladding, tends to either be categorised as ventilated systems or non-ventilated, which are obviously far more rare, tend to be more ventilated systems. Within these systems, we need to protect them against that external fire spread. As has been discussed today, it's very important to make sure that this route for fire propagation is slowed down as much as possible, because it is very much a primary route for fire spread. So with that, we have different kinds of products for these different applications, such as cavity barriers, open state cavity barriers, which is the same as a cavity barrier but allows for ventilation in the cold state, and then things like fire stops, which essentially can look like the same kind of product, but essentially they're fulfilling very specific functions or performances within these different applications. Now, when you're testing fire protection products, what you're testing to is primarily two different kinds of category, something called integrity and the other being insulation. Now, you may occasionally see the term load-bearing capacity, or the letter R, floating around, but that's for structural elements, so not applicable to fire stops and cavity barriers. But what we're looking for are the little letters E and I, integrity and insulation. And these are measured in minutes, and it gives essentially the performance of these products. So going into some of the regulations and guidance, and again, there'll be a few similarities here as a few slides you've already seen. But the first thing that we always recommend being aware of is, as we've seen over the course of the day, it's a very much changing environment. There's things that are going on, consultations, different sort of codes of practice or better practice, all of these sort of meetings such as today where we discuss things, and it's sort of developing and driving for a much safer built environment. So it means that the environment's changing quite constantly, and that can be quite difficult to keep on top of. So the first things first is to refer to our guidance documents, which essentially are, whilst they're guidance, not necessarily fully legislation, they are the best point of call for actually seeing what needs to be done as an absolute minimum. But we again always recommend seeing them as these are the points where it's a minimum. It's not necessarily what needs to be done. So often you might get extended or increased performance requirements. And obviously we have a technical guidance document B for Ireland, which is where we'd be looking at primarily. And again, we'd highlight a couple of sections in particular within technical guidance document B, which is B3, highlighting very much the importance of fire resistance, compartmentation, and things like subdivision, purposely dividing that building into smaller sections to slow down that propagation of fire. And it stresses, therefore, the importance of cavity barriers and fire stops within these systems. You then have section B4, which is very specifically talking about things like external walls, these envelopes, which, as I say, primary route for fire spread, and also roofs. So it's a very specific section B4, but again, it just stresses that importance. As Michael was just highlighting previously, not so long ago, in England we now have Regulation 7 that's came into force at the end of 2018. And this regulation is essentially a ban on combustible materials within an external envelope. Now there's several parts to that. First of all, is it's only applicable to what's called a relevant building, which again, the details or the definition are under consultation and may well be changing quite soon. But currently is a building with a story above 18 metres and contains a dwelling or a room for residential purposes, things like that. It has some exclusions, which again may be reintroduced into that definition because again we're looking for a safer built environment overall. And there are some exempt materials there, as you can see, part 3 on the right there, where some materials we just cannot have as a full non-combustible A1 or A2 classified material, and for them to still function as an actual what they're intended for, like certain waterproofing materials or gaskets, things like that. However, there are still tightened restrictions as to what they can do or can perform, using the same example of membranes being classification B, S3D0. And whilst obviously this is an English regulation, why I bring it up, it is very much being the sort of direction that most of the world are turning to, certainly across Europe, across the UK and in Ireland, as mentioned before, Technical Guidance Document B is looking to introduce some of these changes, perhaps not verbatim, but in a similar light. The next sort of place that we tend to then recommend to go to are some of these important advisory bodies out there in the industry. So the likes of the ASFP or the CWCT, which we've heard quite a few details about some of their guidance documents today. And again, whilst they may be above and beyond regulations, it's all about best practice and trying to find that safer environment that we're looking to build together. So now just looking at a little bit more detail of component testing and system testing. So how these products exactly are tested. How can we prove that they perform as they need to perform for these specific applications? Now, first of all, there can be a bit of confusion between some of the different terms. A lot of them are very similar. So one of the first I'd point out is the difference between reaction to fire and fire resistance. Reaction to fire is where we're looking at these classifications. So when you've got something that's deemed a Class A1 non-combustible material, it's all about how a material will react when exposed to fire, what it does, what it produces as it degrades when exposed to the fire. Whereas your fire resistance is essentially the time period before it starts degrading and allowing that fire to take an effect or pass through it. So how good it is at essentially blocking that fire from passing through. Now, in terms of going down the right avenue and how do we know what's right to test and what kind of standards, as we know there's hundreds of standards out there, there's a lot of documentation that gives us very good pathways as to what we should be testing to and how we can prove compliance to local regulations and guidance documents. So starting, for example, with this European assessment document, it's far too long of a number for me to read out, but essentially it gives a very good route for linear gap seals and how we should be testing them to which standards and how we can get assessments done to make it easier for the end user and for specifiers to ultimately specify and use the products and know that is the safe thing to do. So for example, and it looks far more complicated than it actually is, but a little flow chart there just sort of showing the direction that you're taking through on this particular EAD. Essentially looking at European standards, obviously being the primary standard to be testing against, and we're looking at whether it's cavity barrier or a fire stop, so whether it's in a concealed space or a cavity. If you're in a cavity barrier, you're sort of taking down the route of whether it's open state, for example, ventilated cladding. If it is sort of closed state, so it could be anything or verticals in a cladding environment, then you're taken to 1366 Part 4, whereas if it's an open state barrier, you're taken to the Technical Guidance Document 19, which is drawn by the ASFP for testing open state. However, if you follow the route for fire stopping, so we're more looking at internal applications such as curtain wall application, you can see there how it very quickly directs you towards the standards of 1366 Part 4 and 1364 Part 4. Which again, all very similar numbers, which doesn't help sometimes with the confusion. So what exactly are these, apart from similar numbers? Very briefly, the 1366 Part 4, which is one of probably the main ways that fire stops and cavity barriers are tested. It's as you can see, a seal that would be installed within a concrete aperture, and then again, you turn your furnace on, following your time temperature curves, making sure that the product isn't allowing too great a heat through it and for the fire to break through it. And then what element of time in minutes you have is the rating that you then have for that product. You then have your 1364 Part 4, which is quite a different setup, where again, mounted on a furnace, this time we're actually installed in more of an intermediate scale, more of a sort of closer to a system test, where you actually have a curtain wall system in there and a floor slab, slightly more true to life environment. Another important part of this standard is that you'll be looking at actually doing cyclic movement to the sample before the test. So it also proves that, or goes towards the durability and service, which leads us nicely onto the next slide. And as we've also seen today, the importance on acknowledging this movement that occurs within buildings. Particularly unnoticeable, sort of you wouldn't think it, for especially some of these tall buildings that we build, there is actually a lot of movement. And quite often when you're dealing in the fire stopping industry, you're looking at calling, or you tend to be calling this gap a fire stop gap, because it's where the fire stop's installed. But in reality, it's a movement joint. So it's so important that whatever product's being installed in there, it's got to withstand that movement for the durability of that entire life of the building. And also bearing in mind that in the event of a fire, when all the elements are heating up and becoming more malleable, it's only going to move more. So we need to make sure gaps don't start opening up and that products can actually allow for that excessive movement which starts occurring. So it's important to, when we're looking at this route, to ensure that the products are compliant, looking at involving this cyclic testing within the test standard. Main difference that allows movement with fire stops and not, just out of interest, is the difference between a horizontally fibred material. So the fibres on the stone wall are running horizontally, perpendicular to the surfaces, versus what's called a lamella orientation or vertical orientation, which is part of the side-rise brand, hence the Lamatherm names that used to exist. Whereas you can see on the right there, that product's fibre direction is running vertically, and that allows for essentially an indefinite movement. Another important part of durability in service, perhaps not so much in a curtain wall construction, but certainly with things like rain screen cladding, but is also important to know, especially when you have people sweeping all the puddles onto the edge of the floor slab during construction, is all about the ability to be resistant of moisture exposure. So again, how do we actually test this? Well, interestingly, whilst there are standards out there to obviously perform accelerated aging and testing the sort of exposure, both UV and environmental, to products, they're not really specific, or there isn't a specific guide for fire stops in particular. So that's certainly why, whilst we take it upon ourselves to test to these standards, we'll also test it to the worst case scenario, which is what's called the Type X, going by the EOTA TR024. So Type X is as if it's sitting outside, completely exposed to the weather. It cycles through different temperatures, freezing, heating, different sort of pressures, elements, and then obviously UV exposure, so how much of that UV light it's exposed to. And then test that product versus brand new unaged product in furnace tests for the fire tests to make sure that after that aged sort of testing, it's still going to perform as intended, just as if it's brand new material. Now, if you tick enough of these boxes and you're able to satisfy the harmonised standard, if there's one available, you can then opt to go for CE marking. And it's something that we're very proud of, that we've achieved CE marking of our fire stop system. And it's certainly a route that should be sought out for, again, making it easier to have comfort in specifying and using products such as the side-rise fire stops. Now, jumping back a little bit to some of the component tests, another test here for open state cavity barriers is, as I say, that TGD19, which is currently the used or the accepted standard, but it is actually being adopted into a new EN standard, the 1364 Part 6. Now, very similar to the 1366 Part 6, in fact, based largely upon it, with a few little differences. As you can see from the diagram there, we're actually installing an open state cavity barrier into a furnace and an upstand, and it gives you the opportunity to install thermal insulation above and below it, so we can actually see how it reacts, whether different types of thermal insulation will actually aid that protection against fire spread, or it will hinder it. So it's very sort of complicated test, but essentially gives you some really good true to life data, albeit some argue it's still tested between 2 leaves of aerated concrete. And that is where system testing comes into play. Things such as the BS 8414 test, where you start testing against, say, for example, a Part 2, you'd be an SFS in a leaf, and then you have different types of insulations, panels, supporting structure, absolutely everything as a system would be built. You're looking at then testing that and seeing how everything works together. So finally, just a brief look or summary to some of these applications. As I say, curtain wall facades are sort of one of the probably most common types of facades you come across, and there's different variations within them, such as stick systems and unitised, where you have precast or GRC elements. And the reality is, regardless of any of these differences, you still have just that vital need for fire stopping within that movement gap. And essentially it only really changes maybe the sequencing of installation. The products tend to remain the same. And as I say, typically, again, hammering on this point of movement, the typical specifications you'll see will be looking at accommodating for movements such as wind loads, live loads, any of these types of deflections. And again, as I say, during a fire, these deflections and movements are then exaggerated and much greater, and we need to make sure that both smoke and fire is prevented from propagating through it. Now, something again that's been touched on today is this idea with protected spandrel zones. As if you've got a sealed chamber or this environment, this compartment, then quite a lot of stress is built up on typically the glazing units, where it will often break out first. But if that is sorted, particularly with things like sprinkler systems, the next weak point tends to be that spandrel zone. So the idea of, whilst it's not regulatory all across the world at the moment, in some areas it is, such as Spain and the UAE, is having actual protected spandrel zones. And there's different ways that can be achieved. In fact, we've developed a couple of systems as to how that can actually be worked from just a non-fire rated facade, protected with a couple of products, to actually give you this now protected, upgraded facade, tested to these European standards, 1364 Part 4. Then going on to masonry, obviously quite a different kind of facade type, tends to be far more robust, or at least regarded in that way. The actual outer leaf of that is, as I say, being masonry, being brickwork, it's seen as much more robust. But it can be quite a complicated cavity you have within there. And there's many different products and different components that are sitting within it. And we need to make sure, regardless of what's in that cavity, to prevent the spread of fire and smoke through it. But also importantly, to prevent that fire and smoke getting into it in the first place. So it's where cavity barriers will be utilised, but also there's a different kind of need for making sure that weatherproofing in terms of sort of cavity trays and things like that. Briefly looking again at that Regulation 7 before, part of that in terms of the exempt materials is cavity trays when used between 2 leaves of blockwork. That does actually mean that if it's not 2 leaves of blockwork, so you have an SFS, you then need to start looking at non-combustible cavity trays. So it's certainly a space to watch, and something that we've also started developing our own form of. And then finally, we've got ventilated facade systems, which again, very specific application, where you have these many different types of lightweight cladding systems, and many different components within these cavities, which we need to again prevent that spread of fire and smoke within and penetrating into. With that, we've also got to bear in mind the fact that these systems are drained, there's air movement, and if we try and stop or we block any of this, then we can actually have quite adverse effects on the system and how the system performs overall, generally having problems with things like potentially mould or degradation of products. So putting a conventional completely full-fill barrier in there horizontally is just not achievable. We need to use what's called an intermessing material, which will remain dormant in normal state. However, in the event of a fire, reactive to heat, not the flame itself, that intermessing material will start reacting, expanding, closing off that gap, and then you regain that compartmentation. So the last couple of slides are just the case studies, but I'll just skim over those because I'm conscious of time. But a few lovely projects we've been involved in over here, such as the Dean Hotel in Cork, and we've got also Horgan's Quay, and there's another project there, Hanover Quay, right here in Dublin. But we've been involved in many projects, again with our partners TIDL, and we do have a stand just in the back corner next door. We're more than happy to discuss anything if you wish to. Thank you very much.
operating facilities to meet the owner's requirements, so that the owner gets what the building says on the tin, basically. The objective really is to reduce the cost in delivering projects, so there's less delays and defects, and increase the value to owners. So it's another verification document. So the whole issue with sustainability, with benchmarking buildings, becomes around the credibility of the performance rating on those buildings. So it's another means of having independent oversight that says that this building, it doesn't just have a sustainability badge, it actually performs as a low energy, low carbon, low resource building. So the commissioning process is about identifying and correcting issues before they become a problem. And it's about confirming that key components have been designed and interfaced and commissioned and checked before they're handed over and go into operational stage. So within LEED and within BREEAM, they've made commissioning part of the sustainability evaluation for buildings. So at the moment, it's you have to commission your mechanical systems, but for your facade, it's an option. So it's an option to get additional credits, 2 credits in LEED for building enclosure commissioning, and within BREEAM, MAN 4 is also 2 credits. But it's not just about chasing the credits, it's a tangibly better outcome for buildings. And so you have an integrative process involving the client, the designers, the subcontractors, the specialists, and the main contractor. And you also bring that through to the facilities management or the future tenants management team. Part of that process is around reviewing design. So it doesn't attempt to replace, the due diligence work that's been done by the architect or the facade engineers or the fire engineer. It's simply just making sure that it's structured and consistent and that all that good information flows through from design and construction stage into operation stage, so that those that take on the responsibility of managing the building understand why certain decisions were made, why certain equipment was used, why, how to maintain the facade, the seals, the service life, etc. So it's based on planning and having a good schedule of tests, benchmarks, prototypes, and the documentation to back that up. And key to it is having a clear test and inspection plan that everyone can roll in behind. And it'll also track construction issues and any deficiencies. Part of that as well, you can look at risks and opportunities to enhance the energy efficiency. So the London plan has quite a good way of looking at energy efficiency. That, first of all, you need to optimize the energy performance of your building by being lean and using less energy, and then be clean. So select a fuel mix that's lower carbon, and then be green. So use renewable energy. And beyond that, then you're either into offset or else you're trying to optimize that building through management and controls. So commissioning is part of that management and controls, and it's about about having good info, good data, and really squeezing that last bit of inefficiency out of the building. I suppose in the current context, sustainability is now the driver, and what used to be a niche or a value add to buildings is now fundamental. So ESG is now the buzzword in this area, that it's actually the financial markets that are setting the thresholds for energy performance. And their view of energy performance isn't the badge that it gets when the building is handed over. It's actually what the annual reporting is. And they want to see that your annual energy reports for new building or for renovation or cut and carve or whatever you have, they want to see that every year that lemon is squeezed to get more and more higher performance, better efficiency, lower carbon, better fuel mixes. And we have to do this, they say 3 years, but this starts now. This is a pivot to a new reality, a new zero carbon reality, because we have a short enough time to do this. And building procurement takes time. But we've a very steep graph ahead of us. Really, a lot of the heavy lifting has to be done between 2025 to 2030. So you can already see that where the market sentiment is. So, already the media is picking up that some of the most sustainable examples of buildings, the LEED Platinum buildings, that they don't exactly do what it says on the tin. So they, in a recent article in the New York Times, looking at a flagship product, it highlighted that LEED rating can be really just a snapshot. That that having a stamp on having a stamp of sustainability on a building isn't everything, and that there is an acknowledged issue that certified green buildings can end up using just as much energy as say their non-sustainable neighbour. And sometimes this is called the half-fat cake analogy. And I had too many of the cakes at break time there. They were quite good. But the analogy being that because the cake is half the fat, you can have twice as much. Well, it's a bit like that with very low energy buildings or sustainable buildings. The operators of that building think all the heavy lifting is done. They think all the work is done, and that management isn't as essential. So this is really about the performance gap, and there are reasons for that. There are reasons why buildings use more energy, different user profiles, but the one that we're looking at here today really is because of the use of buildings. We can design buildings with some level of certainty, but we don't know how the clients will maintain or operate those buildings, and often we don't exactly know how to manage performance and quality at construction stage. So it's about putting a framework around that so that we can build in training programs for the BEMS. We can build in very rigorous criteria and controls around air tightness and thermal bridging. So there is a way around that. And when we look at some of the LEED buildings, now I'm, as a LEED AP or a LEED GA, I'm a big fan of LEED, but it's not the full story. And even for a building that houses a research institute focused on architectural sustainability, when they monitored their own building, they found that in year 2 the performance gap hadn't got below 23%, and they researched that building and they came to a number of conclusions. And what they found is that more stringent energy and sustainability regulations aren't necessarily reflected in the as measured performance of the building, and perversely, it seemed that some of the most efficient and sustainable buildings, living buildings, LEED Platinum buildings, that it seemed that proportionally their energy consumption was 60 to 150% worse than predicted. Now, some of that is down to the way that we measure energy performance. In fact, most of it is that we measure it using certain assumptions. But the other part of it, and the critical part related to commissioning, is that, who was checking at the handover of the building that all those systems were optimized, that that you weren't wasting energy through details that were never checked or never tested. So what CIBSE in the UK had looked at is they took a whole range of building typologies and they measured them over time. And say the central green bar here is office buildings, and for a lot of them, they're their performance gap is almost twice what was predicted. And you know, as Arup mentioned this morning, that's kind of a figure that you know, that needs to be looked at in more detail. So the Better Buildings Partnership has also studied this performance gap, and they've looked at a few different areas. One of those areas being how the buildings are actually measured in use, that should become the benchmark. But one of their main recommendations was that the critical interface is the intensive commissioning and fine-tuning, not just of the systems, but of the overall fabric. So to make sure that the insulation on the roof is correctly installed, that the penetrations for services are correctly done, and on facades that there hasn't been changing to the glass to the G factors, and that it has been installed to meet the performance requirements, specifically to do with air tightness, making sure that expansion joints are closed and that there's continuity of insulation, particularly at areas like ground contact and parapet, and any difficult interfaces where, you know, you have a three-dimensional junction. So to look again at that lack of correlation between energy standards and energy labels and performance, you can see here in the UK for measured buildings that the energy label was no real indicator of how that building was performing. And you can see that the pattern of the scatter of energy use for B and C rated buildings isn't really that different to the scatter for D and E rated buildings. And that performance gap, where is that occurring? And as we said, a lot of it is just through the unregulated loads. So, you know, energy that's used outside of operational hours isn't really counted. So that's quite a big part of it. But another big part in the bit that we're concentrating on is this difference between you know, the systems being commissioned correctly and not. So our current approach to design really is design for compliance. What they're advocating is that, you know, the outcomes of a building, the end use energy of a building is quite critical. And so we need to build in a feedback loop, a process that needs to address compliance, and that changes from a design for compliance to a design for performance. So in a design for performance approach, there are three elements of that which are important to us, so that you have an independent entity that's reviewing the design and just making sure that those priorities can be focused towards commissioning. Now, most of the facade engineers, most of the architects that are in this room have an understanding of that and have that built into their own process. But it needs to be universal across all building types, particularly public sector buildings. There needs to be, you know, a process for and a plan and an implementable plan for intensive commissioning and fine-tuning the systems, making sure that the heat pumps are optimized for the tenant demand. And during COVID, that became very, very difficult to do because you didn't have good occupancy levels. Where you have actuators that use natural ventilation in atriums, you have to make sure that, you know, the thermostats for that are set up correctly and that it works. And then it comes down to the people. And, you know, on my team, we've got Brian Guinan, one of the most experienced facade installers in the country. And he's trained most of the installers and half the engineers in Ireland. So, you know, he understands how components get put together. So, you know, I can do the theory, but not the practical side. So having a good team is important on that. So it's a life cycle approach. So, you know, you start early in setting the goals in defining what's going to go into the specification, what's communicated to the sites team. And within that process, you review design, and then you can also build in an intensive commissioning cycle of tests, of verifications at completion stage, and then in use, you're putting down on paper what needs to be communicated to the end user, what documentation needs to flow from construction into design. So early engagement. And again, sustainability is important. And even though we've radically changed our building regulations, the operational carbon of our buildings, it remains pretty much flat because we're building twice as much in this country as we were 8 or 9 years ago. But we do need to address embodied carbon. That's going to become the big elephant in the room. But this isn't going to come from regulations. This is going to come from the financial industry as they start to apply climate action from the EU, as they start to adopt as a classification language the EU taxonomy. And that's where LEED and Levels and DNGB and BREEAM, they'll all converse towards a single view of sustainability, and commissioning and rigorous commissioning is going to become part of that. Within that, you build a plan. That plan has a number of different elements within it, such as who is the design team, what are the responsibilities, what are the key details, and that then is applied to the project. In terms of return on investment for commissioning, it's said to be about 13% yield on that investment. And as a process, it's fairly straightforward, it's fairly linear. You can build it on top of your existing process, but it will have tangible results and it will become a bigger component of all projects. So the takeaway really is to build it into your overall project life cycle, get it in at the design, the tender stage, and then let it run through the project from design stage right through to operations commissioning. Build in the precise parameters for air testing, review details to make sure they're thermal bridge free, that they're isolated, check for condensation risk. You can do post-hoc thermal assessment to verify those details. And inspection and testing is key to that. Okay, so thanks for your attention on that.
Thank you very much, Archie. That was really interesting stuff. And I think we're going to need to do a lot more of that in the future. And you've highlighted the performance gap between what is designed or what is expected, and even sometimes buildings that, saying in the break, that achieve a LEED excellent can be well below what is expected of them. So these things can't be left, if we're going to be truly sustainable and plug all the gaps, these things can't be left to chance. So some of these regulations will also have to be modified and updated. So thank you for that. The graveyard shift. We have James Brackenreed-Johnston, who is going to talk to us about airtightness. So take it away.
Thank you kindly. Good afternoon, everybody. My name is James Brackenreed-Johnston. I'm the head of facades for the A. Proctor Group. So today, what we're going to be discussing is airtightness membrane solutions for high-rise. So there's obviously a multitude of products that we develop for the high-rise market and the low-rise market and the mid-rise market for off-site and modular, but obviously the focus today is for the high-rise. So today we'll look at heat, air, and moisture management, which is our core principles in regards to our HAM principles. We have a concept reality philosophy, so we're there at specification stage, probably around stage 3, all the way through to the completion of the project. But because certain aspects of this presentation have been covered in depth in the last 3 presentations, I will go into that sort of compliancy side in more detail. We'll go over, obviously, the amendments to BS 5250. If you don't know, there's been another 70 pages that's been added to the BS 5250, so it's a much more in-depth detail. And as with what building regulations are trying to do, they're trying to make it a lot less ambiguous for the specifier in order to make sure that they adhere to what is required in the building regs. We'll then go over the membrane types and functions, again, referring to BS 5250 in relation to those. We'll go into slight fire performance and testing, because obviously that's been covered fairly in depth by previous speakers, and then a membrane systems overview. So initially, when we're dealing with an architect and we're looking at hydrothermal assessment, what we'll take into consideration initially is the occupancy of the building. So whether it's a residential occupancy, whether it's a commercial occupancy. Ultimately, with the residential, you've got the higher initial moisture loading from the occupants of that building. We need to understand how that building is going to be utilized. Then we look at the actual building itself, so how that building is constructed. If it's constructed obviously from a concrete frame structure, then those initial moisture loads within that building envelope will be a lot higher than if you, say, had a CLT build, which, relating back to previous conversations in regards to getting timber back into the construction market for sustainability, it is an option. But initially, those loadings, those moisture loadings within the timber is obviously very minimal. But when you come to thermal mass for the longevity of the build, for the lifetime of the build, that concrete will harbour that heat more and re-deliver it back into the build at night. Whereas with the timber side, you won't have that thermal mass, so the mechanisms of ventilation that you're utilising within that project need to be taken into consideration when looking at that. We'll then, once we've sort of elaborated what's going on internally within the building, we'll then look at the outside. So obviously we have no control over what goes on the outside. So utilising the WFI software, which is the Vormundsfruchtig Stationär from the Fraunhofer Institute over in Germany, we can utilise satellite weather data for the actual plot of land where your building is going to be built. So we require the orientation of the building. We require the layout of where your rooms are in your property. So especially if they're a moisture-laden area, like a bathroom, like a kitchen, we need to know if they're going to be on the exposed side, so the external wall side of the property. The orientation of the property, as I mentioned, whether there's any overshadowing. Obviously in Dublin, there's more and more of these high-rise, not obviously next to the river, but step back, and these high-rises are coming up. If there's going to be any overshadowing, if there's any planned phases of future development in that local area. You know, nobody's got a crystal ball. If it's not planned, we can't plan for it. But ultimately, if there are separate phases coming up in the future, then please let us know the height of that build, how much that's going to overshadow the building that you're doing at that moment in time. We can take that into consideration. So that leads us to our core philosophy, which is the heat, air, and moisture movement, or heat, air, and moisture flow within those buildings. We don't just look at our membranes in the build-up. We look at the full build-up. We look at the building use. So we take into consideration the heat source within those properties, okay? If you've got a residential property and you're putting radiators in that property, you're basically allowing those occupancy to utilize those radiators to dry their clothes, okay? So that moisture within that apartment will increase. If they've got underfloor heating, they have no ability to utilize those radiators. So you're reducing that moisture load. So this is the sort of information that we can help and advise on in order to make sure that you're keeping that moisture load, even on a residential purpose, as low as possible. Taking into consideration the air tightness. Air tightness in Ireland is better than the rest of the UK, put it that way. Even now, obviously, we've reduced over the water, as it keeps being said, we've reduced now from 10 as a backstop to 8, which in comparison to mainland Europe is still abysmal. 7 is the best from this country's point of view. In regards to the UK, we're looking at 7 as our backstop, 8 as our backstop at this moment in time, which still means that it's designed to a 5, maybe a 4, to achieve that number because of the performance gap that's been mentioned before. So this is why we do all the way through the project to completion, is to make sure that we monitor the installation, make sure we're checking on how the product is being installed, because this is the air tightness line for the property to achieve regulation. BS 5250 has finally caught up with this philosophy. 15026 has been talking about dynamic numerical simulation and hydrothermal assessments since 2018. So BS 5250 has finally put it in there in regards to utilize hydrothermal assessments, utilize dynamic numerical simulation, because it's a much more enhanced version of the Glaser method from the 50s. Okay. So facade considerations, so the structure of the building, the materials that you're putting in there. When we carry out the hydrothermal assessment, we take into consideration the moisture that's actually within those products from manufacture. No product, when it's manufactured, is completely dry. There is inherently moisture within there. The Glaser method assumes that the whole build-up, whether new build or retrofit, is completely dry. As we've heard today from Barnaby in regards to open cavities, we all know this happens. We all want them to close the cavities at night, but do they? No, they don't. We can program the system to provide you with saturated insulation, so you can see how it performs then, or medium saturated insulation. Whichever way you want to go, there are parameters that we can change to do worst case and best case scenarios. So all of those materials, if you've got a name of them, if you know what thickness they are, then we can obviously work with you in regards to that. Environmental conditions, so obviously where the project is very key. Insulation placement, we can advise on that as well. Obviously, depending on, obviously we work UK mainly, Northern America, the UAE, and Australasia and Asia. So depending upon where we are in the world, sometimes we have to reverse the system because the condensation risk is reversed. So we've got the vapor control layer externally and the breather membrane internally. So moisture loadings, understanding how the occupancy are going to affect that building, and the building, how that building actually affects itself in regards to wet trades following on, and so on and so forth from the initial construction method. Transportation, as we've mentioned in regards to sustainability, there's a lot more off-site modular construction going on in this day and age. So if you've got panels that are being made off-site and they're being transported to site, make sure that the materials that you're utilizing are going to stay where they are. Especially in regards to membranes, because there's a lot of partially fixed or tape membranes out there, which basically end up as sails and going down the motorway. So make sure they're tried and tested. We've had products that has been made, modular products that have been made over in Morocco and then shipped in past the Bay of Biscay, which if you've ever sailed across the Bay of Biscay, you know it's not a very pleasant place to be in windy conditions. And the product has come in absolutely bonded to the system, no worries at all, and fully exposed. They did the same with the partially fixed, and it was nowhere to be seen. So trial and tested, just get as much test data about the products that you can do. So in regards to through-wall systems, looking at the vapor drive, looking at the U-value calculation, which everybody was always about the U-value calculation. I need a U-value calculation. Yes, you do need a U-value calculation, but you also need to take into consideration the condensation. You need to consideration the vapor drive. Glaser method only caters for outward drying, not inward and outward. It doesn't take into consideration driven rain, wind speed, actual temperatures. Everything's average, means, and everything else. With this hydrothermal assessment, it takes into factual data all year round, 5 years previously to when the project's being constructed. The weather is very tumultuous at this moment in time, and this system takes that into consideration. It does make a prediction for the next 5, 10, 15, 20, 25, 30 years, however long you or your client wants to look at in the future, it can make the predictions based on factual previous 5 years weather data. Okay. Ultimately, you want that dew point in the cavity on the face of the insulation as opposed to within the system. So looking at vapor control layers. So vapor control layers, formerly known as vapor barriers, which has obviously changed to vapor control layers / air and vapor control layers. Under BS 5250, they are classified as a low permeability material of a vapor resistance of 500 meganewton seconds per gram or 100 SD in the new vapor diffusion drive. So the meganewton seconds per gram was part of the previous BS 5250. They now have moved to the European standard, which is vapor diffusion, which is classified as SD, which is done by the volumetric order of meters. So it's 100 meters. Basically, if you get a meganewton seconds per gram membrane, times that amount by 0.2, and that will give you the SD value, okay? If you've got any questions, any problems, please obviously speak to us and we can aid and abet you from there. Ultimately, vapor control layers are meant to be vapor and airtight. Fine. When they get to site, they're in a nice roll, they're all packaged up, no problem at all. From a low-rise perspective, I can completely appreciate that that line can be used as a vapor and airtight line. From a high-rise perspective, with the volume of contractors you've got in there, with the follow-on trades, the amount of penetrations going through that vapor control layer are inordinate. And the belief that they are going to be all sealed up nicely before you do your airtightness test is unrealistic. So the reliance on that vapor control layer for an airtightness line, for a vapor tightness line, is not manageable. So what we've developed is a self-adhered primary air barrier. So this goes on the outside, so on the sheathing board. Not to go onto fire regulations too much, but under BSE N 13501, this is tested onto calcium silicate and cement particle boards, which are the only two boards that you can test under BSE N 13501 regarding this product. It achieves a Class B S1D0, which exceeds regulation. Okay, it's fully self-adhered, so there's no extra tapes, there's no partial fixing, there's no mechanical fixing. It goes on, and this creates your airtightness but vapor-permeable line. So you're not impeding that ingress or egress of vapor from the building. So you're enabling that concrete structure to dry out externally as well as internally. The other side, by utilizing this external air tightness line, utilizing the hydrothermal assessment, what we can actually do is show that the internal vapor control layer may not even be required. Okay? Wait for the gasps and the shocks. It's a development that's been made. Okay? It's not something we make vapor control layers, so we want to sell vapor control layers, but the fact is we're optimizing that build-up. We're making it more sustainable by removing product which isn't necessarily required. No labor in regards to that area. There's no worries about repairing that area because it's not even there. Okay, because you've got your air tightness line on the outside. The internal inhabitants can't get to that product. The electricians, plumbers, they can't get to that product, okay, because it's on the outside of the building. Any remedial works that need to go onto it can be done very, very easily from the outside during construction. If it's work that carries on after the project is complete, you get more ad hoc work going on internally, so anybody can do it, so to speak, whereas if they're working on a facade system, there's more planned works that are going. They know what's behind that facade panel. They know what's going on, so they know how to address that material afterwards. Plus, it's bright red, so it shines out quite well. Sorry, should have done that earlier. Weather protection performances-wise, so yes, we've got the fire aspect at Class BS1D0. We have to conform to BS5250 in regards to breather membranes and also in regards to the air tightness. So simplified detail and rapid installation. And ultimately, taking all those penetrations into consideration, just wrapping a box is a lot easier than wrapping a football. So you put the box around the ball and you wrap the box, not the ball. So it's a lot easier to do it from the outside. If the property is going to be going up for a longer period of time, obviously UV tolerance on the previous membrane was 3 months. This is a wrap-tight UV membrane which can be left open to the elements for 9 months or longer, purely due to the fact that it's been through that testing. If you look at the new CAD details that have been produced in BS5250, I think there's 14 different through-wall build-ups which stipulate, one, the vapor control layer is optional if you carry out the hydrothermal assessment to stipulate that you can negate that VCL in that build-up, but the UV membrane has to achieve 5,000 hours minimum. Okay. Ultimately, it will be covered up at some point. If you decide to go down and enhance on building regulations and you want to utilize an A2S1D0 membrane, again, based on BS 13501 on a calcium silica or cement particle board, there is the ProBreathe A2, which again is it's not a fully bonded one, it's a partially fixed, because obviously with the enhanced fire, you negate that ability to have the adhesive on the back. But that is a fixed. And this is the other thing, when you're specifying the materials, make sure that you get the installed test data, not just the test data of the material on its own, okay? Because it's a get-out-of-jail-free card for the manufacturer not to supply you with that information. So make sure it's an installed fire certificate, not just the membrane on its own. Sorry about the transitions. What we're finding now as well is there's a secondary air barrier. So if you're working alongside passive house at all, they now look at, in order to negate wind washing or thermal bypass, they now request that you have a secondary membrane on the outside of the insulation, which basically protects the cooling down of that insulation through the cavity ventilation. and indeed, obviously, because it's A2, it minimises fire spread up the cavity. Harmonised CE marking as standard. And what, thankfully, and there's one thing in regards to fire that wasn't alluded to, the standard of Class BS 1D0. I hate to use the word ambiguous, but it is. Okay, it's a very broad spectrum. And as you'll see from this video, both these membranes that you can see here, I can say which one the one is on the left. This is fire shield. Okay, the one on the right, I can't tell you what it is, but they are both classified as Class BS 1D0 membranes, and that's free hanging. So you can see the time frame, and that's real time frame, that's not. So why are those membranes both classified as the same? Because they both have a reaction to the flame. The one on the left intumesces, so it foams up. Yeah, it doesn't actually dissipate, spread the flame. The product on the right recoils from the flame, disappears, and reveals that substrate underneath. Ultimately, if that substrate is a non-combustible substrate, so be it. Maybe there's gaps in that board, and the fire can get in that way. But ultimately, the product on the left is protecting the underlying substrate, even a timber one. And yes, it is timber on the left as well. It's not a non-combustible board on the left. So don't always take the classification as being gospel. Find further information. Look more into the products that you're looking at. Gone are the days of, because of the unfortunate events, gone are the days of throwaway specifications regarding breather membranes. Gone are the days of throwaway specifications of vapor control layers. There is no stipulation on the fire performance of vapor control layers at this moment in time. But inherently, across the water, Class B S3D0 is the minimum standard that insurers will allow to be produced into their property. And just as a little crib sheet, those are products, obviously you saw the fire shield in the video, and the other products are available. But ultimately, please speak to us, please call us. We're here until 6 o'clock. So any discussions you want to have, anything you want to look at, any projects you want to have a go with, please let us know. Ultimately, we've got plenty of projects in Ireland generically, but 3 to mention in the local vicinity is Cherrywood, which is with John Sisk, the National Children's Hospital in Dublin, and the Dean Hotel, which I think everybody's been a part of today as well, over in Cork. All right, so thank you very much, and speak to you soon.
Thank you, James. And with that, we conclude the presentational part of today, and we go on to our panel discussion. The panel discussion is on the topic of facade process management. Now, I've been working in this business for about 35 years, and it seems to me everybody believes that they are an expert, but I don't know that any of us is really an expert. And I think we need the collective knowledge of everybody to deliver this. But I'll be interested to hear the views of my panelists, so I'd like to invite them to join me on stage, starting with Bobby Conroy from BDP Architects. Hector Cronje from Urban Agency. Paul Green from Green Façades. Piers Fahey from O'Mahony Pike. Pat Cohen from C&W O'Brien Architects. And last but not least, Ronnie Mills from Alucraft. Welcome. If I could have a welcome to our panelists. Is everybody mic'd up? And and mic's working, hopefully. Okay, so welcome everybody. It's great to have you here. And I'd like to just start by inviting you to just do a little introduction of yourself and give us an overview on how you see the topic that we're discussing today.
Sure, yeah. I'm Bobby Conroy. I'm an architect director at BDP. I've been working the last 7.5 years on the Children's Hospital project, so I lead the team in our Dublin studio on that project. And I have a master's in sustainable architecture from the Centre for Alternative Technology in Wales. So I'm very interested in sustainable aspects of construction. I'm on the steering group of Construction Declares Ireland. So very involved in lobbying for more sustainable measures in construction. I mean, I fully endorse and engage with your statement that it's very much a collaborative endeavour trying to line up all the various elements of facade delivery. So I'm interested in this discussion and how it develops.
Thank you.
Hi, I'm Hector Crony. I'm from Urban Agency. I'm Associate Director there. Originally from South Africa, but I've been living and working in Ireland for the last 20 years, almost 22 years. And I'm coming from the technical side and the delivery side, so taking the designs that comes down from the architects and then going through the planning process and then going through the tender process, trying to deliver as closely as possible to the wonderful CGIs that we get these days to show the buildings and to make the buildings perform in accordance with the design and in accordance with what the client has specified, and overall just trying to achieve good building design.
Thank you. Paul.
Hi, good afternoon, everyone. My name is Paul Green. I'm Director in Green Facade Consulting. I've been working as a facade consultant for this past 7 years. Prior to that, I've had a bit of a varied background, ranging from subcontractor to systems design and systems supply. I have particular interest in facade process management, and I suppose when Steve sent through the topic, it was a little bit of a head scratching as to exactly what we were going to get into, but it seems to be a very common sense topic and something that we're all sort of engaged in. We had a lot of technical discussions today about some lovely projects, but I think we're getting into the nitty-gritty of how we actually go about delivering those now. So looking forward to the discussion.
Thank you. Pat.
I'm Pat Carolan, Head of MMC Delivery at C&W O'Brien Architects, MMC being Modern Methods of Construction. I have a background in sustainability. I'm BREEAM and AP and Pacifaz designer. I have a master's in lean design and construction, focusing on MMC delivery. So I guess I'm kind of trying to get out of this in terms of focusing in on lean sustainability and improving the productivity. You know, I'm also on various bodies across the industry, the new construction sector group and the construction 4.0 group set up by the Irish government. And also in terms of design, I'm on the RAI Council, and also a new group set up in the last number of weeks to look at DFMA. So it's understanding the design philosophy in order to adopt MMC at construction stage. So essentially utilising lean design construction in a collaborative way to achieve better outcomes for deliverables.
Thank you. Ronnie.
Hi, good afternoon. Ronnie Mills, I'm the Managing Director of Alucraft, facade specialist contractor. I'm not sure what it means, but I'm probably the only facade contractor that has been allowed on stage today, so hopefully that'll not go wrong. But I've been involved in facades for all of my adult life, all my career, 30 years, 32 or 3 years. From a design and engineering point of view for most of my career, and then in the last 7 or 8 years more in the general management. Obviously, facade process management is a big thing. It's what we probably don't look at it as this, but it's what we do every day. From that, taking that design and performance that my colleagues here from the architectural and the facade consultancy industry provide us with, then as a contractor we have to take that and convert that into something that we can build and something that is going to meet the aesthetic requirements and perform for the life scale. So very interested in hearing what everyone has to say and bringing the stage here this evening, what the point of view of a facade contractor.
Thank you. Very important point as well. Thank you. And last but not least, Piers.
Hi, Piers Fahy, O'Mahony Pike Architects. I'm an architectural technologist and associate at O'Mahony Pike. As many of you know, we do mainly residential, a bit of everything, but mainly residential. And the challenges for us is to deliver the building, and in today's context, the facade, the bit that we all see of the building, in an ever-increasing regulatory background and with an ever-decreasing budget. And to make it economical, and when value engineering comes into play, that it is actually value we're getting. And it's really a partnership with all the stakeholders that are represented here to bring about that, and to work with the likes of Alucraft and any of those main contractors, etc., to make sure that we get something that does perform and deliver both aesthetically as well as performance-wise.
Thank you. So if we start by just thinking about what actually makes a successful facade, a successful end product, it's not just about delivering it on budget. It's actually about, does it meet the expectations? We heard earlier about the performance gap that seems to be happening a lot. The aspiration of the people who are, if you like, going to use that building, going to live next to that building. Are we meeting the community's expectations? Are we meeting our energy expectations? And are we meeting budget and program and quality expectations? I'm going to open the floor for questions later, but if any of you at any time has a burning question as we go through the discussion, please feel free to raise your hand and somebody will come with a microphone, but you will also have a chance at the end to ask questions. I've got a few questions that I'm going to ask myself to the panel. So if we start about the architectural and community aspiration, because buildings are landmarks, people love buildings, and it's not just, they don't fall in love with the performance of the building, they fall in love with how the building looks and what it means to them. So how do we create more, if you like, buildings that meet that aspiration, but also meet the performance aspiration and the budget aspiration, starting with the aesthetical side of things? How do we make sure that the building meets that brief, the community brief, the client brief for aesthetic and functional performance? And I'll start with the architects on the panel, if I may, please.
Sure. Well, I suppose we're getting into the fundamentals of design there, and the first kind of concept ideas, and a lot of it is down to the brief and what's the nature of it. Is it a civic building? Is it a commercial building? Is it residential? What's the scale of the surrounding context? So you've all of that kind of engagement, first of all, and potentially, as you said, community engagement with the owner stakeholders, but also with the wider community stakeholders. After that, when you're going to planning, you want to make sure that the vision you're presenting in planning and in your CGIs, which may be very refined and smooth, is captured in your design intent information that you're going to ultimately go out to tender with. And I suppose, because with each of these questions, you probably end up jumping forward and looping back in order to try and give an overview of the thing. But I suppose in protecting that, again, depending on your procurement model and whether it's a design intent you're offering for development by the specialist, ultimately, it's, you know, how much effort, targeted effort you put in at that early stage to communicate and safeguard that design vision that you've got, and also how much of that you can, I suppose, efficiently give to your cost consultant to ensure that they are capturing that specific, you know, refinement that you're looking for. And then obviously that's from the aesthetic point of view, and maybe we'll just kind of stick with that for the moment. So I think the other aspect is probably in your specification, you're not just specifying performance, you want to very carefully specify the whole approvals process, the mock-ups and everything like that. Ensure that you've written it clearly enough that your intent is clear to everybody, because I think that's where problems arise, where it's not, you know, set out clearly enough, and there's opportunity to misinterpret what the intent was. So the clearer you can set out that process that's targeted to deliver your original vision, the more likely you'll have everybody satisfied with the outcome.
Okay. Before I invite a second contribution, I'll just add to that. who are the right players to be involved in that stage of the process? Maybe, Paul, if I can get a comment from you on that as a facade consultant.
I think at that early stage, particularly pre-planning, you're sometimes a little bit restricted as to who you can go out to, maybe in terms of the budget for the overall scheme. There's a more limited design team at that stage, but it's absolutely critical to get advice from as many of the sort of integrated players as possible. From an aesthetic point of view, I think you'll hear this phrase mentioned quite a lot today. Early involvement by interested stakeholders is really vital, and that goes for members of the design team, but more importantly, possibly the likes of Ronnie and the subcontractor. They can bring a huge amount to the table if they're given the opportunity at an early stage. From an aesthetic point of view, that's always a little bit subjective, but Bobby mentioned the specification document there as a part of the sort of stepping stone towards delivering a facade. Tender documentation and specification, in my mind, is probably one of the most vital aspects of it. And that specification document, contains everything aside from the drawings that is required contractually, just to make sure that what is going to be delivered is ultimately what's thought up of at an early stage.
Okay. If I can come to you, Piers, there are players out there, whether they are people like us, Schuko, or people like Alucraft, who are specialist contractors, and many other, if you like, systems and material suppliers who are open and willing to engage at early stage, even pre-planning. A lot of the work we do is at pre-planning stage. How open is, say, the design end of the business, the architects, the consultants, the client, who are at the front end of the project? How open are they to that contribution? Are they willing to engage?
I think so, and generally speaking, we will go to the suppliers and manufacturers to give us their input on what can and can't be done, or how we go about delivering that intent at the end of the day. It's sometimes easier to approach the suppliers and manufacturers rather than the contractors, because there will be elements of it that, obviously the contractor will have to put a bit of time into something that might necessarily give a job at the end of it, and you don't want to lead people down that path. But it is critical. If we could, we definitely would. And it definitely brings about a more realistic approach to the design at that stage, because you're looking at what can literally be done rather than some hypothetical thing that you're hoping can be achieved.
Okay. Pat, please, do you think that architects and specifiers understand what they can get from industry?
Absolutely. I think if you start teasing out the aims, what is the goal of the building? What are you trying to achieve? Particularly, there's a common thread through the presentations today: sustainability, embodied energy. So if we begin to tease those out at a very early stage, and this is where, I suppose within the RAI, we're now looking at design for manufacture and assembly. So essentially front-loading all of the specialists and all of design, and asking ourselves questions: what do we need to know? So a very simple example of that would be, understanding the aesthetic finish. Are we going with something like anodizing? Are we going with that powder finish, which is so earlier? So if we drill down into the embodied energy of that, anodizing is very energy intensive as opposed to perhaps powder. So, how do we balance that out in terms of aesthetic finish? And then equally feeding that back into the cost plan, what does it actually mean? So for me, actually, it's more about collaboration and engaging with suppliers, manufacturers, specialist contractors. Are we talking about PCSA, pre-construction service agreements at early stage design, so that we can really get into the nuts and bolts of understanding facade construction, understanding how we're going to tease it out and deliver it in line with all the different constraints.
Yeah. I mean, you mentioned PCSA. It's fair to say it's become a more common way to engage, to have a more professional relationship with, especially with contractors. People like us will provide you with the technical support that you need without necessarily having a formal engagement. But as you said, a contractor needs to feel that they have a level of commitment, and hence the PCSA. How common is it? I mean, if we're now talking about our project, we set the vision for the project, we set the key parameters, we're heading towards planning, maybe we're submitted planning and we're thinking, how common is it in Ireland to engage on PCSA? Ronnie, do you find that?
Yeah, maybe just go back a little step, Stephen, to some of the comments that was made there. There probably is a bit of a reluctance sometimes to getting a contractor involved too early, because there is that concept or that thought that perhaps, you know, that contractor is not going to bring the right value to the table, or is not going to, you know, engage correct. You know, it's narrowing the options, if you like, for the procurement process that's obviously going to follow that design. Yeah. The design process, but I think the evidence is there to show that when you do engage a specialist subcontractor early in that process, there's unending amount of value that contractor can bring to the, you know, in terms of the taking that vision and taking that concept, taking the specification and the performance requirements, and then coming up with a product and a solution that will meet the budget. And looking at the logistics and the methodology and the buildability of all of that. So I think there's lots of good case studies showing that getting that contractor involvement early really can bring value to the whole process. The concept of PCSAs here is very prevalent, I find, here in the market in Dublin, and there is a lot of it happening, and there is a lot of value, as I say, being added, I feel, to the projects through that route. So it is something that is very prevalent in this market, and it is working well. Certainly, it's a process that the specialist contractors all engage with and see as a really good route to market.
Thank you for that. Now, you talked a little bit, you mentioned the word cost, and that's always a key step, because every project has a budget and someone has to set that budget. So I go back to the designers. Who do you feel is the correct member of the team? I know there's QSs out there, probably some QSs out there. Is a project QS on their own able to set an accurate budget? What input do you think is needed from the rest of you, or from people like us and Ronnie, to help that process?
I think, given the complexity of facades and how much they've changed in the last sort of 10 or 15 years, it's extremely difficult for QSs to keep on top of, you know, what something's going to cost, and that's aside from the issues that we'll probably get on to in terms of COVID and Ukraine and the price influxes and the price increases that we're seeing at the moment. I think the PCSA methodology used to be seen unfairly as a little bit of a luxury, as something that you couldn't really be afforded within the project. But if you look at it the opposite way around, it is the one method of gaining a little bit of cost surety, particularly for complex facades. I find that it's something that should be almost a given. We obviously can get a lot of technical input from facade subcontractors, but getting that early stage budget at a very detailed level is something that doesn't normally happen on a typical facade. We'll obviously go out to QSs and we'll go out to individual subcontractors to get assistance with budgets, but it's limited as to how much we can lean on a subcontractor for pricing, which can sometimes be very involved and take 2-3 weeks worth of work for a team of people. So as a methodology, I think you're gaining a lot of cost surety by that, and I think it's just a mindset of paying for a PCSA. Do you get that money back? But I think you do, and particularly if it's well set up, if the PCSA project is well maintained and well run to the end, you've got a set of documentation at the end of that stage that can be used to go either back out to tender or to progress on to the next stage of design.
Hector,
can
you add to that?
I agree with what he's saying. It depends on each project. I think in each project it's got its own unique requirements, whether it's a green site, whether it's a infill site, whether it's a city centre site. And the time period that it's going to take to get from first we do a concept design so that the client can see whether it's a viable project for them to take on, to engaging with some of the consultants, like the facade consultant. If you are dealing with a city centre site that's got a defined boundary, you very quickly want to establish, well, if we want to have a certain look, what's the build-up that I'm looking at? If I'm the difference between going for a precast concrete, to a GRC, to stone, and to understand what that's going to do because you've got a defined boundary. So it very quickly defines your footprint. But then you've got the gap between concept to pre-planning, then to planning, and then to tender stage. So depending on how much cost input you get all along, you could be from 1 year to another year, could have a huge gap for various different reasons in the costing. So I always think costings, a client tend to hear cost, and that's what they're attached to. And then during the process, when their expectations change, like, oh, we want to go now with passive house design, so we want to go with a higher performance, they sometimes don't want to accept that the budget's going to increase. So, I find it difficult enough to really establish a strong budget at the start. And more detailed information will give you a better understanding. But until you start developing the project a bit more and you understand how much the facade needs to do, I think you're always going to have a bit of a gap. And it's just how close you can get that gap.
But what stage do you reach that development? When do you see it?
Well, typically in Ireland, you only get to that once you get to tender stage. Because you can get from construction, you can go from concept design to detail design to pre-planning, and you go to planning. But in that planning, you don't have to show much. You don't have to resolve all the consequences of what you have decided to do. And it's once you get the knock over, so you've gone through your planning, you've gotten your conditions, you've complied to that, then you get into fire rating, your DACs, some complications there, and then you get into final design. So I think early on, the QS would maybe like to give a very optimistic budget, so it looks attractive, but it's also a double-edged sword.
Yeah. What about the idea of doing what you might call market studies? We've seen that on some projects where they take, if you like, a condensed set of documents, some elevations, some plans, some outline specifications, and invite budgets on an informal basis from 3 or 4 specialists just to inform the cost plan. Is that?
Yeah, that's happening, and it is useful, and it kind of gives you a picture at that time of, and it might be down to a curtain walling element, a rain screen, precast cladding, whatever it might be, to market test that and see where the market is at the moment and how that stacks up against our other options that we might be looking at. And it can, without going down the full PCSA route, it gives you that kind of snapshot that helps make those decisions, which might be a stepping stone to the PCSA.
But does that also help you as a design team to kind of cement your ideas? If you're being asked by the client to put a package for market testing, you're almost forced to think about what facade systems do I want, what are the key types on the elevations, what are the key performance requirements. That's kind of it's almost like a pre-tender wake-up call to say...
Some would probably argue we should be doing that anyway. Get on with it. But yeah, I mean, it is useful, but you might be looking at a number of different options. So it mightn't be just fixing on a curtain wall. You might actually be looking at different cladding systems.
I mean, invariably, you will get that anyway. But that leads to my next question is, when you've done that, how do you select which companies you're going to go to market test with? How do you select a level playing field? And who sets the quality standard? Because we all know that contractors, I mean, we've got a very reputable, high-quality contractor sitting here, but not everybody is like that. How do you select the level playing field?
Yeah, I think it starts off with having a discussion with your facade consultant who's dealing with this on a daily basis. This is their bread and butter, so they are involved in various projects, so they get to know quite a good few of the subcontractors out there, whether it's manufacturer, supply and install, or whether it's supply only. So they would have a good understanding. So once you've kind of honing in on your facade type, they can then very quickly tell you, well, I think this job might be too small for Allucraft, but there's number A, B, or C that's really falling within their kind of butter zone of kind of size of project. And when you start teasing out, would these people, these subcontractors, be, the right kind of people? Will they be able to produce or provide the product that you are going to be driving for? And then we've, in the past, and a lot of the projects have gone out to tender, pre-tender before the main contract has been appointed, to the selected or agreed group of subcontractors, and then in that process, I think later on we'll discuss it. Then you go through that process of reviewing the tenderers, and then eventually you select one of which you will eventually novate to main contractor. But that's one way of going about it.
Yeah, I mean, you mentioned main contractors. How do you safeguard that? You do get projects where the client says, "I just want to give it to a D&B." How do you then safeguard that you're not getting left at the mercy of a main contractor and their supply chain?
I think it's the same as, and it's all down to the procurement model, because again, like in public sector projects here, you can't necessarily specify who you want to deliver it. They'll probably end up being a domestic to the main contractor. So in both cases, you're reliant on your specification being secure enough and having enough checkpoints and benchmarks.
Does that mean you need more detailed documentation, more precise documentation
not
and specifications?
Yeah, well, in your specification for sure, and in your sort of, I suppose, as I said earlier, in your detail that's targeted on the stuff that counts for you. So you're going out on scoping, on I suppose typical details of the important, design intent. And if you look at REBA's, they have a design management book which has drawings of how to design as design intent versus full architecture design, and one is stick and one is massively detailed, and I suppose you have to make a judgment where along that line you want to go in order to safeguard your quality, but also not step beyond and reduce the opportunities for the specialist then to bring something to it. So I think it's in your specification, and it's in the process that you prescribe for ensuring you've got the quality and giving you an opportunity to reject stuff that doesn't meet that quality.
So I think what you're describing is a process where you have to almost fine-tune the level of documentation, the level of specification you provide, depending on the ultimate procurement process.
For sure.
If the client is open and bringing in specialists on PCSA, your job is a little bit easier. If you're having to cover every eventuality, but a main contractor is just going to go to open market, and who knows who could be tendering the job.
Well, I think tagging on to your specification, the more tailored your specification is to where you want to get to.
Yeah.
So the more prescribed your performance specification is, you're going to funnel the market out there in any case to maybe 2 products which you would deem acceptable from what you would like to see on the building, by just tailoring and really making your product specification, your performance specification very tailored towards one of those 2 products. So when the tenderers come back, you should, if all is fair, then only get one of the 2 options to return as the selected solution by the main contractor. If you've narrowed the market as much as possible with the higher performance and specifications.
I want to pick up on the point that Archie highlighted, this performance gap between aspiration and end result. How do we plug that gap?
Maybe make a comment on that, Stephen. Just one of the things as a facade contractor we're always concerned about is we spend like thousands investing in putting together tenders, investing in going through the whole process, going through the documents, making sure we're compliant, making sure we put the best possible solution on the table, the bid. And it's really just then, while we can have quite a narrowed specification, etc., but will the recipients of that document, whoever that might be, will they really understand the value that someone might be actually bringing to the project? And it's how that, that is a concern as a contractor, how that value, how we get the opportunity then to maybe present that value and present the ability to come along and sort of explain why, okay, our price mightn't necessarily be the lowest, but our value might still be the best value in terms of the overall project. So I think, the wider and the more open that procurement process is, then, there's obviously more risk in it. So therefore, we as contractors start to question, is the amount of time and effort, and how is this going to be adjudicated? How is it going to be reviewed? And getting the opportunity for us to present that value and to really explain what we're bringing is very important, to make sure that the aspiration of the project is met.
And obviously the cost and quality criteria for assessment is going to set that tone from the very outset.
Yes.
You know,
Yeah.
if that's
Absolutely.
not balanced rightly, well,
Yeah.
then you're going to get what you...
It's that opportunity outside just looking at the bottom line. Exactly. Actually look at the full picture and have the discussion. Yeah.
But I think what I've seen recently is that more experienced clients are getting much more in tuned into this. I recently had a meeting where a client was, okay, right, we've got a design hold on this project for 15 years. So it's bring anything to us. If you say, yeah, it might be X amount percentage more expensive than option A, but the design life of it exceeds that period, you know, we would spend that extra money because it means once we spend the money up front, we don't have to go back within the 15 years whilst we are still liable for this building to go and repair, do maintenance, replace, you know. So I think the market is getting more intelligent itself. So definitely the more higher end developers are looking into that. They're not just the bottom line, okay, there's a difference of X amount between this one, so we're going with this one because it is cheaper. You know, so, and, you know, performances and the expectation out there of how buildings are going to perform is driving that review as well. So,
I'm going to stop asking questions and invite questions from the audience if they're still awake. Are you still awake? Yeah, somebody's awake. Can we have a microphone at the front here, please?
Hi, yeah, Rory Murphy from Ready Architecture. No, it's very interesting, everything there, but just to tie it all together, the problem is investment of time and then the appropriate time for that investment of time and the pressure. And our experience has been, and mine over many years, has been that the design team members aren't all paid equally at the right time for their investment in the project. And it's just the nature of the process. There are relationships between designers and, say, preferred subcontractors, and you're into an element of beneficial contribution. But I wrote down a number of words just as buzzwords because I don't have the answer. I just know the problem is more complex than this discussion. So the cost consultant, first of all, they're not paid to do a measure at planning stage. They're just given paid to do oversight. They're defining a budget, but they're not actually being paid to put the same effort into the design as the designers. And they're coming up with a number based on their market research and what they think it is. So that's a factor. Then the project team isn't allowed to invite a market member in because it closes the market to the project. So that becomes a problem. So if they are in, they're a cloak, they're not open. You can't say that you're just talking to Alucraft or Alufactory or Arcal or any of them, you know. And so then the funding model is there. The IRR is everything. And they've made a model, and the model is there at the beginning, and other factors kick in, other factors, and then the planning process takes a long time, and longer in this country. So your initial budget could be well off the plate by the time you get to the place where you're actually lodging it for planning. We've had this a lot. You're 8 months in, you're a VE before you even get to the stage where you want to define the facade, and then the market factors. The market has shifted by the time you started the job to when you're actually lodging the planning, and it's shifted again by the time you finish tender and you're going to build it. It's very difficult. And then you've got what you need is the delta of the options. And so therefore you're looking for the client to invest in two designs for the building. You know, the one which is the shard that we all aspire to, and the one which is the minimum that actually you can build. And somewhere in between is where the building will live. But we never find that delta because we don't get at that. And then the building profile is the factor. What's the market? You get certain developers and they pitch at the highest point and they're looking for that market, and you get others who are looking for the background building. And that isn't, and we're not honest about that at the beginning. And then the end user and the tenant, it goes back to the rent, it's back to the IRR. So a lot of variables, but everything that's been said here is wholly great and all truthful, but it's judgment and time and decision making and having the right person. And it's different for every single job. I mean, it's quite frightening. Sorry, that's a long thing, but I was just listening for ages going, Jesus, you know. Thank you.
Can somebody respond,
If
please?
I could pick up on that point, I suppose to pitch it a different way, do we need to look at a different cost model? Do we need to reevaluate our concept of, or reassess our value of concept, or I would roll backwards, value essentially? You know, are the traditional means of design and construction sufficient going forward in an area where supply chain disruption is rife? You know, like as you mentioned, Rory, you know, large scale projects typically could take 5 years up to construction stage from initial design. The entire supply chain material availability is knocked on its head. So what does that actually do to your cost model? You know, when we talk about the design teams, are we moving into an era of more integrated delivery where different players and different stakeholders have different roles at different times in the project? You know,
I think that's correct. I mean, I think the issue is this, that like 30% of the building is probably the facade, maybe sometimes 25 needs that energy. The M&E, another 30%, yeah, on the building, and ultimately then you've got the structure and say the fit out. And I think the focus has to be early. I think everything you're saying is correct, but that needs to be recognized across the board. But then it's incremental investment of that time, because you can't design the building 5 times. We don't get paid to do that. You know, that I think so. I think you're right, Pat. You know.
Just one comment on that. I think that as BIM approaches more maturity, and we had Neil talking earlier about using dynamo scripting to link models to the QS's information, and I'm sure that can run more or less smoothly. But I think, you know, those kind of exercises as well, that your colleague from Juco showed the optimization of the spandrel spacings. I think the more you can adjust that stuff with less effort, the better position you're going to get into.
Also, it's to do with appointments on projects, and that is changing as well. The traditional role where you bring an architect and that's their scope of service all through the project, that's changing. We're seeing that already with consultants. It's much more task-based. What are the tasks that are needed for this job? What we see, you know, some of these form finding and geometry optimization, that's not needed on every job. It's needed on some jobs.
Absolutely.
So you've got to bring the right expertise at the right time.
That's it. That's the
judgment. And it's not necessarily sitting within the same design team all the time. You've got to be prepared to bring, if you like, specialists.
Yeah, but I suppose the key for me, I'm going through a project at the moment, a significant one, right? And it's about to be considered, you know, it has to be built maybe a different way, completely because of what's happening in the market. And ultimately, what was needed, I think, on the building from the beginning is that there were 2 or 3 cost plans done at the beginning, not one. Yeah, and but therefore, because again, the cost advice each time was they look at the drawing, and before you've even finished it, you say you can't afford that. It's got to be punched openings in brick. Don't draw it. Yeah, and the issue here is trying to get ahead of that problem. Yeah, because it's just to understand from this forum, which is really useful today, that you must understand the delta. Is it a €20 bottle of wine or a €70 bottle of wine? Yeah, you've got to understand that, and then stay connected to that.
What you need to avoid is paying for a €70 bottle of wine and getting a €20 bottle of wine.
There we have it. It's all down to wine.
And that's really, there's nothing wrong with a €20 bottle of wine. If that's all you can afford, then it's a good bottle of wine.
Absolutely.
It's quite often knowing that you set aspiration for a 70 and get a 20 or get a 30.
Well, the market wants to pretend it's selling you a 70 when it's actually selling you a 20.
It's about getting the building you paid for to the quality you paid for. That's, I think, what we're trying to discuss here. Because some projects will be simple, as you say, some brickwork and punched windows and you're done. It's simple. But that's not every project that's out there. And more, the aspiration is to build something to a higher quality.
Well, as Mies van der Rohe said, an architect must understand the materials of their time. Yeah. And that's the big education.
If I can pass the microphone over there, please. There's a question there.
Stephen, what I'm starting to see is a shift in procurement strategy, and Ronnie probably will know where I'm coming from here. But in our business, we're looking for 80% cost certainty pre-planning, which means we need better stage 2 design. So when we're appointing consultancy and our design team, we're willing to pay for a better stage 2. So it's not paying more money; it's just shifting the fee forward, if that makes sense.
Yeah.
But I have a question. I'm not convinced about the value of a PCSA.
Right.
And what does, and Ronnie in particular, sorry to put you on the spot, Ronnie, but what do people think about a shift towards PSA, where it's a design competition with no guarantee of construction?
Okay, so I suppose, John, the first thing I would say to that is, as a specialist subcontractor, we're willing and we want to get involved with the projects at an early stage, but behind that all, we still have a business, and essentially that's a factory that we're running, and that factory, we have to keep that factory busy. We have to keep it full, producing facade panels, in our case, every week. So we're doing, so in terms of getting that early involvement and starting those early discussions, we are doing it, let's be honest, we are doing it with a selfish reason, in that, you know, we're selecting the projects, we're selecting the clients that we want to work with as well, we're selecting the projects that we want to work in, but we're doing it because we've got a business to run and we've got a factory to keep busy. So if we were in the business of providing design service only, that wouldn't, that PCA process you're talking about would work for us, but we're not. We're in the business of taking that design, developing it, de-risking it, providing value, and ultimately we want to build it. Because if we do not have the opportunity to build it, if we had to go to some sort of competition at that stage, then we would end up with a business model that wouldn't work. So if I appreciate there still needs to be an element of competitiveness in the process somewhere. So certainly the projects I've been involved in that have been the most successful is where we have that competitive stage at the beginning, before we would enter into a PCSA. Let's get some documents out, let's get the design intent, let's get a detailed specification, and let's develop that, offer that out to the market, invite some competition into the process, get to a position then where you're happy to move forward with one business, one specialist contractor, and that contractor is then set a clear set of deliverables that we're going to do through the PCSA period. But ultimately, I think the most important thing I have to say to that is that we want to then build that facade because we have a factory and we have a workforce that we need to keep gainfully employed. So that sort of, I hope that sort of answers the question, but that's my thoughts on it.
It does, Ronnie, and I kind of predicted that's what you were going to say. But I think that the downside to PCSA is the lack of competitive tension, and it's really predicated on the quality of the design that you go out for that first stage on. Yeah. And then what you're entering into at the start of the PCSA. So that's what I'm seeing is the poorer the design at stage 2, probably the worse you're going to have of the deliverables or the output for the PCSA. Yeah. So, but it's an interesting conversation.
Yeah. I'll just add one comment to that, John, if I may. I mean, companies like us, like Schuko, we have a team of about 130 engineers in-house. Admittedly, they are all engaged with live projects, so we have to support companies like Alucraft on live projects, but we also have a specialist team that's there to provide essentially a pre-construction service, a bit like you're describing, where we can do it with less vulnerability because we don't have a factory like Ronnie has. We don't have to produce 100 panels a week and ship them to site. We are providing mostly know-how and systems for someone to use at a later stage. So we're open to that type of engagement.
Thanks, Stephen. Yeah.
I think we're severely over time, so I'm going to try and close it, but I'd like to just give all our panelists 30 seconds just to sum up or give us a few words if they want to. If you don't want to say anything, that's also fine.
Yeah, I mean, I think it's all about collaboration, and I think the more you can front load that collaboration, like that graph that we saw earlier, where you have more effective outcome from getting your decisions and putting your effort in. Even down, I mean, you have to bring in sustainability, and there's a lot of talk about embodied carbon. We know that a lot of the areas you can gain on embodied carbon are like, setting your structural grid to an optimum level, how that ties in with the centering of your aluminium mullions and all of that. It all ties together. The more you have a sort of an integrated, informed position at the outset, and the more everyone is educated on all the steps going through the way and can set those out, the smoother ride that you'll get. Yeah, I suppose.
Thank you.
I think picking up on the two comments there, the planning process here has got a lot to answer for the time period that it takes. And I mean, everybody remembers how long it took for Apple to go through the whole process, and eventually by the time they got through the process and got refusal, they had already built another one. The way they used to do in South Africa, and similar to the UK building control, you actually have to achieve compliance with building regulations at planning stage, which means you have to front load the design, which means you'll have to work through the building far more than you do here in Ireland at the moment. And it used to be a far more open process in terms of planning in South Africa, where you can go and meet the different departments as you are going through your planning application. Whereas here, it's very much you can have a pre-planning meeting, you throw it in there, and then it disappears in a hole for 12 weeks, and you don't know what's going to pop out on the other side. So I think that could help with getting more cost certainty, because you're going to have to design at a much earlier stage, which means everybody can get involved much earlier.
Paul?
Yeah, and just to pick up on that, like that's been mentioned a few times about bringing that level of design to an earlier stage. I think from a cost consultant and a QS's point of view, and what Rory was mentioning earlier, that risk involved in the cost not sort of delivering what it's supposed to. I think that needs to become a more live document, and those interim checks on where the cost plan lies needs to happen at an earlier stage and a more frequent stage, not just before planning and just before tender. It needs to become more integrated into the design approach. And I think that'll go some way to address the cost uncertainty. And just picking up on what John was saying as well, I think the PCSA, I was saying earlier, I'd be a relatively strong advocate of it. I think there's maybe a little bit of a hybrid model that can be approached there, and that PCSA isn't always restricted to one subcontractor. So I think obviously there's a cost element of inviting more than one to enter into a PCSA, but there's advantages there in retaining that competitive element. Obviously somebody has to lose out in the race, but if it means that until you get to that point, you're competing against somebody else, you're getting a little bit more comfort that you're not putting all your apples in one basket, or your eggs in one basket, I should say.
Thank you, Pat.
Yeah, I think to me it's one word, it's collaboration. I think that's the key, that's where we need to go. That's, we're bringing all the skills, the knowledge, the experience together. To pick up Rory's quotation, you need to understand the materials of your time. So if we don't understand the systems, if we don't understand the materials, the environmental impacts at early design stage, that's the key point at which we can really optimize the buildings, the outputs, the sustainability performance. So I think it's everybody coming together with the industry that in a way kind of conflicts with commercialism as well to a certain degree. So I think we need to find that model that brings us all together and that benefits the environment, and also I suppose benefits the financial sustainability that we were talking about for all players and for all stakeholders.
Ronnie?
Yeah, I just think to finish it, to wrap it up from my perspective is, there is lots of good subcontractors, there's lots of good specialist contractors, material suppliers out there. So we want to get involved early. We're there to be used. We've got a lot of knowledge and experience that we feel sometimes if we can bring that to the party earlier, even without any commitment, I think it can only be beneficial. And I would just encourage people to use that, take that opportunity up, and use us as the specialist contractors to get involved early and to inform some of the decisions. It will make the project easier later.
Thank you. Piers?
Yeah, it's very encouraging to see the sustainability aspect of what was brought today. The embodied carbon was something that I thought I think for most people it's down the line, it's the future, because it's not enforced at this stage, not fully anyway. But it's good that the industry is starting to look that way, because it will come upon us and we need to be ready for it. And in some ways steer the way that is measured and make it work in a realistic approach. In terms of the speakers, the manufacturers, the contractors and designers that are involved, it's great to see that we have that body of expertise and the direction things are going and how things can be measured. I suppose the technologist side of me was delighted to see that we can measure those kind of embodied carbon things like your colleague was showing. But as it was alluded to earlier on, the aesthetic side of it that we all know is probably the add-ons that are bringing carbon without necessarily delivering performance. We probably don't want to know about that, but it's good that these things can be measured. On the overall side of it, with the way deliverables are dealt with and the design process and procurement, it's we all know that there's kind of hiccups in the system that we need to get over. Like the early design stage is a very good point. The PCSA or a version of it that we can get involved with all of these stakeholders and optimize it, because we know, as Pat said, that the design for manufacture and assembly is very often redesigned for manufacture and assembly. We should be looking at how this is going to be assembled at the end of the day and be ready for it. You know, if it's precast panels or if it's a unitized system, prefabricated balconies, whatever it is, to kind of look with that view without standardizing buildings, but to kind of have that in mind, that everybody in the room and the fact that you've just shown up is a good idea, and more of this is a good idea, just to get everybody talking and working together. Collaboration is what it's all about.
Thank you, everybody. My summary for this is just to say that we need someone on the team who's looking out for what needs to happen at any one stage and bringing the skills to the table. That's all that's needed to steer the process. If somebody's looking out what is actually needed, we need some form finding, we bring form finding. We need some system design, we bring some system design. We need thermal or structural check on some components, we bring that to the table. Doesn't matter how you do it, as long as you do it. So it's just being flexible, knowing every project is different, the demands of every project are different, and I hope that answers the points that came from the floor. It's just being ready to accept the process is not a linear process. You can change it, you can bring the skills that you need, and it may not be in the existing team, you may need to bring it from outside. Thank you, everybody, for this discussion. Thank you for sharing your views on this, and thank you all for staying and listening to us. I hope we didn't bore you to death. There is a cold beer waiting outside, I think. I just want to summarize today as well and say a great big thank you to our organizers, the Zak team. Shweta is at the back. She was instrumental of pulling together our team of speakers and contributors, the rest of the technical crew and everybody who's contributed today. Thank you for today. From my side, I want to just remind you of two things. One is that there is feedback forms. I think it's on the website. Oh, right, you will get a feedback form sent to you. Please complete it and send it back, because it will help the organizers to do it better next time. And there is also, today has actually been recorded, so it's available to view at a later date if you want to view it again. But it will be recorded, and it is recorded. You will get a link so you can view it again or pass it on to others who probably wanted to view it. All that remains from my side is to say thank you for today and enjoy your evening.